insurance company where I see a bunch of interesting risk events happen.
Thanks, Ryan. We have an hour. Yes. Wow. I mean, there have been a lot of security incidents, so I guess we have plenty to talk about, but I just realized we have a full hour. Hi, guys. I'm Lane. Very excited to be here. I have been kind of steeped in hacker culture and hacker ethos since a pretty young age, kind of high school, 14, 15 years old, specifically kind of penetration testing, white hat hacking, ethical hacking, this kind of stuff. So kind of fast forwarding to the present, I was an Ethereum core developer with the Ethereum Foundation for a couple of years, and for the past 3 years have been working on a project which is a new layer 1 blockchain called Space Mesh, based on a novel consensus mechanism. So I currently lead R&D at that project and just generally kind of follow the security ecosystem very closely, contribute to kind of security response here and there, and just think deeply about it in the context of my work at Space Mesh. Nice to meet you all.
Hello, everyone. My name is Arun. I've been a full-stack developer and bug bounty hunter for a few years, and just generally like a very active DeFi degen. I was previously lead developer at a Web3 security related startup called Anti.Finance, and I'm currently head of research at Marana Ventures. And before crypto, I was a scientist in systems biology, where I did research in high-throughput protein sequencing.
And Tom Howard, who's currently stuck in traffic, is the founder of DeFi payments wallet, Monsindo, crypto options exchange power trade. He's an unreformed DeFi degenerate, angel investor, and he's now got a newly formed seed fund, Network Zero. He's working on building tools and infrastructure to support the network state concept that Balaji developed as sort of a successor to the nation state. So there's a whole bunch of security incidents that have happened in the last 3 years. The world was very different in 2019, and I'm sure we can all remember how things have changed. I think there's some broad categories that we're going to discuss of things that have happened, broken down by category, and then hopefully for 10 or 20 minutes toward the end, our views of how things are going to get better, because the current state is terrifying. Like I wonder how people who have very large fractions of their net worth in projects locked on chain sleep soundly every night. I certainly don't, and it's probably something that is not sustainable in its current level of vulnerability over time. So I think to start with, one of the things I've noticed over the past at least 12 years in the overall crypto industry is a lot of the vulnerabilities that we're seeing in crypto are actually old vulnerabilities that were either core internet infrastructure or fundamental to human nature. They're not things that are really novel and new to any of these protocols. They're a whole class of things. They're like insider threats, personnel issues, key management, leaky abstractions, bugs, versioning, things like that. So there's a whole range of things that we've seen that have really affected people. And I think some of the incidents that we can talk about clearly fall into that. I mean, there's a bunch that I can think of, but if either of you have any that you can think of that come off the top of your head.
Specific incidents? Or?
Specific incidents, and then the kind of vulnerability it was.
So I think it could be interesting, if you want to go this direction, to kind of do sort of a taxonomy, because there are so many different buckets. I mean, there's at least kind of 3 or 4 different buckets, and you touched upon a couple of them right now. Some of them are social engineering related, some of them are bugs in the code. Another bucket is multi-sigs, where kind of like your vanilla bridge exploit where one or more kind of keys were compromised. From where I sit, the most interesting of these is kind of low-level bugs in sort of low-level libraries that live there, that lurk there for years, and they're not discovered until the whole world blows up. So the most obvious and salient example of this is the Binance hack that just happened a few days ago, right? That was like a very low-level library, and it's kind of, in retrospect, incredible that it was there for years, and that code is used not only in the Binance ecosystem, but also in the Cosmos ecosystem, and Cosmos kind of got off very luckily in this case, because the vulnerability wasn't present there in the same fashion. I don't know, we could dig into one of these, or we could do a taxonomy, whatever direction you think is the best way to go. That's my favorite category of vulnerability.
Yeah, actually, just to jump on that point before we move on, Yeah, it's really important to realize that this code is very complicated and it's very new. Actually, Vitalik gave a great talk a couple of days ago talking about bringing rollups online. So I believe it was the optimism fraud proof. I think it was the get node actually. It's about 34,000 lines of new code. Any small bug in that code could lead to potentially billions of dollars being lost. So how do we bring these like very complex pieces of software online that are securing billions of dollars in kind of a safe and sustainable way? And yeah, definitely looking forward to exploring that question during.
Yeah, I'm happy you mentioned this. So like, I'll try to share a little bit about what the world looks like from the perspective of a core developer, right, who worked on Ethereum previously. You know, this is relevant in the context of my work on Space Mesh, and I think just any core developer. We have this notion of a TCB. TCB means Trusted Compute Base. And what it means is that there's some amount of code which is 100% critical to the functioning of the network, and any bugs or vulnerabilities or exploits inside the trusted compute base are kind of apocalyptic, right? They're kind of like stop the world scenarios, like many of the exploits we're talking about here. And this is not new to crypto, it's not new to Web3, right? This concept has existed forever. It's present in operating systems and things like this. But as a core developer, touching upon what you said a moment ago about kind of the diff, you know, looking at the changes that Optimism has had to make to existing code like Go Ethereum, or, you know, anyone building, let's say modifying or tweaking or adding on to existing code, like this is what keeps us up at night as core developers. We want those changes to be as small as possible, those diffs ideally to be on the order of like tens of lines rather than hundreds or thousands of lines, because every one of those represents a very real possibility of the introduction of a bug. Right? Another principle of computer science is that there's no such thing as bug-free code. Doesn't matter how good of an engineer you are, doesn't matter how good your software engineering practices are, there's some number, and you can reduce it, right? You can reduce the incidence of bugs by following best practices, which again have existed for decades, things like code reviews, pair programming, there's various techniques, but it can only go so low. I think Microsoft or someone did research on this a decade ago and found that the most senior, most experienced programmers are still introducing one bug for every 1,000 lines of code, period. One bug for every 1,000 lines of code. Go Ethereum is probably on the order of 100,000 lines of code, right? And let's say some of those bugs have been found, but there's still bugs there for sure. So anyway, just as a comment as a core developer, like this is literally what keeps us up at night. We want to minimize the number of changes, and that's very, very difficult when we want to add features and bells and whistles, you know, add new opcodes to our VM. What's another good example? A lot of blockchains are using WebAssembly as a VM now. This is actually what I worked on in Ethereum, this thing called EWASM, which was a candidate to replace EVM after the merge. WebAssembly is a whole complex ecosystem, and if we start putting WebAssembly-based smart contracts on chain, then all of a sudden the compilers and interpreters for WebAssembly are now inside the trusted compute base. So you've added 100,000 lines of code or something to your trusted compute base. So I'm jumping ahead here, but one potential mitigation strategy is to like really minimize the number of changes, the number of things you add, minimize the size of your trusted compute base.
On that front, I mean, the concept of a TCB is something that I read about in the Rainbow books that were the NSA's security guides back in like they were written in the 80s. So this is a very well understood concept in theoretical computer security. Unfortunately, it's kind of theoretical because a lot of systems, there's two classes of errors here. One, there's bugs in your TCB. Two, there's not identifying what really is the scope of your TCB correctly. There's a lot of the craziest things I've seen, like the Yuga hack, where a moderator's account recovery credentials for a Discord server were essentially used to cause like 200, like a crazy like multi-billion or multi-million dollar loss. It was like $200 million or something like that. Yes.
Uber hack, was it? There was someone. Yeah, there was. I mean, these things happen, you know, in all companies and all industries. But just your point about credentials being stolen. This is what happened with that massive. I think it was Uber, right? About a year ago or something. Someone got credentials of an administrator via social engineering, and then got inside the Slack and got inside, you know, yeah. So we have to be careful of this stuff too.
Yeah, this is actually happening in crypto quite a bit. Now mostly with Discord and Twitter. Actually, Zach XPT a couple weeks ago had like a really interesting Twitter thread talking about someone having access to an admin Twitter panel, and basically that was what allowed them to take over all these prominent Twitter accounts.
Yeah, I think one of the main issues is we're using essentially consumer tools like Discord, Telegram, Twitter, things like that for large financial applications. And the people supporting the applications that we're using are not building them for the use case they're being used for. They were built for gamers talking to each other about progress in a game and things like that. So expecting them to provide the level of security needed for a trillion-dollar ecosystem for security just doesn't make sense, and it's unfair to them to really blame them in any way. And we need better tools.
We need better tools. No. So it's interesting. I think I agree very strongly with what Ryan just said. The situation has gotten a little bit better. Pretty much everything has two-factor authentication now. And if you ask any CISO, any security expert in the world, what's the one thing you can and should and must do immediately to increase security, it's not only enable but force two-factor authentication on everyone. So it's a little better than it was like 5, 10 years ago, like when Discord didn't previously have two-factor authentication. Now they do, and I think it may even be on by default. But I guess I'm curious, I don't know the answer to this. Do we think that those tools that we use to coordinate, communicate, et cetera, need to be custom built? Or do we think that we can adapt existing tools to those purposes?
Yeah, I'm a big fan of not reinventing the wheel. If we could take from the, let's say, 50+ years of security research in Web 2 and adapt it to Web 3, yeah, that's no brainer. We definitely should do that.
Yeah, I mean, I think most of Web 3 security is actually Web 2 security, so these lessons have already been learned by enterprise users. I would go a bit further than just saying two-factor. I think we should be using single sign-on hardware keys that are not phishable. Like the whole concept of getting hacked because one of your emails clicks on an email and goes to the wrong URL, or is messaged something unsolicited on Telegram instead of Signal, or Telegram instead of Discord, where they routinely comment with someone, go to a URL that's a phishing URL, click on something, and then boom, you're out $500 million is crazy. Like that's the vulnerability of the system, not of the individual that clicks on a link. And the idea of mandatory phishing training for users is woefully inadequate for protecting these systems. If it's possible to have a button that you push right next to another button that you push every single day, and you push the wrong button and it destroys the world, like the problem is not the person pushing the buttons, the problem is the person who designed the buttons and put them there. So you really need to have single sign-on so you can revoke credentials for an employee. If an employee here, like it's very common to have a laptop lost in a bar or have a cell phone stolen, which might be unlocked and things like that, you want to be able to immediately revoke everybody's admin credentials. So I think essentially if you have administrative credentials for any project, which includes publishing to social media, doing any sort of action on Treasury, anything like that, and you don't have the ability to revoke those credentials remotely on loss in a single, like 5 minutes after the event is reported, you are making a big mistake. And if it's possible for a user to go to the wrong URL by accident or by phishing and lose their keys or use their keys incorrectly, you're also making a big mistake. So single sign-on and hardware-enforced key credentialing are the way to go. But luckily, the broader security industry has largely accepted that, and we now have things like passkeys on iOS, and we have like the FIDO2 ecosystem and everything else. So the key management in the traditional enterprise security world is getting a lot better. We also have great open source SSO tools as well as commercial tools. So that world is getting better, but the problem, one of the biggest problems with security is the attacker can find any vulnerability. The defender needs to be protected against everything. And you get a lot of cases where, I mean, everyone knows as a team, like you have a certain number of hours in a week for your people, and you want to spend your resources on building the product, because if your company fails, if your project fails, no one uses it because you don't have any features. That's also very bad. So if you have 1 hour to spend, you probably want to spend that on working on your product and not locking down security. So there's a lot of cases where the floor of security is not uniformly high enough floor. There's a vulnerability and things like that. So I think making tools better, making things secure by default is really the solution there.
So one thing I want to touch on with adapting Web 2 security practices to Web 3 is that one thing we have in Web 3, the in Web 2, is these systems need to be sensitive persistent. And that's like a very important factor. And that's one reason why MetaMask doesn't have 2FA. I mean, part of the reason is also because of the way EOAs work, and you can have multi-sigs with 2FA. But if you want like a non-custodial wallet built on top of the Ethereum platform, there is no real way to do 2FA on EOA. You have to have a smart contract-based wallet, which I think people are kind of moving towards in the future. But like one example would be, for instance, the Mango Market hack last night. people always say after these DeFi hacks, well, why don't you have, let's say, like some kind of circuit breaker, something that says, okay, if you're trying to withdraw $50 million from this smart contract, maybe you have a human being involved in that process. And one reason why we might not want to do that, and I say with an asterisk, because in the end, if any smart contract which has the ability for an admin deposit is not decentralized, so most smart contracts and most DeFi protocols don't really have a true decentralization as of yet, and I think that's probably a good thing at this stage. But I guess like, assuming that wasn't the case and the smart contract was truly decentralized, you can put a human being in that loop because that introduces a point of attack for regulation and a point of attack for other kinds of compromises, like you mentioned. So how do we do this in a way which is programmatic and sensitive persistent? So I think there are going to need to be some new design patterns in DeFi, and there's things you could do. Like for instance, you could, maybe even develop like an Open Zeppelin kind of like smart contract library that kind of like meters and says, okay, like you shouldn't be able to withdraw more than like $1 million worth of USDC every like hour or so. And I think that's fairly reasonable, although maybe for sample cases it might not be. And it also might be difficult to do in a generalizable way, given that if you have, for instance, Oracle attacks, the smart contract might not necessarily know what the value of the assets being withdrawn are. So you need to be careful about that code.
Yeah, I agree with that stuff. I mean, we're kind of jumping ahead a little bit to like mitigations and solutions. I'll just add one more comment on that, and then Ryan, you can steer us in one direction or another. But so, the title of this talk is Notable Security Incidents since Devcon 5. So obviously, we're talking past 3 years. A lot has changed in the past 3 years. 3 years ago, I would say best practices along the lines that you're describing were just emerging. They didn't really exist. We were still at that point struggling with basic things like reentrancy. And I think now we have a much better, what's that? We still are, yeah, we still are, this is true. This will be a thing forever. But we have libraries that you can include now from people like Open Zeppelin that protect against common classes of attacks like reentrancy. That's just one example. Basic things like not having ever a single point of failure, which is to say like a single key pair or something, right? And as he pointed out, externally owned accounts, which is to say just simple basic key pair based accounts in Ethereum are a single point of failure. You lose the key, you're hosed. There's no getting it back. So having multi-signatures, having cool-off periods or delays, right? Both for governance as well as anytime you're moving funds, right? Having tiers so that you can kind of move a certain amount of funds instantly, but something over whatever that amount is, requires a delay of 2 days, 3 days. I don't know if people are familiar with this, but the reason the DAO hack, the DAO of 2016, wasn't worse than it was, the reason that the white hat hackers were able to recover the majority of the ETH was because there was a delay, actually multiple delays baked into the protocol, right? So it could have been far, far, far worse.
Yeah, in general, you have the frequency of an attack, the potential value at risk, the amount that is actually stolen, which might be limited by all these other countermeasures, and then any sort of recovery procedures that are possible. And we've definitely seen a lot of progress in the last 3 years on both chain analysis and a lot of other... cool. Cool, great. Okay, so we've seen a lot of positive changes in the overall ecosystem where we have now some chain analysis tools. We have a huge ecosystem of security, audit, and infrastructure existing in the world. We have probably hundreds of audit firms, both coming from the Web 2 world and dedicated to Web 3 smart contract audits. So a lot of these vulnerabilities are bugs in code, and I'd much rather find a bug in code in an audit that I've just paid a couple $100,000 for rather than in the wild. We also have more of a culture of bug bounties and reporting. So if there is a bug found, I can legally make a couple $1 million as a bug bounty and be a good person and also build my own reputation, do it publicly, everything else, rather than just exploiting it and probably taking $20, $30 million plus in dirty money and being a horrible person and having to hide it and everything else, and no one learning from it. So there's a lot of positive changes that have happened. The counter argument to all this is just the whole ecosystem has continued to grow. So if a vulnerability affects 1% of the ecosystem, or if vulnerabilities affect 1% of the ecosystem, the total dollar amount and the total number of users affected just goes up as growth goes.
Yeah, just a couple quick thoughts to add to what Ryan said. The tooling that Ryan was alluding to has gotten really powerful. And a lot of it is open source, right? So like folks like Trail of Bits have multiple libraries, multiple tools that you can use to do inspection and analysis at various layers of the stack. And I would actually say, I wonder if you guys agree with this, simply running these open source tools today will probably get you more than you would have gotten if you paid 6 or 7 figures for an audit 3 years ago. So there's really powerful stuff. I mean, it's depends on your threat model. Like, it may not be sufficient. You should still do audits, caveat emptor, but there are very powerful tools out there.
Yeah, Slither is quite nice. One thing I want to say about the existing models is I do think they're fairly efficient. Like, I don't think that, aside from a few auditing firms that have very stellar reputations, like, let's say Trail of Bits or Daub, most times when I see an audit, I'm not necessarily thinking like, oh, this code is safe, because we've seen many times that audits are faulty. Like, there are humans reviewing human code. People can miss bugs either way. And the other thing about bug bounties is actually that the system is just not really working very well. As a bug bounty, I can tell you, ironically, it's often you make more money if you hack the smart contract and then hold the funds for ransom and then keep 10% versus just reporting the bug, which is just insane. But
so that's an argument for possibly increasing the amount. Like, there's a whole calculus of if you offer people too much for reporting bugs, then you end up with bugs get reported through that channel and possibly introduced, and you have a whole problem. As I used to do security contracting in Iraq and Afghanistan, and there was a concept of like paying people if U.S. forces caused a injury to someone or death, and there was a crazy, like, I would obviously say you should pay as large amount of money as possible, but if you make that amount too much, there was an argument that people would intentionally cause incidents just to get the bounty, which is terrible, but you have the same risk with insiders. Like, one of the whole categories that crypto companies do not address really at the level that traditional finance and everything else addresses is insider threat. You can have a team. If a team is a few people that have started a project together and have worked together for a long time, that's one level of trust. But if you've got a team that's hundreds of people, you're hiring people using like LinkedIn and whatever else, somebody joins, you don't really know what people's motivations are. They could be incompetent, they could be nation state affiliated, they could be criminal affiliated, everything else. They may introduce bugs intentionally and then exploit them. They may discover something in the course of their work and then pass it off to a friend externally who exploits it. There's all sorts of stuff like that. Traditional finance solves this by having separation of duties, so no single person would ever be able to have a vulnerability that would, ideally, that would be able to exploit things. But that isn't really compatible with an ecosystem where stuff is being built as you're going. You have a trade-off. Basically, you can build new stuff, or you can prioritize for extreme safety and resilience against this kind of insider threat. And I don't think it would be good for the ecosystem if we became so paranoid that we didn't allow innovation. So, yeah.
Ryan, our final speaker has arrived for your panel. Yeah.
Come on down. Welcome, welcome.
Sorry about that. Learning about Bogotá traffic this morning, getting DDoSed on the road. Cool, yeah, I'm Tom. I founded a DeFi product called Mosendo a few years ago, focused on DeFi payments. Also co-founded a crypto options exchange, which is a centralized exchange, so dealt a lot with custodial risk, and then have been an investor in the space for a while and just started a seed fund called Network Zero. So I've actually been following the Mango Markets hack, even on the ride over here. There's some interesting developments. It'll be interesting to get to at some point.
You can share mic with him.
And so one other point just before we move on was the interesting argument about decentralization. The Binance hack that happened a couple days ago, they were able to mitigate their loss because they were able to just stop their chain, which is crazy from a centralization perspective, but did save them $900 million. So that's the counter argument against proper decentralization.
Also, the hacker bridged some of that money into USDC, which immediately got frozen.
Which is a centralized stablecoin. So yes, cool. So yeah. Okay.
So actually, for that Binance hack specifically, I would argue that was certainly chain sovereignty is an important factor, and social consensus is an important factor of mitigating loss for sure. And that's something that, for instance, protocols which have strong bridges to Ethereum don't have, because if that Ethereum bridge is hacked, basically they have no ability to roll back changes on Ethereum to recover that money. But with the Binance hack in particular, the hacker had about 3 hours to wreak havoc, and he didn't. So that was almost like an issue of hacker incompetence. I think that Binance could have lost quite a bit more if the hacker was a bit more competent in that situation.
Yeah, one of the things that I think Tom's a particular expert in is a lot of the DeFi vulnerabilities, which in a weird way are some combination of software bugs and economic vulnerabilities. And figuring out exactly what's what in that space is difficult. The main value of having a taxonomy is because you can then identify trends and underlying risks and assess them. So I don't know if it's worth trying to figure out which of these risks are more economic versus more software bugs and how to mitigate those. But if you want to talk about some of the DeFi issues that you've seen over the last 3 years.
Yeah, have we gone over flash loan attacks yet? Okay.
Not yet.
Not yet? Oh, excellent. So I find that very interesting because it's like this novel attack that no one imagined. This has
It's not possible in any other ecosystem, right?
It's not.
Yeah.
And it's new since the last Devcon, right? Flash loans only came into existence in late 2019, early 2020, and then you had the first flash loan attack happen in ETH Denver 2020 in February.
Yep.
I remember the BZX team being quite excited about their product, and then that day they got flash loan attacked. And
I like to not assume a ton of prior knowledge. It might be worth explaining what a flash loan is and what a flash loan
sure,
attack
yes.
is, just as a starting point.
Okay, yeah. So flash loans are interesting, and actually, you probably only hear about them in negative context, but they're actually a net positive for the ecosystem. They're actually very useful. So flash loan basically allows you to borrow a nearly unlimited sum of money without having any money yourself. But you have to do it within a single transaction. So at the end of the transaction, say there's multiple lines that make up a transaction, you have to repay that loan at the end of it. So people use it a lot for arbitrage bots or keeper bots, liquidation bots. These keep financial markets in order because a coder who has the skills to run these things but not the capital to can use flash loans to, say, borrow $1 million to arbitrage a position across markets into place.
So I like to say that Ethereum's superpower is composability, permissionless composability, right? The fact that you can build a smart contract that calls into a smart contract, that calls into a smart contract, kind of ad nauseum, actually quite a few layers deep. And yeah, flash loans are just a form of leverage, right? So they allow you to pay a very small amount of interest. I mean, it probably amounts to thousands or tens of thousands of APY on an annualized basis, but because it's for the span of a single block time, a tiny amount of interest, and just jack up to a very high level, a very high amount of leverage, the amount of funds you're moving around and using in that single transaction, and that can flow down. Some of the most sophisticated flash loans, they touch dozens and dozens and dozens of different contracts. They go 20, 30 layers deep. It's kind of fascinating to unpick them as a developer.
Very. I just want to make a distinction between composability and atomicity, because you can have composability over multiple transactions, but the atomicity of a transaction is what is the key distinction here with flash loans. Arun, you wanted to say something?
Yeah, just to kind of like add a bit to that point. What's about flash loans from a protocol perspective is basically riskless. I can lend out any money from my protocol and get repaid back by the end of the transaction. It gets rolled back, it's not repaid. Basically, there's no downside to the protocol, and it makes the markets more efficient. But yeah, I think the issue is it provides like asymmetric ability for hackers to kind of wreak havoc. It's definitely like a very powerful tool. I remember at one point last year, DAI was considering having the ability for people to mint arbitrary amounts of DAI in a transaction and then repay it at the end of the transaction. And you can imagine just like what people could be capable of. They could just like mint a billion DAI and then repay it at the end of a transaction. That would be kind of insane. At least with the current flash loans, if the assets aren't in the smart contract, you can't use them. So there's only, if it's $100 million of USDC in a smart contract, I can only use $100 million of USDC. But if I could literally create like $1 trillion of DAI out of thin air and then repay it, that's a lot more dangerous.
Yeah. One of the issues is you could certainly do this with most of these exploits would be possible without the flash lens. You'd be able to, if you had a large pool of assets, exploit something that requires a large pool of assets to exploit it. But the set of people who have a large pool of assets lying around is much smaller, and it's very hard to move $100 million on chain anonymously, and then the whole chain of moving stuff to and from and everything else. So this opens up to potentially any attacker in the world can exploit one of these vulnerabilities, and not simply the people who have very large pools of capital lying around.
So the key to these flash loan attacks is that you basically have one smart contract system which is doing imperfect accounting on some other smart contract system. And when they're coding it, they think, oh, nobody could ever possibly have that amount of money to manipulate that imperfection.
They make assumptions, but those assumptions are not checked, basically.
Right. So after flash loans happen, I kind of view it as like the immune system of DeFi. Like if coders are taking shortcuts and they're taking these assumptions and being imprecise in their calculations, a flash loan attacker will eventually find it and exploit it. So it actually encourages people to be more responsible with their coding practices.
Yeah, and we were talking earlier about how much more mature things have gotten in the past 3 years since Devcon 4, basically. Or sorry, since Devcon 5, sorry, this is Devcon 6.
But yeah, I think it's like a fascinating category of attacks because they're not exactly bugs. Like code was kind of working as intended, but like, yeah, they were able to get like insane amounts of leverage. The other way that the flash loan attacks are commonly used is for oracle manipulation. So the most common attack is, say you've got some protocol that uses some asset as a collateral, and say that collateral it actually has very illiquid markets and maybe it's only one Uniswap market. So they can use the flash loan to just wind up that market to pump up the value of that collateral, deposit that collateral into, say, some sort of lending market, and then withdraw assets against the value of that collateral. And then they unwind that because they have to repay their flash loan, and so that collateral becomes worthless again. So that's been another common vector of attack, but that's been, there's ways to mitigate that with, instead of using just a Uniswap pool as an oracle, there's some proper oracle practices to fix that, but that's been quite interesting as well.
I just want to point out, this class of attack, if you want to call it an attack, is really interesting and really fascinating, but I think it's very important to make a distinction between this and other forms of security incidents, because I'm inclined to actually put these sorts of attacks, and I'm using scare quotes, into the MEV bucket, right? It's, as you said a moment ago, it's code working as it was intended, and this is not new. I have a background in high-frequency trading, right? We just call this arbitrage, right? It's people finding mispricings or, yeah, it's exactly like you said. When there's some sort of a mispricing or an assumption that's baked in at the interface, it tends to be at the interface of two different kind of systems or something, and taking advantage of that. I'm not sure I'd call that a security incident like an actual bug in core code or something. So it's important to make that distinction. And by the way, we should talk more about MEV because MEV is also really interesting.
This is why I've been using the word attack instead of hack.
Yeah, fair.
Let's talk about okay, cool. Yeah. I just want to make a point that, like more generally speaking, because smart contracts are immutable, when you write smart contract code, it's very unreasonable to imagine like I have to write this code so it's secure for the next 100 years against any future innovation that could possibly happen in DeFi. Like a lot of these smart contracts were written before flash loans, flash loan came along, people can exploit these smart contracts. So how do we get around this? Well, it's like really difficult, right? Because as we've seen protocol upgrades, sure the devs can be responsible and kind of upgrade that to protocol in response to like new developments, but there's still like money and assets in the old protocol that can't be withdrawn. And a huge class of attacks comes from people just like not being up to date on what's happening and not withdrawing their money from stale protocols. I mean, one very classic example was when the whole Terra Luna blowup happened. There were so many mispricings everywhere because everyone had some assumptions about the price of Luna on many different chains, because everywhere, and then people just wreaking havoc. I remember Venus Markets got hit pretty bad by that one.
Yeah, I think we see a large number of things where in the traditional security world you hear about like the 0-day versus the well-known exploit that's been out there. Things like the profanity key generator that, yes, if you were the first person, like one, you should have reviewed it. Two, if you were the first person to fall prey to that, yeah, that sucks. But everyone else who suffered from that and hundreds of millions of dollars lost after the well-publicized exploit existed and clear way to mitigate it existed, that is a failure to stay up to date on threat intelligence and act quickly, which is a problem of not knowing all the components of your ecosystem, like your asset inventory, and having a procedure in place for handling this kind of crisis.
I don't know if we want to get into that more because the Luna, not even exploit, the Luna threat was known for 4 years publicly, and people chose to ignore that, and some people weren't informed on that, but I don't know if it's worth exploring that, but
Yeah, I mean, a lot of very prominent folks among them, like investors, security researchers, were very vocal from months or even years prior about this class of economic attack, right? Because we're talking about an economic attack now. And in fact, there were warning signs, right? Because there was I don't remember the details, but there was an attack 6 months prior or something against one of the other coins or assets or something in the Terra ecosystem, and the price kind of depegged and then went back. So there were like warning signs ahead of time as well.
Yeah, what I found interesting, because I've talked to a lot of people about this incident because it affected a lot of people.
So can we recap the incident?
Yeah, sure. So
it is a notable security incident.
It is a notable security incident. So basically, this Terra Luna design protocol was basically, it had a mechanism to mint a so-called algorithmic stablecoin, where you burn the sovereign asset, Luna, in order to mint UST, which is supposed to be pegged to $1. And the idea there is that you'll always be able to redeem it for $1's worth of Luna, which then gets minted.
If this sounds like circular logic, it's because it is.
It is. So many, including myself, have been vocal publicly about the death spiral inevitability of this design. And I don't think anyone expected it to get as big as it did. But what I find quite interesting is that not only did, I would say, people who are less informed in the space, who it is not their job to maybe know better, okay, it's understandable that they didn't understand that would happen, and they were kind of sold a risk-free thing that wasn't risk-free. There was very professional traders and other people in the industry who also thought that this would not result in a death spiral. They thought it would work, and they were in it.
It's like looking for a perpetual motion machine.
Yeah.
It kind of keeps moving until it stops.
Yeah. So this was, I think, this was actually, I think, more example of like the hubris of success of the bull market, where everyone was like, oh, we've like solved impossible financial problems. We've solved the perpetual motion machine. It's going to work. It's working, and it got just like really big, and it was kind of just destined to not work. But
so something else that's new since the last DevCon, and this is actually the aspect of the Terra Luna situation that I find the most interesting. This goes back to composability, which we talked about before. It's the intertwined nature, right? It's that we have now assets built on top of assets, built on top of assets. And so when one failure occurs, right, 3-4 years ago, if something broke, it didn't cause this cascade effect throughout the ecosystem. And actually, in the case of Terra Luna, it was across multiple ecosystems, right? I mean, Bitcoin began crashing, and there's a whole reason for that. They had this Terra Foundation Guard treasury that held Bitcoin. They had to start selling Bitcoin to defend it. But this, what's the word for it? This contagion, the contagion that spreads throughout. Like, this is a new class of economic risk that didn't exist before. I think we need to understand it better because it will happen again.
Well, I think contagion has existed in TradFi for quite a while. People are well aware of contagion, but you have something like central banks to kind of like perhaps contain it and limit it, which arguably is not good for the long-term economic viability of TradFi markets, and perhaps it's better with DeFi for these to kind of play out and just kind of like, it's almost like a forest fire. Just let the fire burn everything and then regrow everything, versus just kind of keep these like sick trees alive forever like we have in Web 2. So one thing that I want to kind of touch on with the whole Terra Luna incident is, we guys already touched on it, it's this idea of like the illusion of like security, which was actually very dangerous. We had the LFG reserve, we had people like Jump and Delphi and many prominent people kind of saying, hey, we know about death spiral, we have it handled, we have $6 billion of BTC, we're going to buy everything, and it's going to be fine. And I think many people looked at that and said, okay, well, Jump has a lot of really good quantitative researchers. I assume they did that kind of modeling. I assume they ran the numbers, and we're like, okay, this is probably going to work. But it turns out no one knew what they were doing. So how exactly do we like mitigate this particular class of like issues? I think it's very dangerous when you have a situation where people know an issue can occur, and then people also think that other people who are very smart also know this could occur. And we see it all the time in smart contracts. Like, when Alameda jumps into a smart contract, I think people tend to assume that because they're in that smart contract, they've audited it and they know what's going on, they put $100 million into it, they probably know what's happening. But in reality, there's like several examples where Alameda is just yelled into a smart contract for yield, and there's been critical bugs in that smart contract, which is just kind of insane. And it just kind of goes to show you that, like, yeah, you really cannot rely on like reputation and authority in this space to make your decision making, and that makes things very difficult, I think, for the average person working in DeFi, because people who are not experts in these systems rely on experts, and those experts have been shown time and time again to not be doing proper due diligence on their own.
Yeah, there's a range of attacks that have happened where the system as designed was a good design, and even as deployed initially was a good deployment. There was, forget which bridge it was, that had 9 separate validators that they collapsed.
Ronin?
Ronin, yeah, sorry, Ronin, yes. Yes, they collapsed it down to smaller than the blast radius number, and
well, so there was four validators controlled by the foundation, and 5 were independent, and then there was basically it was a usability problem. So withdrawals were happening too slowly. So one of the, by the way, the 4 run by the foundation were like all on the same AWS machine. So they were basically one, and then they convinced a 5th one to give them like temporary permission to like sign for them. So basically 5 of 9 were running on one machine, which got compromised. Yeah, so that was like, okay, we started with good practices, and then like we...
I think the term is the normalization of deviance. It's a concept from like aerospace engineering. So one of the interesting things about crypto is, and a lot of people I talk with come up with the same thing, is if you're deploying an immutable smart contract, and there's reasons why you want to be immutable, protection from forced upgrades, malicious insider, everything else. But if you're deploying an immutable system, you're really in the same safety regime as aerospace, nuclear engineering, everything else, not something similar to normal software engineering. And you need to have procedures in place for that kind of ecosystem, where traditionally you have way more design work than you have implementation, lots of review. You have review of your review process, feedback on that, and it's very different than normal software engineering. And that's not really how stuff is built in the broader ecosystem.
Just super briefly, as a developer, to speak to this, this is really hard, right? Most of us, when I say us, I mean core developers, but also application developers. We don't have this background or this training. These practices have begun to spread a little bit through the industry, and we do now have folks contributing to projects like Ethereum who have backgrounds in things like aerospace. But we need way better education around this stuff. I really strongly agree with that.
To that point, and to an earlier point about TradFi, in the TradFi world, there's something called ratings agencies. This doesn't exist in crypto. In TradFi, you pay professionals to evaluate the risk and give it a rating of a financial asset, not even security-wise. There's also security ratings and certifications as well. But so we're missing that in crypto. There's no professionals that are actually actively monitoring even the economic risks of these various systems. The thing that DeFi has that TradFi doesn't have is real-time transparency and auditability. So if you look to the 2008 housing crisis, that was basically, a series of packaged and repackaged debt instruments that 8 layers deep, nobody could see through to what the underlying was, and they just trusted that the ratings agency that gave it an A+, that everything was A+. Turned out there was a bunch of F through A debt within that package, which caused people to basically buy risk that they didn't know they were buying. With DeFi, we have that real-time transparency, but what we're lacking right now is basically professionals that evaluate that risk and give ratings on it or give metrics on it. So I'm seeing the beginnings of that happening. I'm seeing a couple of projects that are focused on becoming this risk oracle, risk engine. So I'm excited for that in the future because we will combine this transparency in DeFi with the various ratings mechanisms or risk evaluation mechanisms that are coming out.
Massive, massive, massive opportunity. Seriously. Anyone out there who's interested in this stuff, who has a background in finance, who's inclined, this stuff is sorely needed, and there's huge lack of this stuff in the market today. It's a huge opportunity. Like, work on it, talk to us. We'll help you make sure you're talking to the right people.
Yeah, Actually, funnily enough, like
Talk to him.
Yeah. So Anti, which was the project I was previously dev on, is essentially trying to do this in a decentralized way. I think that one of the issues with having kind of like centralized risk auditors is the fact that they are fallible. I'm not saying decentralized risk auditors are perhaps better. It's just the entire system as a whole, I think, is fallible to some level of human error. And any kind of appeal to authority, I think, is kind of dangerous. I mean, just because we have Moody's at this B rating doesn't mean that TradFi is immune to like contagion and stuff like that. Like, I mean, it definitely isn't. Like these companies, I guess like the thing you have in TradFi, you don't have in DeFi, and sorry, I'm kind of rambling a bit here, is you have this kind of like fail-safe mechanism, the central bank, which is able to kind of rescue everyone in case everyone gets a bit out of control. And I am not sure if like Moody's makes things like that much safer. It's probably better than having nothing at all, but it definitely is not like an ideal solution, and it probably is not going to work that well for DeFi where we have no safety net. We probably need something a bit more robust.
So the big problems with rating agencies is that they don't have any skin in the game. Right. So what I'm really bullish on is insurance and other types of systems where they're underwriting the risk rating that they're giving. So there's lots of different ways you can do that, whether it's with a regular insurance company, which is what Evertas does, or various DeFi mechanism designs. This is something that I've researched very deeply, and seriously, if anybody wants to work on this, come talk to me, because yeah, I'm aware of some very interesting things there.
Yeah, we do underwriting for a lot of problems for technical risk, projects for technical risk and things like that. And the problem of how much can you trust a software audit or a software security review. Auditors actually hate the term audit when applied to their work product. But how do you trust different firms? And honestly, every firm I've talked to can do great work. The thing from an insurance and a reliance perspective is you really need to look at the worst work that they'll pass and make sure that that is high quality, because if you're going to just blanket trust the security review performed by a firm, you really care about their internal quality control process and knowing that if it's a new system where they're not already expert in it, or where perhaps they don't have, they're very busy. One of the biggest problems in the security review industry is it takes 3 to 18 months to get queued up for a security review at a lot of these firms. And as a result, there's a huge pressure to ship and then get your review done while it's in production, or get your review scheduled before you're finished building it, in which case you haven't reviewed the system as it's deployed. So one of the critical things that we absolutely as an industry need to improve is better tooling, but also more security professionals in the industry so that we can do more of this stuff in parallel, because every project out there needs to have this work done, and it's a contended resource. And you absolutely want to be one of the ones that gets a security review and not one of the ones that's waiting while you get popped.
I don't know if we want to touch on something that we've kind of uncovered, which is that technical auditors are basically expected to take on this role of doing an economic audit as well. And they're actually not the best people to do that, right? They've categorized the known economic attacks, but for instance, the Mango market attack, which just happened yesterday, was a blatant financial Oracle manipulation attack. They manipulated, if you're not aware, Mango got drained for about 100 million. The attacker increased the price of the Mango asset by manipulating the price of Mango across various markets, and then borrowed better assets than Mango against that unrealized position. And like a technical auditor could have looked through the Mango code, and the Mango team is super smart. And you know, everyone involved like is knows what they're doing, but like this is a very weird edge case that somebody with a financial risk perspective would have been the only one that would have caught that.
Just to be clear, there are folks who specialize in the financial side of things. So shout out to Gauntlet, shout out to Block Science, right? They have tools, they're experts in this, but those are the only two I know of, whereas there's dozens of auditors who are, like you're describing, technical auditors who I think would not have the sophistication to catch this category of bug. So again,
they're expected to.
Yeah.
Yeah, so one thing touching on the economic audit, I do know some auditing firms that now do this kind of auditing separately. And actually there are, like for instance, Compound and Aave will retain people to do ongoing economic audits. And I think it's very necessary to be able to adjust the parameters of your protocol in some kind of decentralized way, of course, to adjust for the changing kind of parameters of like what's actually in that protocol. Because otherwise you end up in situations like, for instance, Mango Markets. If you're not aware, this is a very capital-intensive attack. It took, I think, around $5 or $10 million of the user's own capital to do that attack. And the thing is, like, I think most people looking at Mango Markets are like, oh, this protocol has $10 million in it when it was audited. This Oracle attack is going to be very expensive to pull off. It's not worth it. Once it has $100 million in it, suddenly this Oracle attack becomes very viable. So you actually need like a real-time update of these parameters over time to maintain the safety of the protocol. And that's something that's kind of missing, except with like kind of like a tier 1 or S tier protocols in DeFi right now.
Yep. I'd say another interesting thing that's happened over the last 3 years is the rise of the consumer NFT space, which is bringing a lot of new people into the space that really are, they're from an art background. They're not people who are software engineers in a lot of cases who think about systems failures. Even if they don't think about it from a security perspective, they think about software bugs. So there's a lot of people who really don't have the background or the experience to know what to be afraid of just sort of like naturally. And we haven't built as an industry the right tools to make it safe for people to do things without understanding all the details of how it works. Like there's a lot of people who drive cars who don't know that much about how airbags work and seat belts and everything else. They just know if you do it, you're probably okay within certain parameters. We are nowhere near that level of professionalism and reliability in the space. And we'll see all these people that are new to crypto because they've come in through the NFT world, and they fall prey to the same issues that happened to early regular crypto users 10 years ago and are largely mitigated by community knowledge and tooling there. So it's kind of scary that there's the high end of these DeFi vulnerabilities, which are new classes of attacks, but some of the most basic things are happening to a new class of users right now as well.
So I think a notable security incident along these lines is like owners of Bored Apes revealing their private keys to social engineers on their Discord and losing their apes. You know, I think you're right, Ryan. I think like it's incumbent upon us as designers and builders in this space to like build better tools and install some of those safety rails or airbags like you're talking about. But I just want to highlight that as someone who thinks deeply about this and has been working on this for years, there's a tension here, right? Because the easiest way to install safety rails is centralization, right? Is to say, yeah, you know, for my grandma, like maybe she's not going to really effectively manage her private keys. Maybe she's not really going to understand a ledger or a multi-sig. So maybe the best thing for her to do is keep her crypto on Coinbase and outsource custody to someone else. And that, in some respects, is antithetical to like the whole reason we're here. So there's no easy solution to this, but I just want to highlight that tension, and that's where I approach this as a protocol engineer and as a developer.
Yeah, I think kind of a good balance between this is that the base protocol should always stay true to like the tenets of crypto. It should be decentralized, censorship resistant, permissionless, all this stuff. So people can build what on top of that. And I think that it's kind of on us to educate people on the right way to onboard themselves. Like grandma should not be probably creating a MetaMask wallet. I think that's generally something that is difficult to secure, I think, for the vast majority of people. And in the current situation, as we see with the NFT space, that like there's no way we can onboard 1 billion people into crypto with the current state. Like people, like it's just going to create like a feeding frenzy for the piranhas that are constantly looking for ways to steal people's money. So we need to figure out these more robust wallet systems for these people, and I think that's probably a better compromise. We onboard people through like, let's say, account abstraction wallets or some kind of like non-custodial wallet solution with the hypervisor protocol layer, which manages signing and policy networks, and then we keep kind of like the more bare metal, like quote unquote riskier, but more permissionless wallets for people who need them.
Yeah. But one of the things that scares me is, while these losses might be relatively small dollar values relative to the larger DeFi protocol hacks and things like that, the number of victims is very high, and politically, if you have a lot of victims that individually, like a loss event of any kind, and it makes it very easy for regulators to point it at like a grandmother who's lost something, or an otherwise unsophisticated user who fell prey to some system, or possibly was scammed and then pushed for regulation. So we have the centralization risk the potential to use centralization as a countermeasure to a lot of this stuff is a risk of centralization, but also acquiring a very, very bad public relations nightmare as well as regulatory nightmare is also an existential threat to the overall industry.
Cool. Do we want to open up for Q&A?
5 minutes, yeah.
Yep.
3 minutes, okay. We have time for a couple questions. Anyone have any questions?
How are you? Excellent call.
Bueno.
You talked a little bit about account abstraction. So I wanted to know if you could talk a little bit about that, because I think that it's like the solution to have like easier custodial systems without depending on, I mean, self-custodial systems without depending on centralized entities. So what do you think about that and how we are advancing? And when do you think we will be able to have that for the general public?
So I think there's like two classes of account abstraction. So just to define the term very generally, account abstraction is essentially when you make no distinction between smart contracts and individual wallets. On Ethereum right now, individual wallets are fundamentally different than smart contracts because individual wallets are public-private key pairs. Smart contracts are derived very differently, and I don't necessarily have time to go into that right now. But in account abstraction, they're basically the same. Smart contracts, individual wallets are smart contracts, and we have the ability to do that right now with things like multi-sigs, which obviously are somewhat fallible. And in the future, we may eventually end up doing away with the distinction entirely. So people with rollups were trying to do that, but eventually ended up deciding not to because making these kind of protocol level changes just made it very difficult for Ethereum developers to kind of compose and build on them. But the nice thing about account abstraction is the design space is very wide. People could do things like multi-sigs, they can do things that are much more complicated, like have like off-chain oracles and involve human beings in the process and do basically kind of the sky is the limit in terms of what people are kind of building here. One interesting project that's kind of, actually never mind. Yeah, sorry, that's not quite a, yeah.
So we built this for Space Mesh, okay? We built account abstraction. I think we may be the first layer one, maybe the second. Near has something similar. It was really, 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 really hard. To your point, it had very deep, profound implications and ramifications on the protocol. But it's a very powerful primitive, and it means that the really simple way to think about this is every account by default is a multi-sig, and there's always multiple keys associated with it. Again, this is also the case in Near, so shout out to Near for kind of like pioneering some of this work. It's a very important primitive, and I think it will go a long way towards addressing some of the kind of classes of attacks we discussed here. One last question, maybe? We have time for one more?
Last one.
So I would like to ask, which security incidents, in your opinion, was the most impactful, not in terms of value lost, but in terms of sending ripples across the ecosystem?
Which was the most impactful? Not necessarily in terms of the assets, but like on the overall impact on the ecosystem. The first one that came to my mind, this actually touches upon a point that Ryan made a moment ago, which is that it's not necessarily, as you said as well, about the total amount of funds, but it has more to do with the number of people impacted and the sophistication of those people. There was a hack in a Solana ecosystem wallet about 4 or 5 months ago. Does anyone remember the name of the wallet? Slope wallet, thank you. And what happened here was a bug in the wallet that exposed the private keys because of some telemetry kind of tooling. Very common, I think it was called Sentry or something. I think we actually use it in Space Mesh as well. And the reason that I find this one so impactful is because this was, the actual total number of funds was very small, and I think it was $8 or $10 million worth or something, so it was like maybe even less than that. But it was thousands of users who were impacted, and each of them had a very small amount of money in their wallets, and they woke up one day and their funds were gone. That, I don't think, has ever happened before, that particular class of attack, and everyone was panicking, and no one knew. Yeah, it was a very scary attack.
Yeah, and even scarier about that is no one knew which wallet it was, because a lot of people were reusing seed phrases across multiple wallets, so they thought it was a Solana base level vulnerability or something. It wasn't even localized to a wallet. It was very scary watching that in real time.
Just PSA, because apparently it needs to be said, do not log private keys into your logger.
Yeah, and also use hardware wallets, okay? This class of attack is not possible with a hardware wallet.
That too. I think probably the most impactful on the space has been the combination of the UST collapse, which led to the 3 Arrows collapse, which led to an entire collapse of the crypto credit markets and has really raised a lot of red flags with regulators. Like, we've seen a lot of regulatory pushes because of that combination of UST and Three Arrows. And that has impacted a lot of non-crypto native folks who are sold a risk-free USD interest rate. So it did happen to be a large dollar value, but it's having heavy political ramifications.
For the final remark, Aaron.
+1 for UST.
+1 for Solana.
Yeah, thank you. This was really, I learned a lot. I hope you guys did too.
Thank you very much to everyone else on the panel.
Give it up, people, for Ryan, Lane, Tom, and Aaron. So, and if there's anything to take away for your own projects, remember $1 per 1,000 lines of code. I'd like to call forward Shrey Jain with the longest workshop title of the day, Working Towards a Plural Public via Common Knowledge and Designated Verifier Proofs. Give an applause for our next speaker, people.
Not working? Now it's good? Okay, perfect. Okay. All right. Yeah, about a month ago, I was at a dinner with my parents at an Indian wedding, and we were eating the food, but there were no napkins on the dinner table. Not a big issue, but if you've ever had Indian food, you know that your hands get really messy and you need to have a napkin. And as we were looking for a napkin, asking the wedding venue staff, we saw that the wedding party was getting really mad that there were no napkins in the venue. And there was just a lot of emotion and anger being expressed at the time. A week later, I was with my dad at a coffee shop, and we see this guy getting really mad at a barista. And I said to my dad, and I said, napkin. And because we had this shared experience of being at the wedding previously, and we shared this context of what napkin meant, not something that you traditionally label napkin with, but something that we shared this context with, I knew that he understood what napkin meant. And I had this feeling that I could actually encrypt the word napkin in the physical world and only have the people who could understand it be the ones who were there for that experience and shared the context. And I could actually draw this boundary around who would understand it. And so I wanted you all to think about some of these dictionaries that you may share with your friends, your family, or your coworkers that may consist of idioms, symbols, or these inside jokes that let you communicate incredibly efficiently with one another. But not only do they let you communicate efficiently, they actually have a boundary on who understands that dictionary. And so if you've ever studied information theory, you may have heard of what's called the source code theorem. And there's this concept called Hoffman codings. And what Hoffman codings do is they let you take all the information that a computer needs to read and collapse it down into the minimum number of bits necessary for that computer to process the information. Well, with these dictionaries that you build with your friends, your family, and your coworkers, you can also communicate incredibly efficiently with anyone who's inside of this boundary. And anyone outside requires much more context to interpret what you're saying. But this doesn't just apply to inside jokes or idioms, it applies to things much larger. Like, let's look at the field of medicine as an example. So, of all the medical literature that exists in the world, Columbia has said, let's take all this literature and collapse it down into a set of texts that Columbian medical students will need to know. And so long as they know this literature, then they can communicate with one another and potentially, among other assessments, practice medicine in Columbia. And so if I go up to a physician in Columbia and I say cardiac endocarditis, I know what they know, that cardiac endocarditis means something in the medical terminology. And anyone outside of this field may require more context. But does speaking this language or having this terminology allow you to be part of this group? Well, no. Like, if I read all this medical textbooks, it doesn't make me a doctor, nor does reading the Bible make me a Christian, or reading legal textbooks make me a lawyer. But what these texts are very powerful for is they let you communicate incredibly efficiently with people who are inside of these communities. And so another problem that you may see is, like, let's put 3 scientists on a panel, a biologist, an economist, and a sociologist, who are all aimed at talking about how to solve climate change. And they each come onto this panel with each of their own dictionaries, with each of their own peers. And what ends up happening is you end up getting the most high-level, abstract communication possible, and we lose the richness that comes from each of these cultural communities. And so what I've tried to do in this brief introduction is introduce some of the primers to the concepts that we'll be diving much deeper into the rest of this talk, like context collapse, common knowledge, and boundaries. And this work is titled Plural Publics at Microsoft, and is joint work with Glenn Weil, York Rhodes, and Divya Siddharth. And I hope by the end of this talk, we'll have a very tactical approach of how to build systems that can achieve common knowledge, protect boundaries, and also rebuild the context that we've lost in communication. A lot of this work is influenced by some of the early thinkers like John Dewey and Walter Lippmann, who've talked a lot about the plural publics, as well as what it means to have informed decision-making. Dana Boyd from Microsoft Research, who's talked a lot about context collapse. And I've had the pleasure of working with Joseph Halpern from Cornell, who's done a lot of the early thinking on distributed systems and common knowledge. And so when we talk about pluralism, there's many different axes of pluralism. There's one that felt most right to me as a builder is how can we build systems that facilitate cooperation across social differences. And so the way that I'm going to structure this talk is we're going to first focus on cooperation, and then we're going to tie it back to social differences at the end. And so at the beginning of this talk, I said something like, I know that they knew what napkin meant. And so what was I trying to say there? Well, there's this concept in game theory, psychology, and computer science called common knowledge. And a fact is said to be common knowledge if everyone knows that this proposition is true. Everyone knows that everyone knows that this proposition is true. And everyone knows that everyone knows that everyone knows that everyone knows that this proposition is true. And when I first read this, it didn't make much more sense to me as to what common knowledge was. And so let's walk through a quick example. So I want you to imagine we have two generals here, a general on the left called General A and a general on the right called General B. And their goal is to attack in the valley of this mountain in a coordinated way. And the only way that they can communicate is through a messenger. And this messenger has the possibility of getting lost in this valley. And so let's say General A says to General B, let's attack at 6 a.m. Do they attack? No, because General A doesn't know that General B got the message. Let's say General B acknowledges the message. Do they attack? No, because General B doesn't know that General A got the acknowledgement. Let's say that General A acknowledges the acknowledgement. General A doesn't know that General B got the acknowledgement of the acknowledgement. And so what I'm trying to showcase here is that if a messenger can get lost, we're unable to achieve systems that can attain what's called common knowledge. But maybe we don't need common knowledge. Maybe we need something as close to common knowledge as possible. And that's often referred to as what's called common P belief. It's a as close to form of common knowledge that we can attain in systems where communication is not guaranteed. And so let's now relate common knowledge back to these concepts of coordination and cooperation. So coordination is when you have a set of agents take action simultaneously. Cooperation is when these agents take action simultaneously, but also understand the payoffs that come with these actions. And so cooperation studied in economics and psychology has been broken down into two key subtypes, altruistic cooperation and mutualistic cooperation. So altruistic cooperation, which is a fascinating topic to psychologists, is when I incur a cost at myself to the benefit of others. And why would we do this? And so we've been studying these concepts of emotions that relate to reciprocation, like trust, empathy, gratitude. And we don't probabilistically measure these emotions. We can categorize them. I don't trust you with 20% accuracy. I either trust you, I don't, or I really trust you, or I really don't trust you. And humans are able to categorically depict these set of emotions in these categorical ways. But mutualism, what I think is what we often talk about in the Web3 ecosystem, is when I take action, you benefit, but so do I. And this problem is not as much of an emotional one related to trust or gratitude. It's much more related to what's called an epistemological problem. How well can I measure someone else's knowledge? And in a lot of the psychology and research, both empirically and theoretically, we've seen that not only can humans categorize emotions, but we can also categorize these levels of knowledge that people have. So in an example of this, I know that I sent you a message. I know that I sent you a message and you got the message. I know that I sent you the message, you got the message, and I know that you know that I sent you the message, all the way up to these rich forms of what we talked about earlier being common knowledge. And in these experiments, it's in the physical world that people have run, it's when people have common knowledge, the most rich form of knowledge, that the probability of taking action is much higher and everyone benefits in a much richer way as well. Okay, so we've talked nothing about Web3 so far. We're going to get there, I promise. But what we've highlighted so far is that common knowledge is a critical component to cooperation. Let me walk through a brief historical explanation as to why we lack common knowledge today. So we talked earlier about the common P belief and why we lack it in the coordinated attack problem. And I'm going to work through two key axes of communication right now, one being knowledge and the second being privacy. And so when we communicate in this physical world and I have a messenger, privacy is not guaranteed. This messenger may go and leak the message. They may not say the message in full. And so privacy lacks. And my common P belief, as we saw earlier, is weak. We then move to forms of writing, where at least I know whatever I write on this sheet of paper is going to get sent to that person. But it still doesn't solve these problems of common P belief or leakage. And after 50 years of the envelope being used for packaging gifts in Japanese culture, we finally found ways to use it to package messages. This improved privacy, but still didn't improve the way we communicate for common knowledge. I'm going to skip through forms of radio, telegraph, and move to the ways we communicate today, like SMTP for email, SMS for texting, or XMPP for WhatsApp or Telegram. We can achieve these forms of common P belief, but they're actually quite hard to do in an interface level, and we'll explain why in a second. And as we've seen in a lot of these centralized settings, we still lack the privacy that we want to achieve as well. And so my question now is, where does a distributed ledger play a role in all of this? Or distributed ledger being the key word here. Distributed ledger does not imply blockchain. And so where we've kind of come to in this setting, and if you've been to a lot of the talks today, clearly there's something going on with the relationship between zero-knowledge proofs and blockchains. It doesn't mean that you need ZK to work with blockchains. You can do it without. But there's a rich ecosystem of innovation going on there. Where does communication play a role with distributed ledgers? And Joseph Halpern, who laid a lot of the work in distributed ledgers, has said that if we can satisfy two key properties of a distributed ledger, then we can achieve weak forms of common knowledge. The first being what's called T-consistency, meaning a prefix of my ledger is a prefix of your ledger. And the second being what's called delta weak growth, which means that within a time delta, I can add some information to each other's histories. But let's make it much more clear. Like, what exactly will distributed ledgers play a role in the next step of human communication? Well, the first is that they actually are easier to build an interface on to achieve common P belief, and we'll show why that's the case in a second. And the second is that we can actually provide a commitment to knowledge when we communicate. So an example of this at Microsoft, what we did is we switched the way we communicate from emails and Excel spreadsheets for our supply chain and started to use a blockchain. Because at every step of the inventory process, we had common knowledge about the inventory, who was where, what was where, and everyone knew that everyone knew that everyone knew. We were able to save a lot of retroactive issues that we normally face. And in fact, this led to a savings of $50 million a year in one of our many supply chains of our Azure stack. What are other examples of where we could use this? Well, we could use it for reporting for social action, social movements, or reporting on sexual assault cases, whistleblowing. Whenever you need to have these coordinated attacks, and it's really important to have common knowledge, it's protocols and distributed ledgers that do this in a really nice way with these two properties that I commented on earlier. And the second part is that blockchains, today in communication, we lack a commitment to knowledge. Communication is very accessible, very free in a way that is good, but also with cooperation purposes leads to an extraneous amount of communication to get something done. What's really interesting about what's being explored in the Web3 ecosystem is how we can program these commitments in the way we communicate. And so there's a protocol that was a while ago called Ethereum Whisper. Some of the core team there went and built this research project called the VAC P2P network, where they reveal part of the vector on an elliptic curve from your public key to your private key as you start to send messages over a threshold limit to prevent spam. And so there's an actual programmatic commitment that you make with every message you send. We're starting to see community currencies or tokens with regards to governance play a large role. And how can we use these tokens to stake when we want to communicate with regards to cooperation purposes? Okay, so what have we said so far? Clearly, common knowledge is a requirement for cooperation. If we want to cooperate, we need to do so in a very rich way. And we've walked through this historical example. And now we can see why there's a case where we might want to explore with distributed ledgers to communicate for cooperation. So now we got the cooperation box checked. Let's now figure out how can we do it across different sets of people. But if we want to cooperate with another individual, the first step is being able to recognize who Who are we cooperating with? And in the Web3 ecosystem, decentralized identity is its own suite of problems. So earlier this year, we put out a paper that tried to exhaust a lot of the work being done on the decentralized identity frontier. And we looked at different primitives, and we looked at what needs to be done to identify an individual. What becomes even harder is how we identify a set of individuals. How do you put a boundary around a group of people? And so let's talk a bit more about why we've lost boundaries today in the way that we communicate. So in the past, we had these very rich forms of tribal dynamics, whether it was literally we were part of tribes or it was religion, and we had a very clear sense of who was inside of a group and who was outside of a group. And these strong tribal bonds were quite good with respect to communication, communicating quite efficiently, and we understood each other's dictionaries quite well. But these tribal dynamics were quite oppressive to certain subgroups, and so we started to find ways to liberate these individuals, but some would argue we've gone so far so that these individuals now feel lonely, alienated, and are communicating on systems that try to rebuild these bonds, like social media platforms, that have done so in a way that lack context. And so what is context here? I'm communicating to this invisible audience that lacks the context to understand the dictionaries that I communicate with my peers. And the thing that we lack in communication today is collective disclosure. We talk a lot about I choose to disclose, I disclose this, I do that. We don't have enough of we collectively can do things with strong guarantees. So now let's talk about some tools that we can use today to go and do this. So I want to introduce to people, if you're not familiar with what's called designated verifier proofs, there are a set of proofs that say instead of proving X, Alice will prove the statement either X is true or I am Bob. Again, it's one of those things that takes time to sit with, so let's walk through an example to make this much more clear. Let's imagine we have two DAOs, the CIA DAO and the KGB DAO. And the goal of these DAOs is to prevent a double agent problem. So meaning that I don't want my agents, if I'm the CIA, to be spying on myself for the KGB. And the KGB wants the same things happening for them. Let's develop a scheme that makes this much less accessible to the agents. So let's say I'm the CIA and an agent wants to go and turn on me and I'm unaware of this and they want to go to the work for the KGB. So agent A goes to the KGB and says, hey, I'm part of the CIA and I want to work for you. Naturally, what does the KGB need to know? They need to validate this information. It's very critical that they validate this information with high validity. But we want to mitigate the CIA that this agent can go and do that. So how do we do this? So we're now going to walk through the designated verifier proof scheme. We're not going to go through the technical details here, but if you want to, you can come up to I and someone who I'll introduce in a minute. But the way that this works is we have two inputs. The first is that the CIA DAO actually makes the claim, Agent A is part of the CIA. And so they have this registry that exists of all the agents that are part of the CIA. And so they can pass it through this circuit and signing it with their private key that they're part of the CIA. The key thing to recognize is that there's an OR gate here. And so this constraint can be satisfied by either the CIA actually making this claim, or Agent A's private key can also make this message. And so let's walk through why this is so important. So again, the CIA can make this claim, or two, the Agent A can make this claim, and we won't know which one it is. But Agent A knows that the CIA doesn't have their private key. So if this circuit satisfies with the output of 1, then it must be the case that the CIA made this claim and Agent A is not lying. And so to a third party, they don't know who made this claim, whether Agent A is lying or the CIA actually said this message. So the only person who's persuaded by this information is actually Agent A, because they know the CIA doesn't have their private key. And so what's the bigger part of all of this? Well, you can't ever prevent someone from sharing information, but you can prevent that information from being persuasive in its shared form. So we can mitigate the belief that this has in its shared form. And so what we start to move towards is what's called collective disclosure. And so let's work through a much more Web3 example of this now. Let's say that I'm a DAO, and we have a secret that we want to keep within the DAO. DAOs today are quite leaky. We lack systems to communicate and put boundaries around communication. And so I tell a secret to each of the members of the DAO. I say, hey, we have a secret, but we want to make sure that the integrity of this information is withheld with very strong guarantees within this DAO. And so we issue a DVP to every member of the DAO with this secret. And let's say, for example, here, Agent C wants to go and communicate this to another DAO. But because we issued this through a DVP, that third party won't be persuaded with high guarantees to that information. But now let's say we want to collaborate with another group. What we can do is we could have some internal proposal to say, hey, Do we want to share this information with Agent D? If so, let's issue a DVP again with our wallet and have Agent D be part of that claim. So now Agent D is persuaded because they are part of the designated verifier scheme. So I also want to credit here Enrico Potazzi, who's here and works for Polygon ID, and we worked through this and built some open source tools that allow people to go and build these schemes today as well. And so what we've tried to highlight in this talk is that we have systems that can be built to achieve common P belief, but they're not as attainable as they are on distributed ledger technologies as we've started to see. And we want to keep experimenting on that. The way we've tried to rekindle these bonds between people to build and refix context collapse has been quite weak. And we need boundaries so that we can have these forms of intelligence and collaborative work across communities. And so some experiments that our team wants to run with the communities is let's go and build a protocol where every claim for a DVP, every claim within a DAO is issued through a DVP. So we can start to have some structure and maintain the integrity of information within DAOs. Let's play with other commitment schemes with community currencies or revealing vectors on an elliptic curve for how people commit to knowledge. Let's also build tools for anonymous reporting, where if I want to come forward about a case, I can do so in a way that, first of all, can leverage zero knowledge technology, but also attain common P belief, so I know that other people are also going to come forward, and they know that I will come forward, but do so in a very protected way, where we have a boundary around these claims via DVP. And this can apply to things like social movements as well. And so what I've tried to walk through in this talk is that there's something clearly quite powerful about blockchains, but none of this had anything to do with staking, currencies, DeFi. It was literally all about achieving knowledge. And I think there's something really interesting about these cryptographic primitives and something quite powerful, but we've yet to understand how we can interweave these primitives with the value that cultural communities can add to the community. And so that's some of the work that we're trying to be building and working with the community to do that. And so thank you.
We have a few minutes for Q&A. Are there any questions from the audience? Don't be shy. Yeah, in the middle over there.
What has been the process for connecting with communities?
Yeah, I think right now, because it's so early, the work, it's been, I think Enrico and I only released a lot of the DVP stuff in the past 2 weeks, so it's been small outreach to the communities that we're part of, but part of being at Devcon was like reaching out to DAOs here and talking with them to see, is there an interest in working with these DVP schemes? And again, I think part of even me speaking here today is to have the audience or people who watch the recording to come and work and find us, to find ways that we can just be of value. All of the work we're doing is in open source, and so the goal is to just see how some of these ideas can facilitate some of the outcomes with the communities we're trying to work with. And so we would also like guidance on how to work more with the community as well.
And are you focusing on DAOs then and crypto communities, or also outside of crypto?
It's really anyone who's like very motivated, and as we can see with people here, these Web3 communities are very interested in experimenting with these tools, so naturally it's a very nice vehicle to explore with a lot of these ideas. And so the target right now has been Web3 communities, yes.
Okay, anyone else?
And if there's, oh, I see another question. And if anyone has any of the more technical questions, I would love to work with everyone. We're going to be in the ZK Community Hub on the main floor as well later in the afternoon, so we can come and chat more about some of these DVP schemes as well there.
Hi, thank you for the presentation, very interesting. I just think, when I hear your talk, I was thinking, how is that applied to Ethereum conference? So I think there's a context, there's commitment. For example, when I go to buy the ticket for this conference, it's sold out within seconds, literally very fast. But at the same time, I have no idea how many tickets was being sold. And so there's anything from your talk that can help the Ethereum Foundation to organize a better conference in the future?
Yeah, it's an interesting problem. I think I'd want to think a bit more about it. And if I do, I'll relay it back to the community. But I think in general, anything that applies to a large group of people taking action simultaneously, so it feels as though you have teams or organizations that are all trying to get tickets. How can we do so in a way that mutually benefits everyone? I'd have to think more about it, but I'll get back to the EF if I figure out a way that we can apply some of this to that problem.
Hi, I was just wondering if you could give a few more real-world examples of this being applied, besides the KGB, CIA, DAO.
Yeah, I guess I think like one example is like, let's look at reporting internally in big tech companies in general for like sexual assault cases. We want to make sure that when we so for the common knowledge scenarios, I want to make sure that if I come forward, other people are also going to come forward, because the risk is always on that first individual, a much greater degree than any individual that follows. So if we can coordinate in a coordinated attack way on a protocol that facilitates common knowledge, the probability of each person taking action simultaneously will be higher. But in the context of, let's say, what you're talking about with the KGB for DVPs being a bit too strenuous, even if I take any communication channel for any celebrity or any person who's high profile, let's say I'm the president of a country and I communicate with my peers, I may not even be saying anything that's secret or relevant to national defense or putting other people at risk. But saying this information to an outside community can be interpreted with the wrong context. And so the only people I want to be persuaded by this information is by the boundaries that I draw on the people who have the context to interpret it appropriately. And so I guess it's any communication channel where people lack the context to interpret information, and we want to mitigate persuasiveness to the third party.
Hey, how's it going? What happens if somebody submits false or mistaken information?
So if you submit, so again, like the point here being is that if I am lying, then I'm lying, and then the third party is not persuaded by it. I'm lying to myself, basically. But if the CIA, let's say in this example, lied, there's no incentive for them to lie in this scheme if that lie, unless there's like a broader set of incentives beyond this like actual member registry or secret. And so if I lie, it doesn't do anything to the scheme because I'm just persuading myself in that scenario.
One final question in the front here. Yeah.
G'day, great talk. In the KGB example, does the CIA then not reduce their ability to assert their authority to the general public then?
Well, the point being is like, yeah, in that scenario, yes, but we maintain the integrity of secret information within the CIA with high integrity.
Yep. Okay.
Yeah.
Thank you. With that, I'd like to call on everyone to give a hot applause for our speaker.
Thank you, everyone.
Thank you, Shay.
Thank you.
And with that, I'd like to call forward our next speaker of the day. We have with us Isaac Patka to talk about exploiting inattention and optimism in DAOs. Let's give him a warm welcome.
Forward, back.
I think I left something. Is there something on this chair? No, nothing? No?
Let's see. All right. Hello, everyone. I'm Isaac. I'm the co-summoner of the Logos DAO, and I'm also a research fellow at MetaGov. And today I'll be talking about some real-world examples of how DAOs have been exploited, one by me, based on proof of inattention and just generally lack of monitoring infrastructure. So I'll be detailing how I was able to steal some money from a DAO, how other people are attacking them even as much as like last night, and how you should be protecting your infrastructure from this type of vulnerability. So I've been referring to this as like proof of inattention. So attention is really the most scarce resource in DAOs. And so governance tooling should be designed accordingly. There's all sorts of optimistic architectures out there that rely on people to actually pay attention. And that sounds pretty simple, but like people paying attention is not something that you can actually assume is happening. So Safe Snap is an example that I think is one of the most widely used optimistic architecture tools in DAOs, which uses reality.eth to bring off-chain gasless votes on-chain for execution. But Moloch DAOs are also have a lazy or optimistic consensus mechanism where there's no minimum quorum for proposals to pass. Thankfully, they do require sponsorship, but these are just two cases of things where people could very easily sneak proposals by into DAOs while people are not paying attention. So the main thing that I want to highlight today is about reality.eth. I'm called on to set up many DAOs, and often people are like, well, why can't we just have gasless voting and use reality.eth to execute our stuff? And I think the assumption is that it's this like magical thing that brings reality and truth on chain, but that's not inherent. And so the way that reality.eth works is that anybody can ask a question of the Oracle that's like, hey, did this DAO vote to pay me $20,000? And then that goes in this really confusing format to reality.eth that you can see in the middle, which is like almost impossible to decipher. And then if you put down yes and nobody says no, then that just happens. And so like, it's not anything that actually relies on a vote having to take place. Reality.eth is a general purpose oracle that you can use when attached to a Gnosis safe to take money. So this is just a configuration of how that architecture usually works. Many DAOs have a Gnosis safe, which has multi-sig signers. Many DAOs, including things like 1inch, I think Shapeshift, a lot of DAOs out there that use a lot of voting on Snapshot have added this reality.eth Zodiac module. When you add a Zodiac module to your Gnosis safe, you're basically giving it super user privileges. It can shortcut all signatures. It can do anything with any assets in your safe. And so you have to be very confident in how you've configured that. So reality.eth is the separate application which brings the decisions on chain which get executed on your safe. So anything in your safe, the NFTs, the assets, the interaction with other contracts, it can all be executed by the reality module. And anybody in the world can ask questions of the reality.eth module. So when you're setting something like this up, there's a bunch of parameters that you can use to configure. And it's important to understand the impacts of every single one of these, because if you misconfigure one of them, then you can make yourself significantly more vulnerable to an attack. So when you set up this oracle, you want to set up a timeout. This is the duration during which people can answer questions. If it's 24 hours, then your question is live for 24 hours, and then whatever the answer is at the end of that period becomes the truth. If it's a week, then you have a week to answer the question. Cooldown is like a grace period after it, but after the truth comes on chain, but before it can actually be executed. Expiration is how long until it stays valid, and bond is how much you have to put down to make an answer. And there's other configurations, but I have some nice timelines that make this a little easier to understand. So the way that we intend for this to work, that a lot of DAOs intend for this to work, is that they host a vote on Snapshot, and then once that voting period is done, there's a little button on Snapshot which says execute this, and so that asks reality.eth a question, and then it goes to the pool of people that sit on reality.eth and answer questions. Unfortunately, there's like 3 people that sit on reality.eth and answer questions, so usually it's the main person that asks the question that also answers the oracle, and they tend to answer honestly and then execute. So this is the intended scenario where you've had your gasless vote, you've minimized your on-chain transactions, and then everything executed according to plan. So there's also the dishonest oracle scenario, where any attacker can pose a non-existent proposal to reality.eth and submit their own fraudulent answer. So you don't even have to go to Snapshot, you don't even have to make the vote, you can craft a transaction that's like, hey, did this Snapshot vote, which didn't really exist, pass? And then you put down a bond and say, yes, it did. And then you wait then you wait for that cooldown period, hoping that nobody's paying attention, and then congratulations, you've been able to steal money from the DAO. There's a few different ways that DAOs can protect against this. there's, of course, overriding the malicious answer. So reality.eth works in a way where you put down a bond to answer a question. You can put down double the previous person's bond to correct their answer, and that can kind of continue forever until it becomes not profitable to put down those bonds. So the best way to do, the easiest way to do it that reality.eth wants you to do is just correct malicious answers, because you'll take the bond if your answer becomes the truth on chain. You can also request arbitration. So if a dishonest question is posed, anybody could trigger arbitration. But what I've found in surveying a lot of DAOs on reality.eth and Snapshot, most of them kind of skipped electing an arbitrator. Or they set the arbitrator to themselves. And so like, these very simple misconfigurations can make it so it's like, well, now we don't have an arbitrator, so if we're not paying attention for a week, all of our money is at risk. There's also the opportunity to veto if there's a cooldown period. Surprisingly also, I found that a lot of the DAOs that I looked at in doing this research just skipped cooldown. They were like, nah, like, let's just execute this as fast as possible. So these are all things which may seem like logical when you're setting up a DAO, assuming like we're all going to be paying attention for our NFT investing DAO all the time. But then people go on vacation, your multi-sig signers go to Devcon, they leave their ledgers at home, and now you're pretty vulnerable. So each one of these can be misconfigured and is often misconfigured. So if your timeout is too short, then it makes it too hard to catch a malicious transaction. If your cooldown is too short, you have no opportunity to veto. If you have a low bond, it's trivially inexpensive. Somebody could put down a $10 bond for a fraudulent answer. If you have no arbitrator, then you have no final safeguards against that. And a absent or negligent multi-sig signer removes the veto or opportunity. All of these are actively being exploited. Even like yesterday, as I was saying, like this is a very much an ongoing issue. So first, I'll detail how in the springtime I noticed a vulnerable honeypot, actually called like the emoji like honeypotDAO.eth or something, where I wanted to figure out how easy it was to actually exploit this. So a little over a year ago, Gnosis put up this bounty. They were like, reality.eth is this great new module. Let's put $50,000 in here and see if anybody steals it. If no one steals it, then we can feel confident that this is safe. But like so many things in crypto, it just kind of went under the radar. No one really noticed. So this thing sat dormant. I have the address here, and I'll share this after. It sat dormant for a little over a year, no activity. And so I decided to try to exploit it. But I was doing it for research purposes, so I live tweeted the exploit to make it good and not illegal. So what I figured out is like how to craft the exploit using the add proposal feature on Etherscan, where you craft a transaction. And in this case, I was like, OK, I want this DAO to send me like 19,420 DAI. And so I crafted the transaction locally, and then hashed it and included it on the Etherscan link. Now, a quirk of this is that you could, looking at this proposal, you actually don't know what my transaction is, because it's only a hash of the transactions that gets asked to the oracle. So this is another scenario where, like, if you see a malicious proposal, you don't even know what the attacker is trying to do. They could be trying to take $1, they could be trying to drain the whole treasury, but all transactions are hashed so that you have absolutely no idea what's going on. So in this case, I submitted a fraudulent proposal, and then I went on to reality.eth, and I paid 0.1 ETH as a bond to say, yes, this is true. It was fine for about 24 hours, and then I saw a tweet from Oren. I cheekily called my proposal ID nothing to see here, because I kind of wanted it to get detected. I could have put a proposal ID which blended in even better, but I put like, nothing to see here. Oren found that funny, I guess. And so Oren and some of the other folks from Gnosis were like, hey, it looks like somebody's actually trying to drain our Gnosis safe. We should veto this. But much like the Gnosis safe table earlier this morning, nobody was present to veto the transaction. So this is just, and being a honeypot DAO, they set this up as like 24-hour periods, whatever. It'll be fine. I'll go back to my funny slide for pictures. Thank you. But it was too late. So at this point, I was like on another call with another thing, and people were like asking me questions. I was like, I can't talk right now. I need to finish stealing this money. So I went on and I executed it, and I tweeted about that as well, that I successfully drained 19,420 DAI from this Gnosis safe, and nicely offered to give it back. They said, don't worry about it. So it was too late, because arbitration could not be requested because their arbitrator was set to the 0 address. The cooldown was too short, and I think one person was on vacation. And nobody else on reality.eth was paying attention to refute my answer. Like, Oren refuted me once, but then I refuted him and put a higher bond. So I actually got his honest bond in addition to the exploit. And so, like, the system, yeah, it's not perfect. But then it was like quiet again for a while until like 2 weeks ago, when people actually started using this to try to steal money. So some folks from the Opium network thankfully had some monitoring infrastructure set up on one of their safes and noticed that somebody was submitting fraudulent proposals to try to drain their entire treasury. But being nice people that they were like, is this attacker doing this to anybody else? And what they actually discovered was the attacker first went after this like really easy target. It's this DAO called like Lolly DAO. It's never been used. It's like one person. But there was 7.5 ETH in the treasury, and they had reality.eth configured. 24-hour voting periods, no arbitrator, no minimum bond. And so the attacker snuck some money into a fresh wallet. I think they withdrew from like Aztec into a fresh wallet, put down a bond, and within 24 hours had stolen 7.5 ETH. So now they had 7.5 like stolen ETH that they could then use to put down bonds on other things. And so there's this like NFT collecting DAO called, there's this NFT collecting framework called Seasons, which uses DAOs that set this up. And some of them have like, hundreds of me bits or like a bunch of stuff in their DAOs. And so the attackers started going after those. And so they used their ETH to place bonds on all of these other DAOs, saying, did this pass? Did this pass? Did this pass? And at this point, like, you could very easily flood the reality.eth UI, because it's like Web3 UI and takes 10 minutes to load when you go to the page, and it's really frustrating to use. So they put these like 6 proposals down. They put down, thankfully, the Seasons folks have done some really good configurations where they had a minimum 1 ETH bond, a 7-day voting period, and so that gave us enough time to defend. And so I was, some of this was going on in the ETH Security Telegram channel and chatting with like the Seasons folks. I was able to actually go in and put down like 8 ETH in bonds to overcome the 4 ETH that they put for theirs. If they then came back and like put down 16, being like, no, I really want to steal all these me bits, then I would have had to start like calling up some friends and being like, can you guys please donate some ETH so that I can like defend these safes from this attack? Thankfully, they got scared and ran away and took their 3 ETH in profit, and the attacker went away. But this is continuously happening. For the next week, I basically had this screen open on my computer, refreshing like every hour to make sure that the attacker wasn't coming back. So it was a bit of a stressful time until they finally gave up, and I was able to claim their ETH and make sure that the honest answer made its way on chain. So there's hundreds of millions of DAO treasuries that are at risk of what I would say are inattention attacks. And in fact, like, reality.eth is like the one that I've been highlighting, but there's Moloch DAOs that are vulnerable to the same thing. I want to include some links to, so Sky sent me from like a Metacartel, sent me a proof that he did of a Moloch DAO inattention attack, where if you're in some Moloch DAOs, maybe you're in 1, maybe you're 10, maybe you're in like 60 of them, and oftentimes like they go dormant for a while. There's no monitoring infrastructure in place, and so any member could be like sneakily submit a proposal while everyone's at a conference. And I'm saying this to try to scare you to like look at your DAOs and make sure no one's trying to take things from you while you're sitting here. I think that attacks like this are only going to start happening more and more frequently. So beyond smart contract audits, we need configuration audits. It's not just enough to have the core logic right. It's a matter of how you stitch together all of these composable pieces into something that is also audited and safe. And so configuration audits are something that I really want to see become more prevalent in DAOs, like whether it's the Gnosis Safe, the Safe app, where it's like, hey, if you add these modules, you might be vulnerable here, or like, hey, you have like a green check mark, this configuration seems pretty safe for you. And I know it's early, but like these are things we should be adding before we have some sort of like trauma of like a bunch of safes getting drained. So I have some tips on how you can protect you and your DAOs from people like me and people that are worse. This is a bunch of text, but I made this to like kind of take pictures, and I'll post this out later. I think it's as somebody that went through like a SOC 2 audit with a startup before crypto stuff, there's actually a lot of stuff from those processes that I think DAOs could adopt. They make you think about what's your resiliency plan, what's your continuity plan, who has control over this administrative thing, is there some random multi-sig somewhere that actually holds veto power to the DAO that we're just too lazy to get rid of. There's a critical need for more monitoring infrastructure. So I know a lot of people are working on dashboards for individuals, like track their portfolios and stuff, but we really critically need more monitoring infrastructure for DAO tooling that can WOOF style, I don't know, ping you everywhere every time there's like some sort of big transaction going on. There's cool automation tools that I think are underused as well. OpenZeppelin has a tool called Defender, which I really like for identifying dangerous scenarios, setting up alerts, and then actually submitting triggers to pause contracts. You can create these Defender bots on that tool that look for a malicious proposal, or maybe your DAO is going into sleep mode, and you want to set up something where it's okay, if anyone tries interacting with this smart contract, this pause transaction is going to go out, and you can pre-sign a transaction, preload it, and have all these defense mechanisms ready to go for your communities. I think it's also really cool to see that simulation tools are getting more used, because I don't think I've seen an attack like this, but I wouldn't be surprised if somebody submitted a proposal at some point that was hey, we should submit my monthly payroll, but then they just add a 0 to their paycheck. That would be pretty hard to detect, and most people that are on a bunch of multi-sigs are approve, 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 approve. But thankfully, SAFE has added tenderly simulations where you can just say okay, what would happen if I actually approve this? And you can choose to say, okay, is that person getting paid $1,000 this month or $100,000 this month? Simulation tools in DAOs are critically needed as well. We need to conduct regular configuration audits and detect when configurations change. All of the things that in legacy companies are really boring and they have entire departments of people for things like change management are actually needed in composable governance settings. We should always minimize cross-chain communication. Anytime you're using a bridge, you're probably just waiting to get exploited. We need to implement spending limits and transaction guards. Everybody should use hardware wallets, not back up their stuff in. And this is just general purpose, housekeeping stuff. But a last one that I think would be cool is if we could set up some sort of on-call shifts and rotations for people that are on 60 multi-sigs to make sure that they know that, hey, this person's on vacation, these 6 people are in Bogotá, we need to keep track of what's going on. So, I mean, in conclusion, composable governance tooling is why DAOs are going to be great and powerful and transformative, but we also need to be very careful about how we configure things, or else we are just going to start seeing floods of malicious proposals coming in, and people are just going to get overwhelmed. So take care of your DAOs and protect them. Thank you. Thank you.
Thank you, Isaac, for that inspiring talk. Are there any questions from the audience? I see some in the back over there, in the middle. Yeah. Please talk into the mic because of the stream. Yeah.
Is it possible to set up prevention rather than monitoring? Because I just see if you would have a lot of monitoring tools in your DAOs, then what makes it so different from the traditional financial system?
Yeah.
Does that make sense?
It does make sense. And I was chatting with some folks earlier about better architectures for this kind of stuff, where proposals should actually be minimized in DAOs, where you can set up different governance architectures that are much more set it and forget it. The folks at Protocol Guild, the way that they, and also the Build Guild, the way that they have their payroll set up is it's just streams which are set up until they're not. And so I think that more things like that, where governance is you set it and you only have to do governance when you want to change things, versus constantly having to do proposals, makes it so that you could have much longer voting periods, much more safety. And I think that generally architectures that prioritize that over active attention-based governance would be better, and then we're not just flooded with notifications, which is not necessarily better.
Right. So that means that there's a huge opportunity for UX and designers in the space, right?
For sure, the UX, but and also UX of the UX of the governance itself, and thinking about things on time spans and cycles and attention and stuff. So for sure.
Really interesting. Thanks.
Mm-hmm.
You mentioned sending out alerts when there was a possible attack going on. Have you thought about somebody trying to exploit those alerts and creating many, many false positives so that people stop paying attention to the alerts and then it allows somebody to start the attack?
Notification fatigue is like, yeah, it would not necessarily be better because then we're just like, okay, which of these alerts is real, which is not? So yeah, it would be similarly bad.
You've mentioned earlier about arbitration and that some of the DAOs are basically setting themselves as the arbitrator. What are the other options and how would that process work if you get there and you need an arbitrator?
Yeah. So some DAOs have like Claros courts set up as arbitrators. Hello, which is cool. So that would be a great option. Or other systems that have or just any other system where somebody can be like, here's an independent board that, but your arbitrator also needs to be responsive. And so like that's why it's kind of good to go with a protocol versus an individual, because if you have like a one elected individual arbitrator, people go on vacation, people go away. So yeah, I would say like using like other consensus mechanisms like that would be ideal.
Any further questions from the audience?
I might have my contact info on the next one. Yeah, always feel free to reach out to me on specifically Telegram is best. If you are identifying issues with DAOs or configurations or like, hey, is this vulnerable? This is what I enjoy helping with, so reach out. No, more questions? Yeah, thanks.
We actually have a final question over here.
Yeah, quick question. Does Logos DAO use reality.eth?
We do not.
Oh,
but that doesn't mean that I would never use reality.eth. I just think that you have to apply it carefully, and it's not a like panacea of like wonderful gasless voting for everyone. It's good for specific use cases when it's well configured. But we do not currently use it. Thank you.
Thanks. Thank you again, Isaac, for today. Yeah. And with that, thank you again. Yeah. This ends our morning cycle. We will be back at 1 o'clock with an AMA with the Geth team. In the meantime, be sure to get some food and drinks on the first and second floor. And I'll hope to see you again at 1 o'clock here. Joining us for this session with the Geth team. Today we have Peter, we have Guillaume, we have Matt, and we have Marius to answer all your questions in this session. Please give them a warm welcome and applause.
Thank you for coming. We have no idea what we're going to do for the next hour, so maybe, I don't know, maybe we should start with introducing ourselves or something? Yeah, okay, I'm Marius. I've been with the Geth team for 2 years now, and that's it.
What were you doing before you were in the Geth team?
Oh, I was working on payment and state channels and actually mining software before that. But I also worked on the merge, so I hope that like kind of balances out.
Oh, okay. My name is Guillaume. I've been working on the Geth team since 2017. Initially on a project called Whisper. Didn't work out, so I moved on to more core development, and I'm currently working on the topic of stateless Ethereum and Vertical trees. Before that, I was an engineer at various non-crypto related companies, and I'm very glad not to work there anymore.
Hey all, I'm Peter. I've been on the Geth team for about 8 years now. I started working on Whisper and figured out that it won't work out in about 2 months. But yeah. And yeah, essentially Ethereum is my first real job, so fun.
Hello, I am Matt. I've been on the Geth team for 4 months. I've been working in the Ethereum space for about 4 years. That's also my first real job. I worked on the Quilt team previously, doing various R&D efforts on future ideas for Ethereum, and now working on the JSON RPC for the Geth team.
Cool. So this panel was supposed to be an Ask Me Anything. So it would be super nice if you have any questions, starters, go for it.
Ethereum. Okay. Hi, I'm Ulash. We woke up with the news of Arbitrum acquisition for Prism. How your team looks for an acquisition, and do you think Prism will be a leader consensus client for Ethereum?
So I actually just heard it 2 minutes ago before we went on stage, so I didn't really read anything about it or made up my mind about it. as I said, I think consolidation is, it's always this two side of a coin, right? We want to be as decentralized, we want to be as distributed as possible, and that also means that the teams should be independent. On the other hand, if you have like a bigger company working on different things, they can achieve stuff faster. And so let's see what the future holds for Arbitrum and Prism.
Plus, just to add to that, I think the Ethereum vision, long-term, the idea is that the clients will be, or the most important clients will be maintained by fairly important companies. Whether those companies grow out of the ecosystem or are external companies, that's, I mean, up for debate, but I think in general it's good for Ethereum if you have solid, well-funded teams behind them. So whether this particular case is good or bad, I mean, that's up for debate, but the idea is okay.
All right, I have a question for you guys right here. So thank you for being here. You guys are rock stars. So this is a question for the, the ones that have been here many years about what is your most memorable experience working for Geth? I remember Devcon 2, the Shanghai attacks. So I don't know what's your experience about that. So I would like to know what's the most memorable experience for all you four? What is the fondest experience working with the Geth team?
Hard question.
No, I was just going to say, and totally unpredictable as a question.
Yes.
We are very well prepared.
What about the merge? Like, how do you celebrate it? Was that a happy celebration? Was that full of anxiety?
The merge celebration was basically, okay, it's done now, let's move on. So for me, I think the most memorable, I haven't been in this team for that long. The most memorable thing, I think, was the Greece interop, where we worked on the merge together with all of the different client teams, consensus layer client teams, execution layer client teams, in a really nice hotel in Greece. And we spent like the whole day sitting in the basement, hunched over our computers, working while it was like 30 degrees outside. And after the third day, I made the decision that after lunch, I'm going to take 1 hour or 2 hours to go to the beach to enjoy life a bit between working in the basement.
You stole my answer.
Hello, hi. I'm Jeff, and I'm in the space around 5 years. So as I'm a Go developer, I had opportunity to read your code and participate something in your Discord. But after the years passing, I was feeling that less and less, maybe, or you're so occupied or with less support. I could saw you less and less in Discord. Also, the documentation will become more and more outdated. Now, after I saw Peter's, I think last year, one of our tweets that say, oh, we need more support, other stuff. Did you get some support for the Ethereum Foundation to support your team, maybe to hire new people to help with the documentation, the stuff? Because you did an amazing work. Go is still being a good platform for building this stuff. But I see a lot of people say, okay, I'm going to use Rust, other stuff. But we have a very good base of knowledge in Go that you guys built. So how is the future for Geth? So basically, this is my question.
Yeah, so that's actually a very good question, and I'm kind of happy that I have a positive answer for that. Is that, well, in the past, most of the documentation that we wrote or stuff we published were all written by us, and I mean, that's kind of nice. it's kind of, we have to be the origin for those, but we didn't really have the capacity to do it. And for the past couple months, we've actually had somebody on the team who helps write documentation. I kind of feel that we still don't help him enough, but we are trying our best. Plus, it was Sina's initiative to actually revamp our entire website, which will come in a few weeks, months, I'm not entirely sure. But there again, we kind of, a huge shout out to the EF, essentially Ethereum.org website team, because they are the ones doing our new website. And so we know that there's a lot of things to improve, but we have received an enormous help from the EF towards improving it. I'm sure there will be a lot of things that still depend on us, but things are getting better.
Also, regarding support on our Discord and everywhere, I think with the increasing complexity of Ethereum and the increasing demand of shipping stuff, just being there, like our time being spent on supporting individuals in the community is very limited. And we need more people from the community to take over, to help educate others about how to use Geth and this kind of stuff.
Yeah, I just wanted to answer the question about the future of the Geth team. So far, people were quite positive and upbeat, so I wanted to be the downer here. I think, I mean, it makes sense that so much of Ethereum has been relying on the Geth team before. There's been an effort, like, the help also comes from other teams, like, for example, the consensus layer clients are taking part of the trouble, the burden away from us. There will probably be this kind of other efforts in the future, and hopefully we can just become a bit more redundant in a way. Excuse me, that would be true decentralization.
Also talking about support, if you guys have experience with Geth and want to help us with the Discord, yeah, we're really looking for people who can do it. Although I know if you guys can work with Geth, like you have experience, then you probably get better jobs elsewhere. But you know, just yeah, for technical support, yeah.
This is Sina, by the way. He's also part of the Geth team.
Yeah, so Sina didn't want to be here, but thank you for being here.
But Sina gave a good lead into my question, which is to ask everyone who's in the Geth team, either on stage or off stage, where do you most need help individually? Like, in parts of projects you're working on, whether it's like strategic stuff for the future or like something right here, right now. Is there anything you can share with us as community to help us better support what you guys are doing? Like, can that work?
The first thing that comes to mind is please be polite on PRs.
Yeah, so I guess with the Geth team, our bottleneck, our single bottleneck is pull request reviews. We have a lot of very nice members on the team who can really churn out code super fast. Maybe a few people way too fast, like Gary, and we can't keep up with him. And we also have a lot of external contributions. And the problem is that the code is super sensitive, so it kind of always boils down to a couple of people having to review everything and having to do a lot of context jumps to review them. And unfortunately, this is our Achilles heel because we have absolutely no idea how to solve it. Definitely more people on the team, more reviews help, but it's not an easy to solve situation because we can't just hire somebody to do code reviews since, I mean, the entire network kind of depends on it. So that's, we're really open for suggestions on how to solve that.
I think two things also come to mind for me. The first is helping create better onboarding mechanisms for people to contribute to Geth. Right now it's kind of, you know, look at the code base, find something to fix, look at the issues, find something to fix.
I'm taking you don't like your onboarding experience.
No, I think my onboarding experience has been excellent. It has been such a fun time working on the Geth. No, but I think seriously, a lot of people have talked to me saying, I have no idea how to start working in core development. And, you know, some people like work through that filter themselves and they find issues and they start contributing and they end up in that position. But I think that we could build some mechanisms for more people to contribute. And I had this idea that I've started working on a little bit is like having some sort of like capture the flag that has like basic flags for people to capture where you do like a core development task, like add a new opcode or fix some sort of bug or go through an invalid trace of the EVM. And you're able to resolve it and run a program and verify that you did it correctly. And so that's like a very, you know, binary system of like, I did this right, and so now I can move on to the next thing. And then once you go through that, then it's a little bit easier to come into the whole Geth process and figure out like, okay, why did they not like my PR? How do I get this PR to be accepted and everything? So I think that would be a cool thing for people to contribute. If that's something you want to contribute to, I'm happy to talk offline about that. And then the other thing that I think that we could use help with, and I think like all of the execution layer teams could use help with, is working on the JSON RPC so that this is an interface that's a little bit more standard across all clients. I think the ideal world is that a client is just simply a black box, and no matter what client you're running, you can always interact with them, you know, almost exactly the same through the JSON RPC. And we're trying to get to that point, but we're still not quite there. And it's just generally one of these things that's not as high interest for a lot of people, and so it gets put on the back burner for the most part.
And I guess one more thing I would add is that no shade for the other execution clients, but very often I do feel that the Geth team is driving a lot of the changes, a lot of protocol changes, networking changes. So it's kind of a bit asymmetric in that we are the ones bringing for example, the networking EIPs to the table, and everybody else just, well, okay, if it's backed out and if Geth implemented it, then we'll just roll with it. And I mean, that's perfectly fine, just it kind of means that our tasks are always not only to maintain Geth, but also somehow to try to advance the execution layer features. Whereas the other clients are kind of, I feel that they are sometimes just playing catch up. And this is fine for them, which is less fine for us.
And I think that also goes, not only goes for features, but also for the testing. So a lot of the testing efforts right now are driven by Geth, and we're currently trying to build out a new team within the Ethereum Foundation specifically for testing, for cross-client testing. Yeah, in the past it has been Geth is the majority client, and we have to take care of the network, so we have to make sure that everything is really well tested, and we can create tests that can also be used by the other clients. But in the future, we would like to get to a state where researchers and the testing team create tests for everyone, and so and they don't have to rely on us doing the work for testing.
Yeah, and something kind of in this area is also there's Geth. Geth is its own monolithic piece of software, but there's a lot of, I feel there's a huge gap still between the Solidity development world and Geth, and I would really love to see a lot more tooling developing in between, like to bridge this gap. So I don't really have any suggestion about such tooling, but I feel there's a gap here that would be great to fill.
All right, I have to think of a question, because what I really want to do is just use this as an opportunity that I may never have again to say just how sincerely appreciative I am of everything you guys have been doing over the last couple of years. From one developer to another, I know that sometimes that doesn't come through as much as it needs to, and it's just what you guys have done has really helped me personally and get me involved in the ecosystem. So if I came up with a question right now, I guess it would be, does Clef have any future?
So first of all, it's pronounced clay.
No, Clef. That was perfect pronunciation. So whether it has a future or not, I would say, so Clef was one of those projects which we really think would be very, very useful. However, I kind of feel that we, as developers, kind of took it to a point where it's secure, and it's highly unusable because it's very, very console-based and everything. And the only way to make Clef more usable or friendly at even the least bit is to actually turn it into a product. And unfortunately, I will admit it that that is way outside our capabilities, because there you would probably need a UI team, you would need a completely different team to do that work. And whilst I do think it would be super awesome, it's, again, the question is, we could hire somebody or multiple people to work on it. We could maybe get an EF to work on it, but there are a lot of other wallet software out there. And the question is it worthwhile to try to compete with them? I'm not sure. So I would say Clef isn't going anywhere, but I don't really see it going into a product quality either. So it probably will be a bit in this limbo space for now.
But something that we are currently thinking about retiring is the personal namespace and the wallet within Geth. And so if you're depending on that, we're sorry. No, actually, there's a discussion to be had, but we would really like to get rid of this stuff.
Yes, so definitely that's the direction so Geth is kind of like this huge monolithic monster, and that was kind of born out of the necessity of when Ethereum launched, there was no other software, so the clients had to do everything. But obviously, having your accounts managed by a node is a bit wonky. That was partially the reason why we built Clef, and we will definitely try to take Clef up until the point where we can remove account management from Geth, and hopefully it should be as easy to manage your accounts via Clef as if you were managing it via Geth. But I think that's the threshold where we will probably stop, and if somebody picks it up, awesome. If not, then it will be used as kind of as a developer tool in the future.
So a long time ago, there used to be a very nice proof of concept running Geth on Android. And I feel that now, after the merge, maybe it's more relevant and it can be actually useful that people are running their own clients on Android. Is there any work being done on that?
On what, sorry?
Android.
Oh, yeah. So
Let me answer that. So originally, when we shipped Geth for Android, we shipped it as a full node, which obviously doesn't work anymore. Then later, Joel shipped the light client. It's still, I wouldn't call it really production ready, but it kind of worked. However, it turned out that the pre-merge light client is still too heavy for a phone. So now that we are post-merge, that's actually an interesting discussion to be had, whether we could just somehow pick this thread up again. I think it definitely would be interesting. However, usually with mobile phones and Android, you have very, very strict limits on how much, I mean, okay, on iOS you have very strict limits on how much your background process can run. Android is a bit more relaxed, but you're still eating battery very, very fast. So I could imagine some LES client or some light client on demand where you just, whenever you just want to interact with your thing, then very temporarily just pull some data from the network and that's it. Then I think the post-merge world is kind of compatible with that. So I think that would be interesting. However, at least using the Geth code base, I think it will always be a bit heavier than ideal. So if you were to really, so the Geth Lite client, even if we ship it as production ready, will probably more cater towards running on a laptop. And if you want to run it on a mobile phone, in a production-ready environment, my guess would be that it would take a different team, maybe a slightly different approach to get there.
No, so it's like an additional thing that we have to maintain, and I would actually like to get rid of this, the Android stuff. The thing is, like this go to whatever Android uses cross compilation is always broken, and there's always some issues there, and so it never really works, and sometimes is a bit clunky, the code that gets produced. And so I think another team just building a light client from scratch for mobile phones, especially after Verkle, we will definitely see some stuff there. And I hope that at that point we can just get rid of this.
Wait. So there's also a bit of a roadmap issue here. It seems that, now the direction for Ethereum is to have all of the day-to-day operation happening in roll-ups, and having the core layer be something more, I'm not going to say inaccessible, but maybe not the thing you do on a day-to-day basis. If that is the case, if that trend continues, I don't think it makes sense to worry about mobile, because no one is going to try to access the layer 1 from a mobile.
One more thing I would add is that it's an interesting twist post-merge world, that before the merge, even a light client had to have a lot of connections. I mean, you either connected to a trusted server, which kind of beats the purpose, or you had to connect to multiple light servers so that you kind of got the ground truth, kind of followed the correct chain based on proof of work. Now, post-merge, you don't really need that because you have the signatures. So in theory, post-merge, you could connect to an untrusted Web2 provider and download the necessary data, and you could still verify it. So this kind of opens up a bit of a different design direction for making Ethereum trustlessly work on mobile phones.
Hello. So what's your take on the parity Open Ethereum saga? And what can the community do to make sure that good clients don't die again?
Can you repeat the question?
Yes. This level is good. So what's your take on the Open Ethereum parity saga? And what can the community, what can we do to make sure that alternative good clients don't die again?
I think that's inevitable. So in my opinion, good clients will die. I mean, look at the Geth team. Geth team currently is about 10 people. Now I would say that out of these 10 people, you have probably 4 to 5 people that are kind of more familiar with the very, very internal details. Now, should these 4 or 5 people leave, it is very, very hard to find replacements for them. And this is essentially what happened with parity. Okay, the leaving, it was a bit different, but the idea is that if you actually manage to simultaneously lose enough of your main contributors, then it's very, very hard to onboard enough people fast enough so that the project survives. And I think that it's as bad as it is to lose a client, I don't really see what you can do. I mean, the same happens in open source software too, that eventually you have a couple maintainers that just, I mean, life happens, they go do something else, either because they get bored or whatever reason. And I'm not sure that, yeah, so I think it is a very real chance, and it will definitely happen, that good clients will die. There's always one way to protect it is if there's a very, very good funding behind it, maybe a large corporation, but again, if there's a large corporation behind it, they can always decide that it's not worth it to keep going. So it's, I guess it boils down to the fact that this is why we would need client diversity, because that kind of affords us good clients occasionally disappearing.
And I think within the Geth team, we're trying to prevent this by onboarding new people and making sure that the new people that come in get familiar with a lot of the different parts of the code. And so, but it's very hard for us being relatively new to meaningfully contribute, because there are so many just invariants within the code that are not explicitly stated. And so sometimes it happens that we break an invariant, and it's usually Peter who has all of the invariants in his head and says, okay, we're breaking an invariant here, don't do this, this is going to fail at some point. And it just takes a long time to actually learn all of these invariants that are implicitly in the code.
Plugging back to one idea I was talking about before, just the fact that, for example, we kind of spun off consensus. If another one of those steps happens in the future, like maintaining a client becomes easier and easier, so that would be a good, I forgot the word, but it would be a good way to make clients not be at risk of dying. But until we simplify the protocol, it's going to happen.
And one thing that I also really like on the roadmap is these the purge, where we try to eliminate some of the old, outdated stuff. And so, for example, history expiry would allow us to delete all of the rules that we have for executing old transactions. And at some point, if there's a way to execute them in a different client, and all of these caveats, but it would make maintaining a client a lot easier. Another issue that we always run into is that someone wants a feature and we don't really think about it and care and implement the feature and merge it in. And 2 years later or sometime later, we realize that this feature is not really used by anyone, and we cannot change something because we would break this one feature. And at that point, we have a decision to make. Either we just don't do anything, or we delete the feature, and someone is going to be upset. And we don't want to make people upset, but it's inevitable, I think, with the way Geth is right now.
Yeah, and I guess just one final thought there. Marius said that if we implement the purge and get rid of a lot of features, then that would really help other clients get up to speed. I think if we, so currently it's very, very hard to write a client, and starting a new client is essentially impossible because Ethereum is moving so fast that you never catch up. But I guess once we reach the point when Ethereum starts to ossify, that would be a nice place when actually new client developers can join in, because then you can actually say that, well, I want to make a client just specifically for iOS that has this and this and this properties, and they can work on it for 3 years without the protocol constantly changing the invariants. And I think my expectation will be that when we reach that point of stability, we will have the original clients be quite marginalized by new clients that are very, very focused to some specific sub-task or some use case.
So thanks again for carrying so much of the Ethereum ecosystem on your shoulders. You said 10 people, that's insane. The amount of value that sits on top of 10 people, that's crazy. Can you hear me? Yes? Okay, so the question is, what is the current sustainable business model? And the follow-up question is,
The what?
what is the current sustainable business model for Geth and probably other clients that want to copy that? And the follow-up question is, what is the plan to do something similar to what's being done for the core protocol, right? We want a certain percentage of it to be staked as a security, a percentage of the total value, right? So is there some sort of research going on how do we get certain percentage of the development effort in the Ethereum ecosystem to be going towards Geth security?
Well, to answer your first question, it absolutely makes no sense to write a client. So I think there's no business model behind it. It's currently, most of the clients are funded by, I mean, we are fully funded by the EF. We have absolutely no income. And I'm assuming other clients, usually how they try to fund themselves is that many clients get grants from other projects so that they support different blockchains, different layer 2s, different scaling solutions. That's one way to somehow try to build a business model around it. But at the end of the day, since Ethereum is kind of like this public platform, as a client, you cannot really make money out of it. It's, yeah, so that there's no business model behind creating the client itself.
You want to say something?
The only thing that I would say is that there's the protocol, what's the protocol? Protocol guild, yeah, exactly. That allows projects, for example, DeFi projects, to allocate a percentage of their token distribution to a pot, and out of this pot, client teams get, right now, they get bonuses. And this is, the general idea behind it was not to fully fund client teams, but to provide an upside that they wouldn't have if, that they currently don't have, and that they would have if they were to switch to DeFi. Because we've seen a lot of good client developers just say, okay, I can make 10 times the money if I create the next token. Yeah. So the protocol protocol guild thingy is like a way to give some of that upside from the DeFi projects.
Yeah, appreciate it. Like, I was wondering if you can start experimenting with things like maybe Categorizing funding towards PRs, right? You said there's a big backlog of PRs and only a couple of people that are capable of reviewing, but you could imagine that with some sort of Categorizing funding, you can't hire, or at least bounties for other people or layers of developers to review and write tests and integration unit tests before it gets to a core developer.
So I guess this depends on the granularity. Generally, people do that at the EIP level. So famously, Uniswap is pushing certain EIPs very, very hard, and I'm assuming they are actually funding the people who are doing the necessary research, doing necessary presentation, et cetera, to get an EIP through. Now, that I don't think that really works at client level, because we've tried, for example, at some point we gave out a couple bounties for some work. The place where it kind of backfires is twofold. One of them is that you usually get contributions of not the greatest quality, because a lot of people see that, oh, there's a, I don't know, 1 Ether bounty on this, so let's just jump on it. So you will have 10 different implementations, all just kind of trying to hack it as fast as they can to get the bounty. So the code is not the best. It requires a lot of effort from our side to somehow try to fix it up or try to guide that person. And the other side is that after the bounty has been paid out, since this was a bounty work, they just disappear, and maintenance is our problem. So we kind of have more problems than gains with funding PRs at that level. What we have done previously is we have funded research teams, for example, who have helped us on the discovery protocol, the discovery V5. I think Felix was managing a small research team at, I'm not entirely sure which university, and the EF was funding them for a year or so to just investigate, find possible solutions to different challenges, write some papers. That one works. So that definitely works, but at the client level, I feel it's the wrong granularity.
I just wanted to say to the original question of like what is the business model for clients? I agree, like there's no reason to build the client. There's not a lot of money in doing this. It's always going to be like considered a public good, but I think one way of making it sustainable is, like Maria said, this protocol guild project, and a way that people can like help make this sustainable for the long term is whenever you're developing new projects to consider adding a small allocation to the protocol guild in your initial like token launch. If some of these are, if this would have been something that was around in 2018 or 2019 when a lot of these blue chip DeFi protocols were starting, we would have over $100 million dedicated just to core development. And so I think like going forward, it's like a good thing to consider, because you want Ethereum to be around for a long period of time, and the best way to do that is to make sure that the people who are making it happen continue having the funding that they need to do it.
Yeah, and adding to this, we not only is there no business model for a client, but I don't think there should be, because otherwise you would kind of adapt your strategy to increasing that revenue stream, and you lose your independence, basically.
Okay, hi everyone. So my question is related with what Marius just said. And well, I'm still a student, and I'm still trying to figure out what I want to work on after I graduate. So I see the stuff that you guys do, and I think it's amazing. And I still see something more on the application side of things. So my question is really, why did you decide to go to core development and to stay in core development instead of going to something higher in the stack?
Because it's way more fun and way more interesting. And so for me, the big thing is also I want to work on something that makes sense to me, where I have the feeling that I'm doing something good for the creator of humanity. And I don't think DeFi is, or a lot of the DeFi stuff is this. And so that's why I was so interested in working on the merge and helping push the merge, because I felt like this is like the biggest thing that I'll ever be part of regarding like the CO2 consumption and everything, and so just having this big level of like my small work can have a really big impact. That was something that was pretty magical from the beginning, and yeah, that's why I am in core development. I don't know about you guys. It's not the money.
I mean, I would add, so my answer is kind of boring because there was nothing when I started working at Ethereum. So I think Matt's answer would be much more interesting, since he did have the choice of picking one or the other.
Picking one or the other is in?
I mean, working on protocol versus working on dApp layer stuff.
Right. I mean, you know, I originally started working on the dApp layer. Like, when I came out of university, I was very interested in how, you know, the types of applications that you could build on Ethereum. And I was very interested in like dispute resolution, because I had done a lot of like e-commerce and buying and selling things on the internet growing up, and I was like frustrated with the way that these systems were built. And so I was very excited about this as an application on the protocol. And so I joined Consensus, and I was working on something pretty similar to this, and just immediately realized that, you know, the user experience for Ethereum at that time, and like still today, was too bad to really onboard like hundreds of thousands of users to, you know, have this kind of dispute resolution system. And even if 100,000 users decided to show up tomorrow, like we didn't have the scalability to support that many users on the protocol. And so that was kind of like where I started getting really interested in protocol development. It's like, I was like, this is broken. We need to fix it so that we can build an application on it. And I've just like slowly become more and more indoctrinated in the idea. And now I'm kind of at the point where I feel like I would rather be a small piece of a very large puzzle that I feel is going to become extremely important and impactful for humanity, rather than trying to build an application that may or may not have any kind of impact for anyone.
So I guess your reasoning for joining platform development was, you guys suck, I'm gonna fix it myself.
naively maybe so.
Yeah, I don't do that for humanity. Sorry, you guys suck. No, yes, of course. I think also it's where the biggest problem. I mean, like the impact indeed is going to have like reverberating consequences in the future. So that's where it's the most interesting. But it's also simply because. Yeah, you want to have good tools to build better societies, to build better companies, to build better software. And I think simply the core, I mean, if you want to work on your tools, you always end up working on the core, no matter, I've worked on Linux kernel before. It was the same thing. You get dragged into the protocol as long as you want to improve your tools.
Hi there. I have a question about databases, the underlying database, and Geth as being viewed as a database. You guys have talked about Geth as being monolithic and wanting to remove or modularize components. And I was wondering, since database throughput had been traditionally a kind of constricting aspect, if there were any changes to that coming up. And this question comes from seeing a remote DB option in the command line options and not being able to find any documentation with respect to that.
So that's a very nice technical question. So one aspect I'll ask a previous question. A lot of people sometimes ask us on social media, why did we pick LevelDB? And that was actually also my question when I joined the team. And Jeff's answer was because Bitcoin was using it. So that's essentially how Geth started out using LevelDB. We've tried switching databases many times. Generally, what's not so visible from the outside is that databases are kind of built up, have two components. They have a storage layer, which is kind of like this very dumb layer that just has some very primitive ways to store data and retrieve data. And then they build on top various transaction mechanisms, journaling, all kinds of stuff. And most people kind of convolute the two. And most people don't realize that LevelDB is essentially a storage engine. It's not a full-fledged database. And there have been databases built on top of LevelDB which have all the bells and whistles. Now, the issue is that the moment you are adding, if we were to use something higher level, then essentially we're not only paying the costs of the storage layer, rather we also have to pay the costs associated with running the transactions, indexing the tables, et cetera, et cetera. So at this point, since Geth was kind of architected from day one to just use a storage layer as its database, if we were to plug in any full-fledged database instead of it, everything becomes just insanely slow because Geth was not architected to use these high-level primitives. Geth always assumes that it has more or less direct access to the data. And because of that, we've tried. We have a lot of PRs trying different databases, and they always crashed and burned. One thing that we currently are working on, actually Jared is working on it, is to switch out LevelDB to Pebble. Pebble is kind of like a next generation version of LevelDB, but it's still just a storage engine. As for remote databases, the problem is that one of the bottlenecks of Ethereum, of running an Ethereum node, is disk access, I/O operations per second. Now, the moment you move the data away from the node, actually the bottleneck is getting way, way worse. So it's instead of making things better, you are making them a lot worse. Since accessing, I mean, usually you have, if you want to access an SSD, a modern SSD can do maybe 500,000 I/O ops per second. That's not the high-end SSD, that's a payable, affordable SSD. You cannot do 100 million round-trip times on the network per second. So it gets a lot slower if we go down that path. Of course, you could always say that we could create an Ethereum node architecture which has a remote database, and then you could have multiple clients using that same database. That's a very interesting architectural decision, but that is essentially writing a completely new client from scratch. So you cannot really retrospectively retrofit Geth to use it. It would be its own new client.
Hey guys, seconding all the previous comments, thank you for the incredible work you're doing in the ecosystem. You guys are the unsung heroes of Ethereum. Quick question. If you were to hypothetically re-architect Geth from scratch today, knowing everything we know, factoring in the merge, what would you do differently?
I think we would, at least I would be more careful about the features that we accept into the code. There's some stuff that barely anyone uses, but it's still used. And something that kind of bugs me is that we write a lot of like small tools, and instead of having them separate from the client, they end up somehow in Geth. Yeah, I would have like a stronger policy of not including them. For example, the ABI gen stuff should, in my opinion, be a different thing. But I already know what Peter's going to say. But then you need someone to actually maintain it, and if it's not in the client, it's not going to be maintained. If it's not in our code base.
No, I actually agree with you. No, so I just wanted to add what Marius said. That previously it was brought up that the problem is that when Geth was started, we had to be this monolithic thing that does everything. And this kind of leaves its mark on the code base. And it's very, very hard to get rid of stuff. And I mean, we could get rid of stuff, but some people somewhere always depend on it. So I think if we were to start over Geth from way back 8 years ago, we would end up in this exact same situation because we would need to make the same tools. And we would so I don't think the fact that we have a lot of legacy junk in the code base, that's not a bug. It's just the way the ecosystem evolved. So I don't think that would have been preventable. If we were to start over now, then all of a sudden you can rely on all the awesome tools that people created, and that allows the client to be a lot slimmer.
Hey, I think it's a lot of stuff changed over the last like 1 year and a half, but especially what changed significantly, I think it's that a lot of other networks appeared that actually locked a lot of billions of dollars, like somehow that actually are like Geth forks with some changes. And was it somehow like useful for you to take a look on it? Are you somehow monitoring what is happening over there? And if so, were there any cases when you somehow wasn't like inspired by some changes in these clients and you want like to bring them into the Geth, like the regional Geth, and like some cases when some bugs were opened in like Geth forks that actually are pretty close to the regional Geth as well?
So about features or changes, I don't have anything to say about that. One thing I wanted to say is about bugs. So whenever we find a bug in Geth, then there's usually a lot of different clients that are also vulnerable to this, and so we're looking into them and making sure that they are not before we actually fix the bug and publish it. The problem there is in which layer ones are we going to look, and are we only going to look at Ethereum aligned layer ones or not? And so I think the way we handled it up until now is that we kind of look in the biggest ones and just send them an email that, hey, you should expect an announcement at a certain point,
and then we're going to make a public announcement. Because we don't want to be kingmakers, we don't want to say which client, which fork gets the bugs first over another fork. Yeah, there's also been bugs that have been exploited on other networks before they were exploited on Ethereum. We're kind of like not really monitoring them, the other networks, but we're trying to be on good terms with the other client devs.
I guess one kind of satellite question here would be that way back there were a lot of drama around when it turned out that we fixed a bug and we haven't necessarily announced it. Other networks had a problem with it. People very often asked us, why don't we have a standardized way of reporting bugs, reporting vulnerabilities? Usually what big Web2 companies do is that they have their own little private consortia where they share bugs, and then when they publish it, everybody in that consortia already updated. And people were always very, very vocal that we should do the same thing. We kind of felt that that's a bit problematic because in the blockchain world, if we were to create one of these consortia, it's not really clear whether everybody in that group would be friendly or how friendly they would be. So usually what we try to do every time we found a hairy vulnerability or bug is that depending on the nature, we always try to announce external people or give enough details to external people, external teams, to minimize any potential damage. Now, for example, in the case of Ethereum, what we did is that if we knew that we are going to fix something that only affects miners, or if the miners are good, then the worst that happens for average user is that their node crashes. Usually what we did is that we just gently pinged a couple of the bigger mining pools that, hey, we will release a release. You really want to be on this release. Nothing more, just a gentle reminder that it contains something that you want to run. And by having the majority of the hash power updated, the network is kind of safe, and there's not much damage that can be done. But this is kind of a completely arbitrary bug-by-bug decision on how best to proceed, how best to minimize any damage to anybody either in the Ethereum network or the external blockchains that use Ethereum. So we really try to be as friendly as possible within the limits of keeping the Ethereum network live.
Thank you. Hey, it's me again. I just want to add that apart from the people sitting here and some of us off stage, we also have people watching the stream from the team. I want to give a shout out to Martin, who is from far away, who couldn't make it, unfortunately. And who's from far away trying to contribute to the conversation. So somebody asked about the remote DB flag. I have an answer to that. So it's basically, it does the low-level database get over RPC. So basically, you can have you have a node on a server, and you can have your local node connect to the remote one for some only read operation. So for example, if you do db metadata command locally, then it would basically give you the metadata of the remote node. Yeah, that's it.
Okay, we have 37 seconds left.
So if anyone has one short question, 3 minutes.
Here?
Okay.
Hi, I'm
Chris.
Oh, sorry.
You go first, but really short, and then Chris. And
okay. I'm Josh. Do you see snapshots as the solution for the state database layout for the foreseeable future?
Sorry, what was the question? I missed it.
Do you see snapshots as the Geth solution for the state database layout for the foreseeable future?
Yes.
Thank you. Yes. You got the last question.
Just one question. We are in this beautiful Colombia, South America, Bogotá. I just want to know what each of you have most loved about Bogotá so far.
Hiking in the rain at the waterfalls.
I actually really liked working from here. It was really fun with we had some workshops a day with all of the client devs, and today we had a really nice working session in the morning.
Yes, if you haven't noticed, Marius is the new workaholic on the team.
Yeah. It was really nice just getting the people in the room that need to be in the room and work on some of the interesting things that are coming up. And I'm really, really, really excited about the new stuff that is coming for Ethereum.
I also enjoyed the hike quite a bit. That's the only time I've left the hotel besides coming to here, so.
I heard different, Matt. I heard different.
I also really like the energy at Devcon. It's been a while since we've all been together, and I think it's easy to forget that the community is so large now, and there's so many people excited about this protocol. So I found that very energizing for myself.
Yes, Jared tells me the food. No, yeah, it's the food has been nice. I like the hotel as well. No, but I don't know. I saw the center the other day when we went. Looks quite interesting. I guess we will explore more this weekend after the work is done.
One last question. Who from the team is not on stage today besides Sina?
Who from the team is not on the stage? We have Jared beside you. So huge shout out to Jort in the back, Felix, who's in Berlin, Martin's in Stockholm, and a giant shout out to Gary, who wasn't able to make it to any of the Geth meetings for the past 3+ years due to him being stuck in China, and the Chinese rules on leaving the country and coming back due to COVID are super, super strict. So an insane shout out to him for still tolerating us and working for us without all the upsides of having the fun like we are having now.
Also, congratulations on getting married. He's getting married next week.
Do you want my social security number next?
I think we have to cut it off there, Thijs. Thank you so much for today. Yeah.
And,
and
Joseph.
Marius?
And Joseph, who's doing the website.
Yes?
Yeah, Joseph. Yeah.
Yes.
Joseph.
Thank you.
Big round of applause, guys. Thank you so much. Yes. And with that, I'd like to call forth our next speaker, thank you, which will be John Kane, providing a session on better Solidity support in VS Code by Hardhat. John, welcome to the stage. Oh. Please give him a warm welcome.
Okay, can I just kick off?
Yeah.
Okay. Cool. Okay, everyone. Welcome to Better Solidity Support in VS Code by Hardhat. We're going to be covering, this is going to be like a jaunt, quite an easy jaunt through the different Visual Studio Code extensions for Solidity. There will be shilling of the extension I work on, But then, more interestingly, we'll move on to a couple of the technical blockers that are holding us back from giving you the Solidity experience you all deserve. And then, a plan for getting around those blockers. So my name's John Kane. I'm from the Nomic Foundation. You probably know us as the Hard Hat people. Nomic is a not-for-profit foundation paid for by donations with a remit to improve the Ethereum developer experience. Hard Hat's a big part of that, but the remit's general. And we've identified a gap in editor tooling. And that's why we have built and released a VS Code extension called Solidity by the Nomic Foundation, of which I'm the team lead. So you can find me on GitHub or hanging around our Discord server, particularly the Hard Hat VS Code channel. So if you want to come and chat or suggest some features, or you've got a really detailed bug report and a matching PR, come chat. Come chat. Right, editor tooling. Let's kick off by addressing the Microsoft-branded elephant in the room, right? Why are we focused on VS Code? And the reason is, we have good reasons to believe that VS Code is the main way that Solidity is getting developed today. So if we take a look at the most recent Solidity developer survey, you can see that VS Code is dominant, right? In fact, the 60 Visual Studio people, we suspect, actually meant Visual Studio Code rather than the venerable .NET IDE. Similarly, the Remix, that's an online Solidity editor, but pulls in key components from VS Code, right? So you're actually down at Vim before you're not talking about VS Code or VS Code adjacent, right? And we suspect that the Solidity developer survey skews towards those who are deep in the ecosystem, right? Those who are on crypto Twitter and click on the survey link when it goes out. Put another way, it's overrepresenting this long tail. It's overrepresenting the shadowy supercoders who are doing their development in Vim in a TMUX session over a VPN to a military satellite that they repurpose for the day, right? Actually, let's just test, right? Hands up anyone who, when they do Solidity development, they do it in VS Code. Okay, good. And hands up if you're a shadowy supercoder who's doing it in Vim. See, that's a trick. No shadowy supercoder would admit, right? And actually, hands up if any of the two Emacs users are in the room, because I'll buy them a drink. I'm having my doubts. I've created the wrong incentives here. Right. And I'm not immediately going to renege on that promise, right? That'll be a lesson on soft promises and the value of escrow. Right. So by Pareto analysis, VS Code is where we should put in the effort. I'm in VS Code, I want to do Solidity development, I'm looking in the marketplace, what should I do? And I would say that there are 3 options. If you have a different setup, get in touch, I want to hear it. But those would go down as Solidity by Juan Blanco, Solidity by the Nomic Foundation, and Truffle for VS Code, right? And we're going to cycle through all 3 of them quickly. And if we were doing it by installs, we would start with Solidity by Juan Blanco, but as I work on this one, and it's my talk, we'll start with mine. As I'm a coward, I'm not going to do live coding. So here is earlier John to run you through the feature set.
Hard Hat projects arranged and organized underneath packages. So if we jump into our Solidity contract, as you can see, we have table stakes, so syntax highlighting. We also have diagnostics, or otherwise known as inline warnings and errors. You can hover over variables or functions to get useful information. Note that currently we're not showing documentation, though I will come back to that. We have code completion on local variables, or more sophisticated examples where type information is required. Completions work inside of import statements as well, both at the file system level, but also direct imports. So in Hard Hat's case, that's looking inside of NPM modules. In terms of navigation, we can find usages. Similarly, we can jump to definition. And this is working across the different packages of the monorepo. Refactoring includes rename, which obviously you shouldn't use to do any evil, though we have implemented undo. We have a set of quick fixes which appear in response to salt sea warnings and errors. You can find them under the bulb icon. So let's bring back public visibility. And similarly making sure that we set the override specifier. These are small annoyances with function signatures, but we have more complicated quick fixes. For instance, if we have a contract that needs to implement an interface or multiple interfaces, we can leverage the add missing functions from interfaces quick fix, and this will do some of the heavy lifting for us. It is scanned through the inheritance hierarchy of interfaces and base contracts and figured out what the smallest set of functions that needs to be stopped for saltsea to stop shouting at you.
Oh. So I want to add, oh no, if I push play, this is going to play again. Ah, good, they've figured that out. I want to add 3 caveats to that video. Caveat number 1. Like any suitably advanced technology, is indistinguishable from a rigged tech demo, right? And what you just saw was a rigged tech demo. You didn't see all of the places where jump to definition doesn't work, or you're aiming for completions, we didn't resolve the type information, so you get the default set of completions. Caveat number 2, I want to just re-emphasize that the documentation against the function wasn't appearing on hovers. And there's a technical block to that I want to come back to, right? And 3 is the biggest caveat, which is there's key features in there, actually like diagnostics and quick fixes that only work inside of a hard hat project, right? And that's a problem that I want to come back to again. But let's take a look at the other extensions quickly. Solidity Y1 Blanco. This is the OG. It's been the workhorse of Solidity development for years, with over 800,000 downloads relative to ours. Let's just say we know how Vim feels. It provides syntax highlighting, integrated formatting, it has navigation and diagnostics, but the default structure assumes that you're organizing your contracts under source and lib. So setting it up for hard hat is difficult, but it's going to work better if you're doing Foundry or DAppTools or Brownie. Next, we have Truffle for VS Code. This leverages Solidity by Y1 Blanco for the syntax highlighting, diagnostics, etc., but adds a layer of UI integrations into the Truffle tool suite, right? So that you can run compile through the UI, through the task subsystem in VS Code, for example, right? And that's great for onboarding if you're new to Truffle or you prefer the UI to the CLI, right? One other really cool feature is integration with the Truffle debugger. I just wanted to mention as well, this isn't from general development, but the diligence team at Consensus has a set or suite of extensions that are security-centric. So they're going to give you analysis and visualizations when you're doing a smart audit. Okay. So, plenty of options for Solidity then. Lots of great programmers pushing the ecosystem forward. But I don't think any of us would claim that we're yet in the same league of editor support as other language ecosystems like .NET or Rust or TypeScript, right? So how do we move from where we are now to that best-in-class experience? And one of the answers is just time and resources, right? But there are a few technical blockers. I'm going to spend the rest of this talk digging into those. First off, feature fragmentation. So we have features which are siloed by editor and also siloed by development framework. The other is feature brittleness, right? Can you rely on a feature to always be there and to do the right thing? For fragmentation, clearly extensions we have built in VS Code, maybe the lack of support in Vim is why there isn't as many people using Vim, right? If they had those advanced features in Vim, they would be using them, right? So that's one form of fragmentation. The other form of fragmentation, though, is in developer framework. not all of the features that were listed there work for all development frameworks, right? If you're working on a Truffle code base, you're probably using Truffle for VS Code. And if you're in a Hardhat code base, hopefully you'll use the Nomic extension. And if you're in Foundry, you're likely using one Blanco's extension, right? And that makes sense for some development-specific features, but there are core editor features which should just work across all of them, right? You're going to want rename in Foundry just as much as you're going to want it in Hardhat, but currently it's siloed in Hardhat, right? So how are we going to get around this? Sorry, there are multiple reasons for that. One of the reasons is just Conway's law. So if you've got 4 teams working on a compiler, then you're going to end up with a 4-phase compiler. The code structure matches the communication structure of the teams, right? And the development teams that are writing editor support, it's easier for them to add it for their own development framework. It's easier for me to harangue the other Hardhat devs or cajole them or convince them or go crying to the CTO to try and get it changed than it is for me to convince the entire ecosystem to just do what I say, right? But there's another aspect that's part of Solidity, right? Which is that Solidity doesn't specify how import loading works, or doesn't specify that part. It leaves it up to the development framework, right? So if we've got an import statement here pulling in other Solidity code, SaltC requires a custom loader to actually resolve that, and it has to be provided by the development framework. And if it's a relative path, the development framework is probably going to do that as relative to on the file system, right, from the current file. But if it's a direct import, then there's multiple different interpretations which make sense, right? In Hardhat, we would interpret this as look inside of node modules, and then find OpenZeppelin and resolve the rest of the path, read the IRC20 sol file. And that makes sense, right? Hardhat leverages JS, including node modules, but that doesn't make sense for Foundry, right? It's going to resolve this based on remappings in either the foundry.tomo or remappings.txt. Right? And that has profound implications for editor tooling, right? So say you're on IRC20, this token here, and you want to do jump to definition. The editor can only resolve that if it understands this at OpenZeppelin import line, right? That implies the editor has to understand the import loading logic of the development framework that this file has been dealt with under. Okay, so how are we going to work around these fragmentations? And editors, and different editors, and fragmentation across the development framework. I'm going to do it in 2 steps. First, we're going to use the language server, which is, language server is a technology that came out of VS Code, but tries to deal with the fragmentation you get across editors, right? So instead of each editor implementing language features for each language, we gather up the language features under a daemon, and we have the editor boot that daemon up, ask which features it provides, turn those features on in its UI, and whenever those are requested by the user, it delegates them off to the daemon, and the communication between the editor and the daemon is covered by a clearly specified protocol, the language server protocol. And that's what we're doing in the Nomic extension today, right? There is a language server which is encoding all of the completions diagnostic solvers that we provide today. And that is embedded in VS Code, but there's nothing stopping us from exposing that out so that other editors, say Vim, can take advantage of it, right? But what about the more important or more difficult form of fragmentation, right, between developer frameworks? If you have a language server in the Nomic extension already, why is it that I don't have advanced completions in Foundry, right? And the reason is because currently, the language server is really a Hardhat language server rather than a Solidity language server. We are, all through the code base, encoding Hardhat assumptions to deal with things like the import loading that we saw earlier, right? So, and the reason that we've done that is we use bits of the Hardhat code base, right, which allowed us to get up and running quickly. We could make Hardhat dance, right? And subtraction is hard, right? But we are looking now to refactor the language server to isolate out these Hardhat particular points, the development framework particular parts, behind an adapter interface. We'll have a Hardhat adapter, but we'll also can then have implementations for Foundry, Truffle, Brownie, right? And in that way, we can add the feature once and have it available across the ecosystem. One other point I just wanted to mention, recent versions of Sol-C have a language server built in, right? So why don't we leverage that? And we're big fans of language servers, so the more the merrier. But the Sol-C language server is embedded in a particular version of Sol-C, right? And hard hat code bases can have versions that are older than the ones that provides the language server. And similarly, we have many complex code bases and hard hat code bases which have multiple Sol-C versions, right? And we need the language features to just work across those versions. So that's why, right? But just to summarize, the Nomic extension has an inbuilt language server that we are making developer framework agnostic, and that we're going to make standalone so it can be used in other editors. And that's how we can build a feature once and leverage it across the ecosystem. OK, feature brittleness, right? This is about quality. The editor just doing the right thing. And so when you do jump to definition, you can do jump to definition in all of the places you expect, and actually goes to the right place. And the Nomic extension has blind spots, right? There are lots of places where features don't quite work as we would like. And there are several areas that we need to work on this. But I just wanted to focus down on one in particular today, right? And that is that we are not giving the best experience when people are annoyingly trying to use the editor to make edits, right? Just to walk through, so you're bopping about inside of the editor, you're doing navigations, you're exploring the code base, you jump back again, right? And then you start making an edit. And you remove a semicolon, right? Shame on you, shame on you. But suddenly, jump to definition doesn't work, right? And why is that? Okay. So the video just showed you a change in the document, and that change doc gets passed to the language server, right? And the language server does a parse. And it builds an abstract syntax tree, right? And that's a data structure which represents the syntactic elements in the code. So a node might represent, the code might represent a function, and then subnodes would represent substructures like the function name, the parameter list, the function body, right? And note as well that the parse produces an abstract syntax tree, right? So some trivia is thrown away, stuff that isn't strictly necessary, like whitespace, like comments, right? Because they are not typically used in later phases by, for instance, the parser, right? And that's why when we do hovers, we don't show the documentation. The abstract syntax tree is abstract because it's thrown those elements away. And because the AST doesn't have it, we don't have it, so we can't provide it in a hover, right? But we take the language server takes the AST, and it combines that AST with the ASTs of all the other code files, right? And then we do a further analysis stage. We overlay it with type information. We also scan through the nodes, and we find definition nodes and usage nodes, right? So a definition node might be a function declaration, and a usage node might be a function invocation, right? And we layer on top of the AST that extra information, these extra links, so that you can see which node is connected to which other node. And so I change so that when the user requests a jump to definition, the language server receives that request, including the cursor position. It looks up the nodes underneath that particular, underneath the cursor, and finds, say, a function invocation, right? And then looks up that pre-calculated link to find the definition node, and we return that location, right, in terms of its file, line, column, actually both the start and the end. And VS Code then jumps to that location. Next, the user makes an edit and introduces a syntactic error, okay? The change doc comes through, we do a parse, and it fails, right? And why did the parse fail? Well, we, like other projects in the ecosystem, leverage Solidity Parser, right, for parsing. But Solidity Parser it's a JS library, and it's designed to give binary answers to the question of, is this syntactically valid, right? So if it's syntactically valid, we produce an AST. Otherwise, here's a list of errors. And that makes sense, right? Most use cases of a parser stop if there's a syntax error. You don't proceed on to compilation or generation steps if there is a syntax error, right? But editors have other needs, right? In the editor's case, we want both the list of errors, but also the syntax tree, right? Or as much of the syntax tree as possible at the same time, right? And that's not what a standard parser is designed for. And the way that we get around this in other languages is by building specialist parsers that are more tolerant, right? And they're designed specifically for that editor use case. And that's what we are building now at Nomic through our Slang project. The Slang parser, one of the components of that project, looks to leverage best practices from other languages, right? From Roslyn, from Rust, right? Things like red-green trees. And the goal is to always produce input, always to produce a syntax tree, right? Even in the presence of errors. It's just that sometimes the syntax tree will be valid and other times it will not. But hopefully, Slang's error recovery will mean that a missing semicolon in one function doesn't mean we don't get the syntactic structures in all of the other functions, so that we can take advantage of those in editor features, right? One of the other advantages of building a parser specifically for the editor is that you can include that trivia that's normally missed out, the white space, right? The comments, so that we can show the comments in hovers, for instance, right? Or we can do advanced formatting, refactorings, right? Right now we're blocked in refactorings because developers probably wouldn't be too happy if on doing a refactoring we stripped out all of the comments in the file, right? That's probably unacceptable. But with a parser designed for the purpose, we have that information and we can make sure it's there. Okay, so what we're doing here is swapping out an excellent but general purpose component with a component specifically designed for the editor. And that's how we drive up feature quality. All right, to summarize. Okay, if you're using Hardhat and you're using VS Code, we think you should give Solidity by Nomic a go. And we think it represents an excellent set of features. And you've just heard how we're driving up the quality of those features by building editor-specific components and swapping out the general components that we have. And we are looking to make those features available across other development frameworks, right? We want a credibly neutral language server, and we're doing the refactoring and putting in the work for subtraction to support that. We also want it to be a standalone language server. So we want to pull it out for being embedded in VS Code. It's going to need to do a small amount of cleanup. This is actually one of the easier things we need to do. But hopefully, sometime soon, a shadowy super coder will be able to hack away in Solidity to their heart's content. Okay, so that's how we're going to improve the Solidity developer experience for everyone. Thank you very much.
Are there any questions for John before you leave?
Sure.
You have room for a few.
We'll see how. Does anyone have any questions? Go for it.
Hello? Oh. Are there any analysis tools that can benefit from this improved, more robust abstract syntax tree? Sorry.
Yes, sorry. So the question is, are there any other tools that can take advantage of this? And we would hope definitely yes. The Slang parser, we're building a component that can be used in dev tooling across the ecosystem, right? And it's going to give more detailed information and work across different Solidity versions, right? So it should be giving you rich information across versions. Other parts of the Solidity project also intend to add other components to provide even more information. So usage and definition would be the next one that we're looking to tackle. So yes, hopefully lots of analysis tools will be able to leverage these components.
And for a final question at the front.
Hey, thank you very much. This is awesome. So 2 questions, real quick.
Go for it.
It wasn't clear to me, at least, if the slang parser is being used right now by the extension. And the second question is there any intention from you guys to support coq.nbeam, which is like a, yep.
Yep. So right now we do not have the slang parser. We're using the Solidity parser. And we're looking to dog food the slang parser within the VS Code extension. I'm not giving out estimates, mainly because it's not up to me, but yes, we're hoping to pull in the slang parser in the near future. In terms of Vim COC, that's part of making the language server standalone, and Vim COC would be the first target for making it work with that. And that's something that is within just the VS Code team's remit, so hopefully that should be in the near future.
Thank you very much.
No problem. Are we having any more questions, or?
Room for one more.
Okay,
If
go
there's
for
one
it.
more. Short one. Oh yeah, here at the front.
Thank you. Yes. When the slang parser comes out, how do we do we need to install it, or is it already built in? How can we get access to it when it does
be
come
available
out?
as a separate library. I believe it's written in Rust, but we'll make it available in Node and JavaScript as well.
Okay, thank you. That was the last one. I'd like another round of applause, please, for John.
Thank you.
And while we're setting up the stage, yes, I would like to welcome our next guest who will be presenting, which is Rob Stupai. I have seen him. Yeah, oh, he's already here. Look, to discuss what's new in Remix. Rob, are you ready?
Yeah.
Okay, let's give him a warm welcome.
I got this. Yeah. Oh, look at that. So this one goes forward? Okay. And backwards? No. Okay. Yeah, perfect. So are these all the Remix fans of Devcon? Welcome. And get ready for our new features. We're going to be whipping through about 250,000 slides. So, wait a minute, am I in the way? Here, that's better. Wait, move back a little bit. So new features are everywhere, and we'll be going through all these sections, like the File Explorer. You can now clone a Git repo in the File Explorer. Right now, there's this little icon. We added a new little icon right over there. You click that, but soon it's going to turn into a little hamburger icon, and you click the hamburger icon, and you can clone if you click the clone button. And then you get this modal to come up to ask you for the address of the repo, and then it comes in as its own workspace. So you can bring lots of code into Remix really fast, or easily now. And then when you click the workspace pull down, you get the Git icon on all the workspaces with a Git repository associated with them. And you can manage a Git repo in dgit. Of course, you could before, but maybe, actually, have any of you used dgit before? Oh, there's one. And it's important, yeah, you need to be able to push pull and do all your Git commands. So you click it's a plugin, and you load up the dgit plugin. It stands for Decentralized Git. Click that, and then over here, behind the chair, or maybe on your screen, you'll see the init, push pull, all the normal Git commands, and oh, it's over there. And then you're good to go. And then we've got new templates. In the workspace, if you click the new template, a new workspace button, and then you get, oh, look, it's over there. you can get a create new workspace. I like it looking at this. And then what happens? You can choose a template. Come on. Oh yeah, but first you can initialize a repo, any repo you want, to become a Git repo. So now you click the default, or that pull-down menu, and you get all the different workspace templates. And now they're all the Open Zeppelin templates, or some coined Open Zeppelin templates, and the 0x project. And if you click one of the Open Zeppelin templates, you get some of the features. So you click one of those, and you can add a new import to your base coin contract. And now you can drag and drop in the File Explorer, which means that your workspaces won't be so messy, especially when you didn't open the right folder when you're creating a new file. And has everyone here used RemixD? It's an important little thing. Yeah, and because it's important because Remix is not like a Google Doc. We get emails pretty often like, I lost my files in Remix when the browser crashed. So you just have to know where your files are saved. They're saved in in the indexed DB, and that's in the browser, and the browser is feeble, you know? So if you want to save it to your hard drive, you can use RemixD to share a folder on your hard drive with Remix, or you can push it to, you know, some other external Git repo if you want. And now, as a result, we made the RemixD command a lot easier. Instead of a lot of flags, you just go into the directory you want to share in your terminal and just type remixd. Of course, you do have to download it first, and it's an NPM package, so, but it's simple. And now you can load Slither for all you static analyzers out there. You just want to load Slither locally. Yeah. And we've made some editor updates. And for the master of editor updates, I give you Philip.
Thank you, Rob. For those who have been here at the, what do I?
The green button, the big green button.
The green. For those who have been here at the previous session, you know how challenging it is to build a good code editor. And as we are using the same editor as VS Code does, we've been able to make it do some stuff that we expect the editor in VS Code to do. And the challenges that we had are basically the same that the nice people from Hard Hat have when they are doing code parsing. So we've been trying to solve this problem. First of all, in order to use these features, you have to turn them on, because by default we turn them off because, you know, some people might not like it, or it might be all too sudden. But basically what we have is autocomplete. And autocomplete is a very complicated beast, as we know, because when you're typing, you want stuff to happen. So we have designed some custom parsers. We use 3 in total to parse the code while you're typing. So what does it complete? It completes globals, the usual Solidity stuff. It completes it does dot completions on globals from Solidity. It also completes anything that you have inherited from other contracts, and anything that's available to the specific location where you're typing. So that all of that also takes into account visibility of certain functions or variables that are being imported through the imports, basically. It also autocompletes functions from other contracts, so that when you type proof, for example, it will pre-fill the variables for you in the editor. It's still very limited, but it's getting better as we go along. It's an experimental feature. It has some stuff to it, but we try to make it fault tolerant, so that when you're typing and you're completely messing up, it tries to make sense of what's there. And I think we've done a pretty good job. It's for you to try out and to see if it actually is, it is what I'm saying it is. The dot completions are a thing that I think is specifically useful for when you're doing complicated stuff with contracts that you import. Here we have also a nice little feature that we built in order to complete possible imports when you type import. Basically, we have some Uniswap and OpenZeppelin preloaded, so you can easily find and search files that you're looking for. If you're looking for some kind of interface for an ERC 1155, you just type in, you just go to the OpenZeppelin / and you type in 1155 and it will just show up in the list. It's easy to import it that way. You don't have to copy paste it anymore from other locations. And the imports will be available, the imported classes, or import contracts, sorry, will be available for you as autocomplete objects when you try to extend the contract and anything else. So these things are all being taken into the editor. These are things that we believe are important features for people to develop quickly and that any editor should actually have. We also include gas estimates. Gas estimates are simply returned by the compiler, right? And we display them on the places where the compiler says that there is an estimate. Sometimes there is not an estimate. If you don't see the estimates, that means that the compiler can't make sense of what you're doing. And then suddenly things stop, right? So you see the gas here. If you hover over it, you see some more information because the gas is a more complicated beast as we go along. Then we have, just as in VS Code, we have jump to definition and references. We also have the peek function, so that when you click here, it will just open up this editor within the editor, and you can just jump around through all the references and definitions that the thing can find. We try here also to be fault tolerant. If your file is messed up and you have errors in it, it will still be able to find the functions and the definitions. It will also show you the netspec comments that are included into the files that you have imported. So let me see if I can actually see. Oh yeah, and then we try to make something that when you actually type and you make an error, you see this squiggly lines. You get warnings and errors, and what's the other thing? I forgot. And it also colors the files, just like in VS Code. So when you have an error in a file, you will see it turn red. Also on top, you will see it turn red. If you've made an error in an imported file, which is important, you make an error, you just forget something or something. It will actually put a squiggly line underneath the imported file, and also it will also show you where the error is in the file explorer, so you can easily say, okay, this imported file has an error, I'll just go there and see what's going on. The hovers are another feature that we do. This hover feature shows you the errors that the compiler says that you've made, and as I said before, it just shows you the definition and the location of the stuff, and also the comments. If there are any, it will show them into the hover. Then we have a nice play button, and this play button has several things that it does. For Solidity files, it will just compile the files, and for TypeScript or JavaScript files, it will just run the script. That's the play button. It's a nifty new little feature that we made. And then we have code formatting. Code formatting is something that I use all the time because I'm lazy. And I'm not a Python guy, so I like to format a lot. So we did it, and we will build some customization to it so that you can actually customize the formatting to your own specifications or likings. But for now, it does some basic formatting on your JavaScript and on your TypeScript and on Solidity. So try it out and see what it does and see if you like it. And if it becomes a big mess, just tell us and we'll fix it. Here in the opening screen, when you close all the tabs in Remix, it will just show you this screen, and it contains the shortcuts that you can use in the editor. So the important part to remember from the editors, is to turn on all the features in the settings so that you can actually use them. If there is something that doesn't work, just tell us, because we need to learn from the experience from people who actually use Solidity a lot. And so that's important. The next part is proxy contracts, and I want to introduce you to David Dissou, and he will talk about it. Thank you.
Okay. Hi, I'm David, and I'll be talking about Remix IDE support for proxy contracts. Okay. Remix IDE allows you to be able to deploy upgrades to your smart contracts. We just introduced this, I think, a few months ago, about a month, 2 months ago, and it was purely inspired by continuity of your project. I believe we've all, at some point, deployed some contracts that we might feel like making some changes to, and then we couldn't do that because there was no provision for upgrades. So we have that, and the Remix IDE uses the Open Zipline ERC 1967 proxy contracts to help do this. Now, the Open Zipline supports 3 types of proxy upgrades. I think the UUPS, the transparent, and also the beacon. For us, for now, on Remix IDE, we support you using UUPS pattern for contracts upgrade. Yeah, okay, and then it requires you having the UUPS upgradable DSOL in order for it to work. This feature can easily be tested if you access the Open Zipline wizard. You can be able to customize how you want your contract, and then you select the UUPS upgradable and open in Remix. If you have that, you compile, you should be able to have this. We also have templates. I believe Rob was talking about templates towards the beginning. You click Create Workspace. You can select and customize what you want by checking also the proxy. So once you have your contract in the IDE compiled, you should be able to have these options: deploy with proxy, upgrade with proxy. Yeah, so basically, Remix IDE does, in the background, the deployment of the proxy contract. So we basically have a compiled bytecode of the ERC 1967 contract, which we deploy as your proxy, and then we now have your implementation contracts deployed on top. So basically, when you're interacting with this feature, you'll be prompted with a model instructing you that 2 transactions will occur, and then using the JSVM, it's super fast, so you just see it immediately after the first deployment. the first deployment, oh yeah, the first deployment and then the second, yeah. But then if you're using, say, MetaMask deploying to mainnet or one of the test nets, it will be a bit slower because one of the transactions has to complete. That's the proxy deployment first before the implementation. Okay, next. Oh yeah, so after deployment, you have this interface displayed. The first here is the deployment of the implementation contract, and then this is the proxy. Now, these 2 instances have the same UI, but then you get to interact with the proxy. You get to interact with this UI and not that. And this is because the whole point of having an upgradable contract is that you don't want to interact with your implementation. You want to interact with the proxy. But then we still display this so that you don't get confused and feel like something is up. But it's actually just there so that you interact with this, and then this makes low-level delegate calls to your actual implementation contract. Okay? And then we also have the upgrade. So now for the upgrade, you need to provide your proxy address. If you use Remix IDE to deploy your proxy originally, then you can check this box to be able to use the last address. Yeah, so really smooth. And moving on in the future, we plan on having a list of previously deployed proxy addresses so that you can be able to pick from and not just the last deployed address. Yeah. Yeah, I think I've talked about this. It makes a delegate call, I guess, to your implementation contracts. Okay, also, talking about workflows, Remix IDE also has a GitHub action that allows you to be able to run your Solidity test on your GitHub workflows. So it can be integrated as part of your build process, and you can be able to have it run Solidity unit testing every single time there's a push, or depending on how you configure it to be. We also plan to have the static analyzer also added as GitHub actions so that you can be able to have it on your GitHub project. We also are currently working on having you run JavaScript tests with Mocha and Chai, also as GitHub actions. So yeah. Okay. Oh yeah. This is a sample. This is a sample workflow that can be used. Yeah. I guess it would be nice to check it out on the GitHub Marketplace. Moving forward, I'll be handing over to Rob to round things up.
Right on here. Okay, a few more things to go over. We got a new workflows for quickly working out problems. So setting the state of a contract is can get kind of hairy because you got to maybe have to deploy a bunch of contracts, got to go in and hit a bunch of functions, and you got to remember what you do. And each time you develop, it can be you got to remember what the process is. So you can make a script that does that for you, and then let the script run after you do a little bit of coding. And now we have this button to push, so when you click that, it will compile the contract and then run the script. And you connect the script and the contract with some NatSpec comments. There's an example in the default one_storage to see how to connect the NatSpec comment to connect the script and the smart contract. So you don't have to hit compile and run all the time. You could just hit it when you want to. So just compile, 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 and then when you need to, run it. Or I guess you probably could do it all the time too. We got a bunch of interoperability updates. You can compile for a Hard Hat project when you share the folder with RemixD to the Hard Hat project, to your Hard Hat project. And you can sync now. So if you want to use Remix or Truffle, or if you want to use Hard Hat, Truffle, or Foundry, and deploy with, and you can deploy with Remix. So once you share the folder, and then you compile a file in one of those other frameworks, then you can go to the deploy and run, and hit the refresh button. Like that one was compiled by Hard Hat, and then we took the same file and compiled it in Remix, and it comes up with compiled by Remix. And then, yeah, then you can deploy and run it. We got Foundry remappings when you share the folder with a Foundry project. And here's 27 seconds, so we can have some time for questions of some quick grab bag of stuff. We got the advanced settings in the Solidity compiler. So if you click the button over here, you can see an example JSON file that will run all your compiler settings, so you don't have to do it by that. In deploy and run, there's a bunch of new providers, environments, and now for beginners, it's easier to see which one is the injected Web3, the injected provider, and it will say the name of the injected provider. Also now, like there in the environment section, the top link goes to chainlist.org, so you can find the spec of the chain you want to deploy to. And when you're looking at one of the L2s, it will go to a bridge to get the funds for that. Debugger got wider. There's a console.log, just like Hard Hat. And to get to the documentation, you got to click that little caret, it opens, and then you can click the book to get to the documentation. And also the little green check mark means that Remix is owner of this code. We have a little bit updated Viper, so you can go to the Viper plugin, click that, and it'll download the Viper Lang repo. And there's a transaction recorder, which probably none of you have ever used, but you should check it out. It's in the middle of the deploy and run. And the browse and grab, if you go to a verified contract in Etherscan, you just change out the Etherscan for Remix, and it'll open it up in the editor. And now, questions.
Thank you first. Oh, 3. So much. Yes. We have questions in the back coming up already. Yes. Take a moment for the mic to get to you.
There's a question there.
Yeah.
Yes. It's a question about, I see, I know there's already some integration between Remix and Swarm. I'm just wondering if you have any thoughts on the future of where that might go.
I guess we're in open conversation with them. Right now we're adding the postage stamp, so you could publish to Swarm. The next steps I'm not entirely clear about, but we like to. That will be going on, continuing, not dropping.
Okay. Anyone else? Yeah. Oh, here in the back, over there.
Hey, just a quick question. Are those features already available, or do we have to wait?
No, those are all available.
Awesome, thanks.
At the front here as well. Yeah.
Hi, it's a simple question. Is a way to enable Bing mode? Because right now I'm using a browser plugin, but I hope that you can support the Bing mode online.
Mobile?
Bing mode, the Bing editor.
So yeah, we spent some time to improve the editor, like the Monaco editor, and then I think it's some request that we had last year, and I mean, we are looking at that. It's not like something we will prioritize for now, except if you would push for it. But yeah, we could do it. Yeah.
Well, it could be great.
Push for it, and we would do it for sure.
Thanks.
Let's see. Anyone else? Okay. In that case, I'd like to thank you again, all three of you.
Thank
And
you.
give them a round of applause, people.
Thank you so much.
And just to check, gentlemen, Rob, where can we find you later? Okay. in the room, when they're back up. In the meantime, I'd like to announce our next speaker. It will be Lawrence Breidenbach, talking about improving the Oracle infrastructure on Ethereum. And Lawrence is in the house here somewhere. We have seen him. And he should have a mic as well. Somewhere in the back. Okay. Welcome, take your seats. Yes. Is he not here? Oh, he's in the back. Okay. Okay. Yeah. Okay, let's give him a warm applause.
Hello, everyone. My name is Lawrence. I'm head of research and development at Chainlink Labs. And yeah, today I'm excited to tell you about improving the Oracle infrastructure on Ethereum. For those of you who don't know, Oracle infrastructure connects smart contracts with the rest of the world outside the blockchain. And so let me start by talking about the most prominent use case of Oracle's, data feeds. I'll start by reading a quote. We'll play a little game. You guys can, while I read the quote, guess where the quote is from. I'll give you a few more seconds after I'm done reading the quote, and then I'll reveal the answer. So the quote is, for example, one powerful use case of an Oracle contract would be a hedging contract where A and B put in $1,000 worth of Bitcoin, and after 30 days, the script sends $1,000 worth of Bitcoin to A and the rest to B. This would require an oracle to determine the value of 1 Bitcoin in US dollars. Sounds a little bit like DeFi, but the terminology is a bit different from what we would say today. So the solution is, it comes from the Ethereum white paper all the way back in 2014. So already back then, it was clear that oracles are required for certain types of applications. And indeed, here we have an example of a price feed or data feed oracle. And if we think a little bit about the properties that this implies that we need our oracle to have, there's two things that stand out. So first of all, we need reliability. We need to make sure that when the 30 days are up here, indeed, the oracle supplies the exchange rate between Bitcoin and dollars, so we can fairly settle the hedging contract. And then we also need security and integrity, right? The price that is provided here by the oracle will be used to settle the contract. And so if the price is incorrect, then we won't be able to settle the contract fairly. So it's essential that we have an oracle that provides these properties. And I think if we think about the history since then, billions of dollars have been stolen in oracle manipulation attacks. So oracle security is paramount for DeFi. So let's have a look at how one might construct such a data feed oracle. And I'll start with a strawman construction, and then I'll evolve that construction into what I would say is the state of the art today, and is what Chainlink does today. So here in the strawman example, we have a data source that the oracle observes. In this case, the data source says, hey, $10 is the price. The oracle will sign that price, and it will then provide it to a contract running on chain, and then a dApp contract can read the price from our data feed contract. But if we think a little bit about the two properties I had just mentioned, reliability and security, then this system does not achieve them because we have a single point of failure. If this oracle goes down or fails to provide the price, then the system on chain won't work. And similarly, if the single oracle here is compromised or malicious, then it can feed a false price to the contract on chain and cause the contract to be settled incorrectly, unfairly. So how can we solve this problem? Well, there's a few different approaches that people commonly take, but I think the most common one today is to say, let's decentralize the oracle. So let's have a bunch of independent oracles all provide the system together. And so what we've done here is we now have multiple oracles that each fetch a price from a data source and then send their individual signed observations to a contract running on chain. And that contract on chain stores the observations until there's a sufficient number of them, then aggregates them into a single price using a robust aggregation. For these data feeds, the typical aggregation one would use for numerical data is to take the median, because that's a robust statistic that doesn't respond to, for example, false outlier values or things like that. And then, once we have medianized our value, we can expose it to the dApp contract downstream. And this is nice because we can now handle subsets of oracles being faulty, right? So if some of the oracles here do not send a price, or if some of them send false data, that's OK. If they don't send a price, our data feed contract can just handle that by ignoring a certain number of missing submissions. And if they send a false price, as I had mentioned, we use the median, which is a robust statistic, and which ensures that as long as no more than half of the oracles here are faulty, the aggregate price still lies within the interval of prices reported by correct oracles. So this works well in terms of giving us the security properties and reliability properties we want. But there's a problem here, right? If you're familiar with smart contract development, notice that we're sending one transaction per oracle here. We store the submissions in state, and we compute an aggregate on chain, all of which are expensive things to do. And indeed, this is how Chainlink used to work in the past with a system called Flux Monitor. And indeed, that became prohibitively expensive. And so we moved on to the next generation, which I'll describe now. So I would say that the state of the art then is to say, let's move as much work as possible off-chain. The less we need to touch the chain, the more efficient our system is going to be. But we'll want to do this in a way that preserves the security and reliability properties that we desire. And so roughly speaking, what we do here is we again have our oracles observing prices from their respective data sources. But now we have the oracles communicate with one another using a peer-to-peer network. And we, for the distributed systems folks out here, have them run a Byzantine fault-tolerant protocol. Byzantine fault-tolerant means that they can handle arbitrary faults. So any of these oracles could be, malicious or faulty or down or whatever else. And as long as, some subset of them is affected by this, depending on exactly how you set up the assumptions, either less than a third or less than half of the oracles, the overall system will keep functioning correctly. Chainlink's version of this is called the off-chain reporting protocol. And indeed, it's far more efficient than the predecessor I had just showed you. So we realized something like 90% on-chain cost savings. And this is good for security, because it means that with the same security budget, we can have a lot more oracles. So we can tolerate more faulty oracles in the system. And it's also good for reliability, because in this system, at the end of the off-chain protocol, every oracle ends up with an identical copy of the report, which is signed by a quorum of the oracles. And the contract will then validate that the report is indeed signed by a quorum of the oracles. And what this means is that as long as a single oracle is able to get a transaction on-chain, the overall system will keep functioning correctly. And so, for example, during times of chain congestion, this is very desirable. So indeed, as I mentioned, right, this is how the Chainlink off-chain reporting protocol works. And it's been very successful. So we designed it for powering data feeds on EVM chains. It's been running reliably and securely for, at this point, 1.5 years in production. It secures roughly $20 billion of value across all the various chains that Chainlink is active on, 14 billion just on Ethereum. There's more than 1,000 feeds across all the chains we're active on, and more than 290 of those are on Ethereum. And I think the reliability and security of the system are also shown by the fact that we have major DeFi protocols relying on this system, like names such as Aave, Compound, and Synthetics all use this. Cool, but OK, so I told you about data feeds, but now I want to tell you that oracles are about a lot more than just data feeds. They enable, in the general sense, interactions of smart contracts with the outside world. That is to say, things that are outside the blockchain a contract executes on. And so they empower smart contracts to reach their full potential, because now I can do a lot more interesting things with my contract than if I'm just isolated on the blockchain and cannot interact with the outside world. So here are some of the capabilities that are enabled by oracles. Data feeds I just talked about. Proof of reserve. I can ensure that on-chain assets are sufficiently collateralized by some off-chain reserve of funds, by having independent oracles monitor that reserve of funds and report how large the collateral is. Secure randomness, contract automation, and cross-chain interoperability I'm going to talk about more later in the talk, so I won't go into them now. Fair sequencing, I can use an oracle network to protect users from toxic MEV extraction by fairly sequencing transactions. I can outsource computation and storage so that I can enable contracts to scale beyond what the EVM provides. As much as we all love the EVM and as much fun as gas golfing is, there are some things that are just a little bit hard to do on the EVM. And then finally, I can also enable oracles to perform real-world actions. So we actually had a hackathon a couple of months ago inside Chainlink Labs, where we had contracts ordering pizza via the Pizza Hut API to people's houses. So I think that's a pretty neat use case that is enabled here, and that would not be available to contracts natively. And then finally, we can also provide privacy-preserving access to almost any Web 2.0 data, and I'll cover that also towards the end of my talk. So this gives rise to this notion of hybrid smart contracts. And when I say hybrid smart contract, what I mean here is a hybrid system that partly operates on-chain in the form of a smart contract running, say, on Ethereum, and partly off-chain, operated by a network of decentralized oracles. And so this overall hybrid smart contract is now able to interact with the real world. And so this enables me to do all sorts of interesting things. And let me give you some more specific details on some of these. And I'll start by talking a bit about secure randomness and what that enables contracts to do. So as you're probably familiar, there's kind of two on-chain native ways on Ethereum these days to get random values. One of them is the block hash opcode, and that's sort of audit findings 101. Do not rely on the block hash opcode for randomness. Any block producer can easily tamper with that. And now, since the merge, there's also a second opcode, prev_randao, which is a little bit better than block hash, but which is still manipulable by block producers. And so the output of both of these can be biased. So if your contract needs secure randomness, for example, for running a lottery or for doing a NFT mint where you assign valuable random attributes to your NFTs, these are not good enough. And so on-chain, there's no native capability to get good randomness. And this is where oracles come in, and oracles can provide that functionality. We have a cryptographic construct here that's called a verifiable random function, and that enables an oracle to provide tamper-proof randomness. And let me explain how that works. So we start here with our DApp contract that, if it wants some randomness, can request from another contract on chain that's part of this VRF service some random words. The contract will emit an event with just telling the oracles that randomness has been requested. The oracles will evaluate the verifiable random function, which is based on deterministic public key cryptography. That is to say, the oracles actually have no ability to change the output. It's deterministic. So based on a given key pair and a given blockchain state, which is used as the input for the VRF, we will always get the same output value, the same randomly distributed output value. And the oracles will then provide a cryptographic proof that they correctly evaluated the VRF. We'll send that cryptographic proof to our coordinator contract here, which can cryptographically verify the proof. And if indeed the verification succeeds, then finally the coordinator can send the random output here to the DApp contract, which can then, for example, run its lottery or whatever else. And this is live today in production. If you are writing a contract and you need this functionality, you can use it. And I think there's over 1,400 unique contracts that have used this in the past 30 days. So OK, randomness is cool. Now let me talk to you about yet another use case that is live today and that enables contracts to do more interesting things. And that is contract automation. Once again, I'll return to the quote from the original Ethereum white paper in 2014. But this time, I'll highlight a different part. So here we have, after 30 days, the script sends $1,000 worth of Bitcoin to A and the rest to B. So how does the script do this? How can the script or the smart contract send those funds to A and B? Contracts do not have an ability to initiate their own execution, right? And of course, I could say, well, I'll just have my users A or B here, call the contract after the 30 days are up, and then I'll do a payout. And maybe if I just have 2 users, that's fine. But now let's say I have a lot of users, or I want to sweep a bunch of tokens from different contracts into a single pool, or whatever other expensive maintenance action my system requires to run. Then that will lead to a very poor UX if I put the onus of performing those maintenance actions on the users interacting with my DApp. Because if I'm a user, I now have a non-deterministic gas price, right? Once in a while, when I interact with a DApp, it's going to cost me 100,000 gas. Another time, I need to maintain some expensive maintenance on the side, and suddenly it's going to cost me 500,000 gas. That's not great. It's also unreliable because I can't really rely on my users calling the contract at a specific point in time. And so this is where contract automation comes into play. So once again, here we have a set of oracles or automation nodes that are monitoring the chain. And the upkeep contract here is the DApp contract. And the upkeep contract is just any regular smart contract written in Solidity or Viper or whatever programming language you prefer. And it has a special function called check upkeep. And that function will be evaluated by our Oracle network here whenever a new block is mined. But it will be evaluated in a simulated environment using the, say, fcall RPC endpoint of an Ethereum node. So we never hit the chain with these evaluations. No transaction lands on chain. And so we can call this on every block without incurring any cost. And so then the programmer of this upkeep contract can basically come up with any arbitrary predicate to decide whether their contract ought to be called or not. And if the contract says, no, I don't want to be called, no problem, we just check again in the next block. But if indeed the contract wants to be called, it can indicate so to the Oracle network, which will then send a second, or will then actually send the first real transaction to the chain that's not simulated with a perform upkeep call for our upkeep contract here. And now this contract on chain can take whatever logic it wants to. So for example, in the previous case, at this point, it could have paid out our two users A and B, depending on the outcome of this hedging contract. And again, this functionality is live today. There's over 250 unique upkeep contracts that have been active in the past 30 days. And if that's useful for your smart contracts, then I would encourage you to check that out. OK, so I've been talking a bunch about data feeds and about other Oracle capabilities that are live today. But I'm from research, right? So I'm particularly excited about the future and what future capabilities we're actively working on to bring to market. And I'm going to present two exciting capabilities, and both of them are in an alpha stage with partners. So both of them are already working in some form, even though they're not quite ready for mainnet production yet. And the first of these is cross-chain interoperability. So the problem here is that smart contracts cannot natively interact with smart contracts running on other blockchains. But we live in a multi-chain world now, right? There's dozens of chains out there. It's a very heterogeneous environment. Some are L1s, some are L2s, some use the EVM, some don't, and so on and so forth. And so indeed, there's also a lot of demand for bridging between contracts on different chains. So to date, something like $168 billion of value have been bridged. Just in the past 12 months, we've seen over 2/3 of the total volume ever bridged for something like $115 billion bridged. But also, we have a challenge with security in this cross-chain space. So to date, $2.5 billion have been hacked from cross-chain protocols. And just this year, over 70% of all value stolen in kind of the blockchain ecosystem is from cross-chain hacks. So I think, once again, this indicates that security is paramount, and that, unfortunately, the current solutions are not yet up to the task. So we at Chainlink are also working on a solution to this problem, which we call the cross-chain interoperability protocol, CCIP. And so here we're working on a programmable bridge that enables a smart contract, that contract here, say on Ethereum, to send a message to a contract running on some other chain. And it could be talking to multiple other chains. So here I have it sending a message from Ethereum to this other chain, B. And the message can carry both data, so some kind of arbitrary binary payload, as well as value, so say tokens. And again, I need oracles for this, because inherently the other chain B or Ethereum have no way of knowing what happened on their counterpart chain that they want to talk to here. And so oracles can bridge that gap, and they can transport information about what happened on one chain to another chain to enable contracts on different chains to interoperate. This is, again, as I mentioned, it's very important that this is done securely, because if for some reason here I were to get false information about what message was created on Ethereum, then that could, for example, lead to funds being moved on this other chain here when they shouldn't be, and I would have a security breach. If you want to learn more details about this, we just had a talk at SmartCon roughly 2 weeks ago where we went in more detail about the architecture of CCIP. And it's on YouTube, so I'd encourage you to check that out if it's interesting to you. The second Oracle-enabled capability for the future that we're working on is about providing privacy-preserving access to Web 2.0 data, to almost any Web 2.0 data, to smart contracts. And this is, I think, a super cool capability. At first, it sounds a bit unreal, like how does this work? How could this be? So let me show you what I mean here. So the fundamental problem is that the vast majority of data is private and is therefore not publicly accessible in the Web 2.0 ecosystem. So for example, my online bank account, my Twitter profile, my Facebook profile, my Amazon account, some government website, none of these are accessible by smart contracts on chain. because all of them are behind some kind of authentication wall, right? And I would argue that's a good thing. I don't want my bank account information to be just visible to any contract on chain. But still, it would be kind of cool if there were a way to expose in a privacy-preserving information just the information required to smart contracts on chain, because that would unlock, I think, many interesting use cases. Things like decentralized identity, risk scoring, where I can use information about my off-chain behavior to score how risky of a borrower, say, I am. Consequently, under-collateralized lending, where maybe in order to borrow $100 worth of assets, I don't have to put up $200 worth of collateral on chain, or private DeFi instruments, where I can have a DeFi instrument where only the parties that are participating in that instrument need to learn, what exactly the conditions of it are, based on what condition it's settled, and so on, to improve privacy of on-chain trading. And more things that I probably can't even imagine yet. This is a very general technology. And so the technology we're working on here to address this is called DECO. DECO was originally researched at Cornell University and IC3, the Initiative for Cryptocurrencies and Contracts. And since then, Chainlink has pushed the project forward, is actively developing it and further researching it to make it efficient and practical. And so I'm briefly going to describe to you how DECO works and what properties it affords. First in the abstract, and then by going through an example. So we have 3 off-chain parties here. We have a web server, we have a prover or a user, and we have a bunch of verifiers or oracles. And so now what DECO enables the user to do is to prove to these verifiers, and then by extension to the smart contract, that some data indeed comes from a certain web server. So for example, I can show that indeed bank.com made some statement. We assume that this web server runs TLS, which is the standard protocol for securing communications on the web today. Whenever you go to some website, you'll probably see a little lock icon in your address bar indicating that the connection is secured with TLS. So I can prove provenance, so I can show that the data indeed comes from a certain source. But I can do this in a privacy-preserving way, where I can run a zero-knowledge proof protocol to only reveal the information, the minimal information that I want to reveal to the verifiers, and then by extension again to the contract. So the web server, obviously, if it's, for example, my bank, knows my balance and my password. I, as the user, also know my password and my balance. But the verifiers or oracles, for example, should definitely not learn my password, right? And DECO enables me to do this in this privacy-preserving way. And then finally, and I think this is actually the coolest property of DECO, it's compatibility. So it's compatible with the existing TLS web ecosystem. And that means that there's no need to get, for example, the data holder here, the web server, to change anything about their API or their stack. They don't even need to know that DECO is being used to prove something. And if you, for example, look at how hard it is to get the internet migrated to IPv6, you know that protocol upgrades are very difficult. So it's, I think, a game changer here that this works with the existing Web 2.0 ecosystem without requiring modifications on the part of the web server or the user. So let me show you an example. So I'm the prover, I'm the user here. My name's Lawrence, and I want to show to a contract on chain that my bank account balance is greater than $1,000 without revealing anything on top of that. So what I'm going to do is I'm going to connect using TLS, indicated by the green locks here, to the API of my bank using TLS. So I'm going to say, hey, I'm Lawrence. My password is Hunter2. What's my balance? And now the bank API will respond, hey, Lawrence, your balance is, say, $5,000, which, remember, I do not want to reveal to the verifiers or to the contract. As part of the way the handshake works here between me and the banking API, I'm also able to, just as part of this TLS exchange, ensure that the verifiers or oracles here get a cryptographic commitment to the data that is being exchanged. And that commitment is, as we say in cryptography, binding and hiding, which is to say that if so you can think about it as an envelope where I put some data inside. If you just have the envelope, you cannot see what's inside. but you also cannot switch the contents without somebody noticing because you kind of tore the envelope. And this is basically a similar thing here. So the verifiers hold a cryptographic commitment about any data that was exchanged within the session. So I, as the user, cannot sort of alter the data after the fact. But the verifiers do not see what's inside the commitment. The commitment is hiding. So they have not learned at this point any private information, any information at all about what was in the TLS session. And so now we get to the final step, which here I'm abbreviating with ZKP magic because I have like 2 minutes left on this talk. But the way this works is that we now run an interactive zero-knowledge proof protocol between the prover or user, so myself, and these oracles. And as part of that ZKP protocol, I can convince the oracles cryptographically that indeed, for example, this statement holds, so that my balance is greater than $1,000. But that is the only thing they will learn. They will not learn my credentials, and they will not learn my precise balance. The oracles can then cryptographically sign an attestation that they have successfully verified this zero-knowledge proof, and this attestation can be forwarded to our smart contract on-chain here. Again, signed by a quorum of oracles, and then we can verify in the contract that indeed those signatures match. And so now I have convinced a contract on-chain that I have at least $1,000 in my contract, and I've done that without having revealed any additional information. And you can think about this in a far more general sense, because this zero-knowledge proof, I could basically prove almost any statement about the data that was exchanged in almost any TLS session. So this is a very general and very powerful technology, I believe. And I'm excited to see what people are actually going to build with it, because I think due to its generality, I personally have a hard time imagining what's going to be enabled by it. So yeah, thanks a lot for listening to my talk. There is 3 things I'd like you to take away. So first of all, security and reliability are paramount for oracles. Second of all, oracles are about a lot more than just data feeds. I think I've shown you a bunch of exciting applications of what oracles can do. Yeah, and third of all, I think we have a opportunity to make contracts more exciting, more interesting, to empower them to reach their full potential beyond just doing things within the closed on-chain ecosystem that they would naturally operate in without the aid of oracles. So yeah, thanks a lot. And if you have any questions, I think I'm over time, so just come and find me after the talk, and I'd love to chat.
You have time, actually. You have time, actually.
Sorry?
There's time allotted for your Q&A. So there's room for questions right now.
What did you say?
There's room for questions right now. There's a time allotted for your Q&A right now.
Okay, sure, I'll take a question.
So I see one in the front here. Let's see, where is our microphone? Oh, there. There first. Yeah.
Test. Okay. So, how are the gas fees paid by the contract automation?
Sorry, could you repeat the question? I couldn't hear it.
In contract automation, how are the gas fees paid?
Ah, I see. So basically what happens is that the dApp that relies on contract automation, we'll maintain a balance. I don't know whether I can go back to that slide. No more. Anyway, so it maintains a subscription balance with an automation registry contract that sits on chain. And then when the dApp is invoked by the Oracle network, that automation registry will keep track of how much gas is used as part of that transaction, the perform upkeep transaction, and will bill the user's subscription for that. So, and when I say the user here, I mean the upkeep contract. So in that sense, as long as the subscription is funded, we will just automatically have the contract deduct the price of the upkeep from that. Does that answer your question?
Yeah. Yes.
Perfect.
There was another question here at the front and another one in the back. Yeah. We're going to the back first. You're not forgotten. Yeah.
Hey, here. Oh, here in the back, yeah. Thanks for the talk first. I'm just wondering, you showed us the diagram of how the Oracle understands the fact that the user has like more than $1,000. But you also show that the user, the Oracle can see that the transactions between the user and the bank API without actually seeing the balance, right?
Sorry, I'm having a hard time acoustically understanding you.
Am I doing
There's
something
a lot of
wrong
reverb
here? Test. Can you hear me now?
Yeah, let's just try again. We'll get there.
Can you hear me now? Is it better now?
No, now I can't hear you at all.
Yeah. So you showed us that diagram where the user and the bank API exchange those messages, right?
So this is about Deco, right?
Yeah.
Too bad we can't show the slide. Yeah, okay.
So the bank says that the balance is 5,000, and Oracle sees that, but without seeing the balance, right? And then
so the Oracle does not see the $5,000, right? The Oracle just has a cryptographic commitment against which we can then perform an interactive zero-knowledge proof.
Exactly. I'm just wondering how the Oracle then can verify that the balance is over 1,000 without like showing that the balance is 5,000, right? Because the exchange was only like containing information about 5,000 and not about like 1,000, right?
Right. So my short answer, and forgive me, is just going to be magic zero-knowledge proofs. Basically, that's what ZKPs are about, right? I can prove statements about data in sort of very counterintuitive ways without revealing anything beyond the statement. But I think we probably don't have time to go into the details of how that works, unfortunately. But come find me afterwards, and I'm happy to talk more.
Final question here at the front.
Yes. So I have a question about the OCR, the off-chain Oracle reporting protocol. So with blockchain, it's easy for the different nodes to reach consensus, right? Because they can check the transaction signature, they can rerun all the bytecode of smart contract. But with the Oracle, how does the different node reach a consensus? Because if it's a data feed, then you cannot compute, right? You cannot compute whether data feed is correct or not.
Okay, I'm not entirely sure I understood the question correctly, so let me take a stab at an answer and then ask again if I didn't get it. So I believe that the answer to your question is OCR is a Byzantine fault-tolerant protocol that is actually the same family of protocols that consensus protocols are from, right? It uses similar techniques, it just has a different goal. Its goal is to provide reliable and secure reports about some data observed from off-chain to contracts on-chain. But it's similar techniques, and so you kind of, as part of how that protocol works, get that property that the oracles communicate with each other over the peer-to-peer network, and that some of them can be faulty and so on. So you broadcast things, you converge cast things, you use digital signatures, the usual type of things you would do in BFT protocols.
Yeah, I mean, if let's say if it's Ethereum or if it's other blockchain, different nodes just have to have a similar result from the executing the transaction, have a similar result. If two-thirds of a node have a similar result, then can reach a consensus, right? But with I understand with you can use that for the consensus layer, but how could you have Byzantine fault tolerance for the data field, right? Data feed. For example, if one node say the price of Ethereum is 1,000, another node say the price of Ethereum is 2,000, you cannot. How can them reach the consensus?
Sorry, it was a little hard to understand, unfortunately, because there's so much reverb in here. But I think what you're asking is how we reliably aggregate the data inside OCR. Is that correct?
No, for computation task, it's very easy to reach a consensus between different computers, because as long as the result of computation is the same, if two-thirds of node computer agree, like the result of the computation result of one transaction is the same, then you have a consensus. You are fine. You are good. But with data feed, like let's say if 1/3 of a server or node, Chainlink node think the price of Ethereum is 1,000.
I see. I think now I get the question. Okay, so basically inside the OCR protocol, which I did not have time to explain in detail here, there is a phase where the different oracles converge cast their individual observations to each other. And at the end of that phase, every oracle will have a signed observation from every other oracle. So if we have a bunch of oracles in here, every oracle will know what all the other oracles think the price should be. And at that point, I can then have everybody compute the same kind of deterministic aggregation function, and I will end up with the same outputs, and so I can reach agreement between the different oracles. Okay. Does that answer the question?
Yeah, it's somehow
Perfect.
answer my question. How many?
Please, sorry, no follow-up questions.
Just one quick follow-up question. How many nodes?
Let's do it afterwards.
Yeah, let's just do it afterwards.
Okay. Cool.
Thanks.
Thank you. I'd like a big applause for our speaker today. Hold on.
Thanks, everyone.
And as we'll take a moment to prepare the stage, everyone who comes in, just please settle in, take your seats. We will be talking about decentralized programmable key pairs. And for that, we will have both Chris Cassano and David Schneider available, waiting to come up the stage. Okay. Let's give them a warm applause, people. Yeah.
Good afternoon. All right, my name is David Snyder, that's Chris Cassano, and as you can see, we're going to talk about decentralized programmable key pairs. We are the two co-founders of a project called Lit Protocol, and to start with a big, exciting hook, we are living in a world where with threshold cryptography, from a certain point of view, you can consider that private keys no longer exist. So what do we specifically mean by this? This lit network is essentially a distributed custody programmable key, and one of the key technologies at the heart of this is something called a DKG, a distributed key generation. And so what lit is specifically is a distributed network of nodes that are custodying shares of an underlying private key. I'll take a quick moment to talk about how security works on this network, and then we'll get into some of the use cases. But essentially, this key is formed in this distributed key generation context and stored as shares across these nodes. And then all of the nodes operations take place inside of a trusted execution environment. And then there are named node operators who are staking that are running the programs on this underlying key. And so now let's talk about what some of those programs can be. So as you know, a key can functionally do two things. It can read or encrypt and write, and this network provides the same functionality in a programmatic way. So let's talk about how the read works first. The hexagons in the middle represent the lit nodes. In this case, Alice, let's say, is a creator and wants to say anybody who owns Alice's NFT can see her video. She would encrypt that video client side and store it somewhere in public, whether it's on a blockchain or a storage network like IPFS, and then create a set of rules that says only somebody who owns Alice's NFT can see that video. Bob owns that NFT. He shows up later. He signs a message, and he broadcasts that to the nodes. Each of the individual nodes validates against the blockchain, does Bob own that NFT? And the whole kind of frame of view here is thinking about these public storage, public state machines as access control lists. At which point the nodes verify that Bob has that node, or has that NFT, and each of the individual nodes produces something called a decryption share. You could think about this like an authorization. Those authorizations are then sent to Bob, who's collecting them client-side. And a good mental model is kind of similar to the way that you may think about torrenting. Torrenting, you're collecting little bits of media from a bunch of nodes. In this case, you're collecting bits of authorization. And once you've collected a threshold of those authorizations, in this case, decryption shares, Bob can reproduce that symmetric key associated with the video or that content and decrypt that client-side. And so some of the applications that we're seeing this used for today are things like token-gated social media, like token-gated chat. This technology is used hand-in-hand a lot with like the Lens protocol, for example, where only let somebody who's following me on Lens see my posts. We also see this happening in the context of intellectual property, whether it's token-gated videos or various other content. And then really excitingly, there's also been a lot of stuff around verifiable credentials and selective disclosure. So I'm sure you all are familiar with the notion of like signing in with Google as an authorization method for how one logs into a site. What we're starting to see is some teams build this out in a much more kind of user sovereign type of way, whereby when a user logs into a site, they're conveying decryption rights, or quote, the read rights, to that application to see their private information. And it starts to become like a pretty interesting picture, and we'll talk more about what this user-owned web looks like. But in a way, this is kind of one definition of Web3, where the user, rather than necessarily showing up to a website with their own kind of self-sovereign server, they're arriving with their own encrypted shard of the open web, and then selectively disclosing to various friends or applications what information from that shard they can decrypt or read. And so this product has been out since January. We still are running all the nodes centrally, and we'll have those decentralized by the end of the year. And there's hundreds of applications that are leveraging this. But just last week, we started talking publicly about new capacity, which is the ability to essentially do distributed custody programmatic signing. And as you can see, the architecture is incredibly similar, but instead of the nodes reading the blockchain as an access control list, they are reading programs that are stored at a specific CID on IPFS. Each of those nodes is running those programs, and now in this case, instead of producing the decryption share, which lets that party decrypt some content, they're producing a signature share. Again, coming back to the idea that keys can functionally do two things, kind of encryption and signing, and then those shares can be aggregated, and you can make a write to your favorite decentralized state machine, like Ethereum. And so talking about some of the applications for this, there's a huge list, right? Thinking about a key as an application development platform, we kind of like think about it as a paintbrush. We're really just starting to explore some of the application potential here, but I'll run through a couple right now. So one would be like DeFi automation. The state of the art for self-custody DeFi today is if you have some staked tokens and you have to, the state of the art is to sign up for some DeFi alerting service such that when the price starts to drop, you get a text, you have to wake up in the middle of the night and push a button on your ledger. But in a world where you've staked those tokens from one of these cloud wallets, as we can kind of call them, you could have that program listening to a feed, and when the price drops, have a program that kicks off that unstakes the tokens, sells them for USDC on a DEX, and sends them to your ledger. And this is all happening kind of without a human signer in the loop, because the key is custodied in this distributed context at the network level. Chris will talk a little bit more about vaults, but in a way, what we're talking about here is making private keys liquid. So you could send a bunch of NFTs and tokens to a given address, and then trade the underlying ownership of that address. There's also a lot to explore here as it relates to account abstraction, doing things like hooking up biometric auth, like Apple Passkey as the auth method into one of these cloud keys in this whole context of how do we bring the next billion users into this ecosystem and abstract away the complexity associated with the seed phrase. This is really exciting, and certainly a lot to explore in the context of cross-chain messaging and bridging as well. And so with that, I'll pass this clicker off to Chris.
Thank you, David. Yeah, so I'd like to introduce the idea of a decentralized programmable key pair, which we call PKPs. A PKP is an ECDSA key pair that's held as private key shares, custodied by the lit nodes. You can create a PKP by minting an NFT that represents ownership over that PKP. And so whoever owns that NFT can ask the PKP to sign anything on their behalf, including Ethereum or even Bitcoin transactions. You can do this by writing some JavaScript code that we call a lit action. So this is a really basic hello world lit action. It literally signs the string hello world with ECDSA. And what happens is this code will be run on all the lit nodes in parallel. Lit actions live on IPFS and are immutable, just like smart contracts. And I just explained that whoever owns the PKP NFT can request a signature using the PKP. But what's actually more interesting is that you can also grant the ability to sign using your PKP to a lit action. This is very similar to the token approval pattern that we use on Ethereum, where you can grant a smart contract the ability to transfer your tokens. But instead of granting the ability to transfer tokens, you're granting the ability to sign anything with this programmable key pair. So here's how it actually works. The user can create a lit action execution request, which you can see at the top there. Oops, wrong button. I think I had a laser, cool. And they pass in an IPFS CID, which is some JavaScript code, and a cryptographic signature that could come from their Ethereum wallet, an Apple passkey, or any public key cryptography scheme. They send that execution request to all of the lit nodes in parallel. The lit nodes use a JavaScript runtime to execute the lit action from IPFS. They check the PKP authentication by talking to a blockchain where the PKP NFT lives. And the lit action can also make arbitrary HTTP requests. So it can also act as a kind of oracle. Want to switch? Okay. It can also act as a kind of oracle. So you can pull any data in and use it in your JavaScript lit action. The lit action can request a signature using the threshold private key share. That creates a signature share that gets sent down to the user that initiated the request. They could be using a browser, or this could be like a server-side client. They combine those signature shares, and they broadcast that signed transaction to Ethereum or any ECDSA blockchain. And I'm talking about a transaction here, but it doesn't actually have to be a transaction. It could be any signed data, like a write on a ceramic or anything else like that. An interesting pattern that Lit supports is called mint, grant, burn. The idea is that you mint a PKP, grant it the ability to use a lit action, then burn the PKP in a single atomic transaction. This means that the PKP can only ever be used by that lit action, because burning the PKP makes it impossible to use the PKP for signing anything else. A kind of fun toy example would be creating a lit action that takes any number as input, but will only sign that number if it's prime. Since anyone can check that the signature matches the public key of the PKP, they know that any number signed by the corresponding private key must be prime, and the signature acts like a proof that the number is prime. You end up with a kind of prime number certification system. This can be used to create a proof of any JavaScript code execution, and this is kind of similar to how ZK proofs work conceptually, but instead of being proven by pure math, it's proven by the guarantees provided by threshold cryptography via the lit network. And here's kind of how that works. The way that you interact with and grant access to use things is by talking to a PKP smart contract that currently lives on Celo, but we're going to move that to Polygon soon. And you mint the PKP, grant access for it to use the lit action in this authorized lit action table, and then you burn it all in one transaction. So we talked a little bit about using a PKP as a vault. You can mint a PKP, then send a bunch of assets to it, like NFTs, tokens, Ethereum, and even ones not on Ethereum, like Bitcoin or Cosmos tokens. Then you can sell the PKP NFT on OpenSea and transfer all the assets at once. You are essentially trustlessly trading a private key, something that has been impossible until now. This breaks soulbound tokens, because now you can trustlessly sell the wallet that contains your soulbound tokens, in the same way that you could sell a traditional non-soulbound ERC-721 NFT. This also enables things like liquid staking for chains that lock up the staked tokens, like Ethereum 2. You could use a PKP as an EOA cloud wallet. Because a PKP can grant the ability to sign to a lit action, you can create any auth method that you want, as long as it's possible to express it in JavaScript. You could create a wallet that will only sign if the user calling the lit action is a member of a DAO. You could use another signature algorithm for verification that's unsupported by Ethereum, like ED25519 or BLS. You could even create a wallet that will only sign transactions on Tuesdays. You can use a PKP for automation. Because the lit nodes do the actual signing, you could create a lit action that checks the price of a token you're staking, and if it drops below a certain price, unstake the token and sell it. This works across chains and could run while you're asleep. You can make any sort of complicated automated trading bot without needing to have a hot wallet sitting on a server somewhere that will get hacked when you forget to update your Linux distribution. And here's some ideas of a lot of different things that you can build. I won't read them all, but
yeah,
you can check them out.
We could talk about some of these ideas, I think, is worth pointing to, but maybe just to a few more metaphors. Like, one of the ways that I really like thinking about this programmable key pair notion, what we've been calling a PKP, in a way, like the centralized equivalent is thinking about this like an Amazon Lambda function plus the Amazon KMS. But in this case, the KMS isn't something that's centralized. It's distributed across this threshold cryptography-based network, and these lit actions are the equivalent of the Lambda functions. And so it's this distributed system for doing the same type of operations that you would build with Lambda function and Amazon's KMS, but in this case, you as the application developer, when you come and bring customers on board, you have this kind of distributed backend where you can't get access to the keys, where if you like build a DeFi automation bot and start selling to somebody as a subscription today, you could jump into Amazon's KMS and grab the keys and the funds out at any point. A couple other interesting things that I think are really fun to think about when we start to think about the notion of kind of this cloud key. There's a lot of implications for this as a DAO's key. So we could talk about DAOs and DeFi and user-owned social media. But in the context of a DAO, the current state-of-the-art for DAOs is, of course, to use smart contract wallets to manage their treasury. But more and more, especially protocol DAOs, we're seeing things that want to extend cross-chain and cross-ecosystem. And so to start to think about the account abstraction, not at the level of the blockchain, but at the level of the signing algorithm, and creating the rules and the governance around this at the level of the signing algorithm starts to get really interesting, because you can have the same rules around governance, issuing verifiable credentials for your DAO, making transactions on ETH, doing rights to ceramic, all from the same underlying curve. And then, yeah, I think another one that's kind of really interesting here is thinking about this in the context of mainstream adoption. We touched on this a little, but you know, there's always capacities to add different levels of authorization and security to wallets, but we've been really, really excited about groups that have started to integrate this with the likes of Discord and Apple Passkey, and there's definitely a lot of opportunity to build really sophisticated tooling in this ecosystem. It's one of the reasons that we were really excited to give this talk. Like, we have a core team that's super focused on this threshold cryptography component, but there's all kinds of opportunities to like stick an email server inside of an enclave and use that as a methodology for authorizing this with email. That's something that we're not going to build internally. And so if this kind of tooling and privacy tooling and mainstream adoption tooling is something that you're interested in, definitely come talk to us. But yeah, maybe we'll keep this slide up, and we'll take questions for the next 10 minutes if there are any. Thanks so much.
Yes,
there's one in the back.
there's questions from the audience. In the back? I see you in the back. Where is our microphone? We have a roaming microphone, which is moving. Yeah.
I have a few questions. The first one is, how do you establish the, oh, well, it reverbs a lot. How do we establish the trust relationship between the client and the nodes? Because like anyone kind of like snooping on that can essentially, you know, rebuild the signing or decryption key.
Yeah, I mean, right now you pass a cryptographic signature with your request to the lit nodes. So that could be a signed wallet message. like if you want to prove something about your wallet. It could be any other cryptographic signature. So it could be, you know,
You need some encryption, right? Because like you need to keep this.
You don't need encryption.
private.
Just a signature, and the nodes verify the signature. And by verifying the signature, they can prove that you own that wallet.
Yes, but they're going to send you in exchange like a key share, right?
Oh, yeah. They don't actually send a key share. They send a decryption share or a signature share. So the key shares themselves never leave the node.
Got it. Okay. I think that like I misunderstood this part. And so the second question that I have is essentially like, can you do any form of resizing of, you know, this, I wouldn't call it like a quorum, but like, you know, just this set.
Oh, like changing the set of nodes and changing the threshold, for example?
Exactly.
Yeah, absolutely, yeah. So we use a technology called proactive secret sharing. And what that lets us do is it lets the nodes, like new nodes, join and leave the network and keep the underlying secret the same, but the private key shares are incompatible between like epochs, when nodes leave and when nodes join.
Basically, this process of proactive secret sharing is quite similar to the distributed key generation process. And you know, the secret is very, very simply put, right? A line on a graph. And in this key refresh process, you're assigning new points along the same underlying secret, such that the shares in epoch 2 are incompatible with epoch 1, but they still represent the same underlying secret. And that's functionally the goal of this network, is to persist a shared cryptographic secret in perpetuity.
Okay, I think that ties into my third question, which is how do you ensure kind of like the, you know, any form of like nonce or like counters so that you know essentially like the number of time that this thing has been signed or like decrypted. Maybe you want to like ensure that like, you know, you can decrypt it X amount of times. You don't want to, you know, you may want to like sequence essentially, especially for vaults, like operations, right? Like the signing of like specific nonces or like just ensuring that like you don't have essentially just like re-signing operations with different nonces either. I'm actually curious, how do you think about that?
Yeah. So what you could do, so the lit nodes themselves are mostly stateless.
Okay.
So they don't necessarily have a place to store anything like that. But what you can do in the lit actions is you can read and write from blockchains or from IPFS or wherever. So you could, like, at the end of a lit action, after you create the signature share, you could write to a chain to record that a transaction has already happened. And then if somebody tries to run that lit action again, it could, you know, check and see, like, you know, did this transaction already happen or not? And if so, it wouldn't sign. And that's like how it works within the lit system. Within, like, you know, if you're signing an Ethereum transaction, for example, right, you would just include the nonce in the thing to be signed when you send up like whatever you want to the lit action to be signed. And so then you couldn't reuse that signature, right, because it has already been broadcast with that nonce.
Okay, that makes a lot of sense. Thank you so much.
Yeah, thank you.
Great questions.
Yeah, great.
There's more questions in the front here. Give us a moment to come to you. And you're not forgotten. No.
Maybe I missed how you explained how to create a PKP without any keys, but how does that work, and how does the user not have a key, and how do they authenticate what things they want the network to do?
Yeah, I mean, they need some kind of key, right? It could be an Ethereum wallet, or it could be like Apple Passkey, which is like one click, and they generate a public-private key pair for you that's backed up to your iCloud in an encrypted way. It could also be like potentially a Web2 auth method, like Discord login, anything like that. It just needs to be basically an authentication method that can be verified by the lit nodes. Yeah.
Cool. I have an additional question. Every time someone creates a PKP, do you generate a new threshold key? And
Yes.
where is that key stored? Are you spinning up new cloud nodes to store those keys?
So the lit nodes, each node stores multiple key shares. So if there's 1 million keys on the network and 100 nodes, each of the nodes would store 1 million key shares, representing 1 share from each of the underlying cloud wallets or cloud keys.
Cool. And what kinds of thresholds are you guys using in production, in test?
Like the number threshold? Like,
yeah.
We're using 2/3 right now. And that's like hard coded across the network, so it's not user changeable. Yeah, and we're using ECDSA, non-interactive signing on the signing side, and then on the encryption and decryption side, we're using BLS keys.
Super.
We have some more questions in the middle area still.
Do you mind if I have one more question?
That's the 4th one, right?
Super. What are your plans for decentralization, and how do you plan to grow this network? It sounds like it's a pretty fixed set, and you do no rotations.
Well, so there's this notion of the proactive secret sharing, which is not quite a rotation because it's the same underlying secret. But yeah, some of our cutting edge work is right at the notion of changing the threshold, which just makes the network be able to become like more dynamic over time. But currently there is the capacity for new nodes to join the network and for the key to be refreshed, creating those new shares in epoch 2, 3, 4, and so on. And then practically in terms of the plan, by the end of the year, this network will be up with a handful of named node operators, and then those node operators are functionally a DAO of sorts that decide who comes in and who comes out to the system.
Okay. There was a final question in the middle area. Someone already raised their hand?
Yes.
Let me see. We're looking up. Someone had their hand up in the middle for the final question? Time's up? Time's up? Okay. In that case, Chris, David, thank you so much.
Thanks, everybody.
Give them applause. Okay. And now, we're going to talk about Python. We will have Mark Garreau, who will join us, and we're going to talk about a little-known thing called web3.py. And he is standing ready. Let's welcome him to the stage with an applause, please. Yeah.
Cool. Thanks. Ooh. Oh, already went forward. Figured it out. Happy day 2. Feels like week 2, am I right? All right. Everybody need a big breath? You do. I think it's important to start with the why question. So besides selling JPEG monkeys, what are we all doing here? I think we've reached a critical mass, or we've gathered a critical mass of people here that actually believe we stand a chance at re-architecting, rethinking, and even adopting some core level systems that we rely on, things that touch on our governance systems, our financial systems, and some of our social coordination systems, so how we work together. I think our window of opportunity is unknown, so ultimately we should seize on that while we've got it. The success of Ethereum and decentralized technologies is, or perhaps should be measured in terms of adoption. And by adoption, I think that at least a couple of the things that move the needle most are, number one, that we're solving real problems, and number two, that we are providing powerful and accessible tools for people to solve real problems. And my thesis here is that the latter comes first. In that, it is unlikely that one dApp will solve all the world's problems or one sphere of the world's problems, right? So by putting powerful and accessible tools in people's hands enables them to solve their problems locally. And so that's where I think I can move the needle anyway. So this is sort of the framing for this talk. My goal is to increase awareness of a set of Python tools, some best practices, and some other projects that I think you might benefit from being aware of. Sort of the template for this talk is that I'll give you just enough information to know whether you want to learn more about it and point to somewhere where you can learn some more. So this is a blog post I wrote about a year ago now that I think is still relevant, that digs a bit further into this call to action. So this is meant to be beginner-friendly, sort of a series of lightning talks smushed together. Sound good? It does. My perspective is informed by 5 years at the Ethereum Foundation, thinking a lot about what it takes to get people to adopt this technology. Starting on the Mist browser team, where we produced one of the first UIs for Ethereum. When we sunset that, the team moved over to do some UI experiments on configuring and running Ethereum clients, called that Ethereum Grid. And a couple of years ago, I pivoted to the Snake Charmers team, the Ethereum Python team, where I write some code, but also prioritize creating education content. In the last year and a half, my life has done some zigging and zagging. My wife and I welcomed triplets into our family, and then while I was on paternity leave, I helped establish Developer DAO, which is a very reasonable thing to do. I'm excited about Developer DAO because it's sort of this hive mind of bright and passionate people, all sort of focused and digging into this solving challenges of adoption. I'm proud to be part of this Ethereum Foundation Python team. We are a small team, and most of us will be hanging out at an Impact booth hub for a lot of the day tomorrow. So if you want to come say hey, meet some of the team, and get some very exclusive Snakey McSnakeface swag, come find us there, come hang out. We just welcomed our 5th teammate this month, Linda. So hi, Linda. Welcome to the ruckus. I'm going to take a moment to burn a couple seconds of time here that I don't really have to say that this is like a full circle moment for me. When I joined the EF in 2017, my first DevCon was in Cancun, Devcon 3, and Ev Fraga is in the audience, who was on stage giving a shout out, or like giving the talk for the Mist browser team, and he gave me a welcome shout out. So it brings me joy to make this a newfound tradition. Quickly, the EF Python team manages or maintains about a dozen Python libraries, most notably Web3Py and PyVM. The rest sort of roll up into those 2 libraries, or help make those 2 libraries work. A shout out to our open source community of contributors. They also help things move along here, and shout out to the Snake Charmers who've come before us that kicked off essentially all of these libraries. So let's get to Web3Py then. Starting with the why question again. Why does Web3Py need to exist? And the same question is applicable to Ethers.js, Web3.js, and language, libraries in other languages. The short answer is because JSON RPC exists, or more specifically that the execution clients in Ethereum speak JSON RPC if you want to communicate with them, you have to speak their JSON RPC standard effectively. So in a command line, if you want to make an ETH call request to an Ethereum node, might look like this, where you've got a stringified JSON object that you're passing along. The Ethereum client comes back to you with this bit of this blob of data, which is then up to you to decode and make sense of. Web3Py and similar libraries give you like a human readable interface for this, so you make the request for whatever it is you're looking for, and ideally you get back exactly the data you're looking for. For the deep dive into what happens under the hood there, I've got another blog post for you. Check that out. So what might you know Web3 for already? In order to communicate with an Ethereum client, you'll have to configure a provider. This is your friendly reminder that the most secure way to do this is to run your own node on your own machine and connect to it via an IPC socket. We all know well that this is an unreasonable ask for most of the Ethereum community, so I'd like to plug here another project to keep an eye out on. The Portal Network is, there was a great talk given yesterday by Piper Merriam about the Portal Network, what it is, how it works, what the progress is. The idea here is that there is a fundamental redesign of the peer-to-peer protocols to actually allow light clients that are light enough to run in your consumer-grade hardware, so your laptops, your Raspberry Pis even. That's in flight. There are 3 clients that are being implemented, and the spec is effectively done already, so hopefully coming soon. In the meantime, use your HTTP or WebSockets providers as needed, and once connected to your node, you can do various things like look up account balances, convert between Wei and Ether, send Ether from one account to another, deploy contracts, interact with deployed contracts, get block data or transaction data, and then watch for events as they occur on chain. That was intentionally quick. If any of these concepts are new to you or you're new to Ethereum in general, then welcome to this weird and wonderful world. And our docs are fairly good, but I've also written a couple of introductory blog posts that will hopefully make these concepts a bit easier. So, what's new? A lot of work has gone into making async functionality just plain work in Web3 this year. We've started with the HTTP provider because that's where the biggest bang for the buck is. This is available today in beta versions of Web3 Instantiating or like configuring these new providers is a little bit more verbose, and that will improve over time, but you're welcome to use it already. So very quickly, like an example of what some Python or asynchronous Python code might look like. In this example, we're just grabbing the first 50 blocks from the Ethereum blockchain using async IO's as completed method. So as each one of those requests goes to your remote node and comes back, we just print out the block number that was received. So you'll get it in this case, a fairly random order. The takeaway here is that if you spend a lot of your application doing read operations, you, in particular, to and from a remote node, you can see some massive performance improvements, like in the neighborhood of 10x. Moving right along. ENS support is not new to Web3 but it's gotten some love in the last year. So you might know it best for looking up its read operations. So looking up the address for a name, resolving a name from an address, or getting some arbitrary text that ENS allows you to store as part of your record. New this year is async support for ENS. So if for whatever reason you want to fetch the address of Shaq, Vitalik, and Paris Hilton in 30 times in rapid succession, you can see some massive gains in performance here. Same async IO as completed code sample there. That's the takeaway. Your gains might be even more significant than the standard Web3 methods. Let's get a little weirder. Web3 introduced support for CCIP read functionality. So this EIP was introduced by Nick Johnson of ENS. CCIP stands for Cross-Chain Improvement Proposal, and read alludes to you're reading some data on off-chain or otherwise not on Ethereum mainnet. So this EIP introduced a standard for contracts to let the user know it's going to fetch some data from somewhere else other than mainnet Ethereum. The simple version of how this works or what this introduces is just a pattern for using a custom solidity error to return some metadata. And of note, you can include one or more URLs where that off-chain data can be fetched from, and then a callback function for where that off-chain data should be returned to be verified as authentic, essentially. This diagram is included in the EIP, and we're going to use it as a quick example of what this looks like in practice. So the use case we'll chat through is ENS placing some, or their, let's say ENS is, some subdomain is registered on a layer 2, like Optimism. In our case, the client is your Web3 script or app. We will be making some func in this case is looking to resolve the domain or the subdomain of an address. The contract is an ENS resolver contract that says this value does not live on mainnet Ethereum, but you can find it on off-chain somewhere at this Optimism gateway, for example, and that information is packaged up in this off-chain lookup revert message. So under the hood, without the user having to know this is even happening, Web3 Pi will go and make a GET or POST request to that Optimism gateway, get that address back, and then pass the relevant data to the specified callback function. The callback function within the same ENS resolver contract then reads the signature, verifies that this address came from a source that it trusts, and sends back along the answer to Web3 Pi. So from a user standpoint, this looks dead simple, right? You are just looking up the address for a name, and you get a value back. And this address might actually live on Optimism, on another L2, on somewhere else entirely. So just for context here, ENS had to implement a protocol change of their own to support this functionality called wildcard resolution. If you're interested here, they've got a full open source example of their resolver contract that supports this functionality. Also of note, Nick is giving a talk directly after this one, and I believe he's digging in a bit further into CCIP read functionality. Cool little update from last week. The Lens protocol folks announced that they're going to be using the same feature set to supply social graph data from their protocol via their own ENS resolvers, I guess they're running. If for whatever reason this functionality introduces some security concern that is not compatible with your use case, you can fundamentally disable that at the provider level or at the the call level. And then again, for more information, go hang out with Nick or check out this blog post. If you are looking to do something outside of the normal scope of what Web3 Pi does, you have a few options. The first is middleware, and this is the most common tool you'll reach for. Effectively what it does is it lets you inject some behavior either just before a call goes out or just when it returns. So you might be using this for some special logging behavior, some data visualization, some additional like munging of data points or whatever your use case might be. It's pretty flexible. And then you inject that into what we call our middleware onion. Your next option is a custom method. So if you're using a client like Aragon or Otterscan, one of these that have some non-standard RPC functions, you can choose just to lump those directly into the the ETH module or whatever feels appropriate for you, and you can use some of our data formatters and call that just like you would any other ETH method. Also of note here is that you can use this to override any existing method in the module. So if you want to change the way that any call or getting of gas works, et cetera, you can essentially replace it with your own version. Your third option is external modules. This is intended to be plugin support. So if you want to include an entire API within Web3 Pi, a whole set of functions, you can do that via external modules. This is very flexible as well. You can, our only stipulation is that you create these as classes, and if you need to make use of the parent Web3 module, then you have access to that via the init method. You can nest these how you choose. I think that's all there is to that one. And fourth, custom providers. You're unlikely to reach for this unless you're creating something like a custom test harness, or you just need to fundamentally alter the way that every request is made. I'll leave that one there. Finally, I don't recommend it, but if you got to monkey patch things, do what you got to do. For more context on when you might reach for each of these, got another blog post just for you. We good? We taking breaths out there? All right, let's talk about the merge. As an app developer, what do you need to care about? The good news is that not much else, like not that much has changed here. So a couple things. We said goodbye to some test nets. Goerli is still a good choice. Sepolia is still good as far as I know as well too. Block times changed. There's maybe a subset of applications this might be relevant for. Pre-merge, a new block was added to the chain on average 13 seconds with high variability. In our new world, we have a new block every 12 seconds even, with much less variability. And I think it might be useful to understand where that variability comes from by differentiating slots and blocks, if you're not familiar. So every 12 seconds, a new slot is made available, and a randomly chosen validator can then propose a block to fill that slot. And if a validator is offline for whatever reason, then we might miss that slot, and you're waiting for the next 12 seconds for the next slot to fill. So that's where your variability comes from. This happens very infrequently, but it does happen. Next, we've got block identifiers, or sometimes called block tags. So you might be familiar with latest or pending, or adding a specific block number if you want to specify when a particular ETH call is made. We've got a couple new ones now, safe and finalized. And the short version of this is that safe is going to give you a result that is based on a period where it is very unlikely for a block reorg to occur, and finalized is one in which it is extremely unlikely for a block reorg to occur. So based on your use case, explore those block tags. And finally, we've got the Beacon API, which has existed for a little while within Web3 Pi, but maybe it's more interesting to you now. There's nothing fancy here. It's a very simple wrapper around the Beacon node RESTful HTTP endpoint. HTTP endpoint. I don't know where the I came from. That's about all there is to that. Couple debugging tips. These both revolve around ETH call. I've prepared this little example scenario, but in the interest of time, I'm going to skip straight to the good stuff. What is ETH call? You might be familiar with it. You're probably more likely to use it as attached to like the contract object. So for example, if you're going to execute a function on a contract, you effectively have two options to do so. One is to call on that method, or transact. Transact will submit that application to the transaction pool to get picked up. But if you call, that simulates the effect locally. So that didn't feel like the perfect explanation, but let's see if we can get there. ETH call simulates a transaction in your local environment. So we're going to use it in isolation here to like highlight a couple of debugging tips that might help you out. The second parameter it takes, the first is the transaction. The second is that block identifier, and the default is latest, so you would play out a transaction in whatever the current state of the blockchain is. But let's say, for example, you wanted to find out why a transaction failed at some point in the history of the chain. So the revert reason is not something that's stored on chain, but you can get it by essentially replaying a transaction at the time it originally occurred. So in this example, we've got a transaction we're interested in. We build up a new transaction object to replay, and then we call it at that block number -1 to replicate the state that it was in at the time it occurred. And then you get that human readable revert message that you can then do whatever it is you need to do with. For some more detail here, another blog post, but that's not all. There is a third optional argument on ETH call, at least within Geth and Aragon and possibly some others, called state overrides. This can save you some serious development cycles if you need to get a contract in a specific state to perform whatever testing it is you need. For example, you need specific state values in that contract, or you want to even alter the bytecode a little bit or like the operations within some of the contract itself, or like undo a condition for which the contract would normally revert, just to see what would happen otherwise. You can override that in real time within the ETH call method. So in this quick example, I'm using the code or the example. Ooh. Hold, please. The beard is knocking off the tape. So in this example, we're telling ETH call that the contract that lives at this particular address, I would like you to replace its runtime bytecode with this altered version that I've made, this version that I'm interested in testing. And then we can run that, and in this example, we've got a successfully executing call in the last example that would have reverted. For more detail here, check out the blog. Finally, last chapter. We, the Python team, know that as time goes on, more and more of our users are going to be using our tools through one or more layers of abstraction, and that's a good thing. Specifically in mind are development frameworks that sort of package together a bunch of functionality that let users be super productive in a much shorter time. So I'd like to encourage you, if you haven't yet, to check out our friends over at Ape. They can be thought of as like a Python version of Hardhat, and they are, I think, more and more in the future, they will be our biggest, or they will be the biggest consumers of Web3 Pi as a vehicle for their users. So again, this enables our users to be more powerful, to do more, and to solve their local problems. So that's a good thing. So that's what I've got for you. We covered everything today. Show of hands, make it a little interactive. Did we touch on anything you weren't already aware of? Is there anything that you're ready to dig into a little deeper? That's like, for the camera out there, that's like 4,000 people that all raise their hands. That's cool. Cool, then mission accomplished. Again, the snakecharmers.ethereum.org blog is where a lot of this lives if you'd like to catch up, review on any of what we've chatted about today. And eso es todo. Muchas gracias.
We have room for some questions from the audience. We have one question per person. In the back, yes.
Hello. Just a quick comment in regards to the merge. Jeez. I believe it's important to recognize that in terms of slots and block times, there can be missed slots where the slot occurs, but there is no block. So the block time doesn't necessarily increase every 12 seconds. Just a comment.
Yeah, thanks for clarifying, though. I'm not certain I got the clarification. So a block, I think we're on the same page. A block can fill a slot every 12 seconds.
Yep. But it doesn't always.
Correct.
I'm afraid we had time for one question. That was it. I'd like to thank Mark. Everyone? We'll have to... I'd like to welcome our next speaker. Thank you. And for that, we'd like to call upon Kasper Schwarz-Schilling, who's getting ready, to talk about time in Ethereum, the implications of replacing our dear friend Poisson. Is he ready? He is ready. Give him a warm welcome.
Thank you. Yeah, that's kind of funny. Yeah? It's okay. Kind of funny that block times were just discussed previous to this talk. I'm Kasper. I'm with the Ethereum Foundation working as a researcher at the Robust Incentives Group. We kind of work on anything incentives, which is, in Ethereum's case, a good excuse to kind of look at anything you're really interested in. Incentives are all over the place. I'll be talking about time in Ethereum, and in particular, I mean, this talk title is a bit mysterious, so let me maybe a bit clarify what I intend to talk about. As you probably all know, in proof of work Ethereum, block production was a random process, aka Poisson process, hence the subtitle implications of replacing our dear friend Poisson, and which basically means nothing else that other than that at a constant average rate, a miner would find a new block. Sometimes it takes 3 seconds, sometimes 13 or 23, but on average roughly 13. And today in proof of stake Ethereum, as we heard already, blocks show up every 12 seconds, like clockwork. So there's no randomness in this round time. But block timeness doesn't necessarily, it's not necessarily 12 seconds. But so basically, this difference in randomness versus deterministic time may not immediately appear as a big deal, but it comes with some implications that I want to explore. There's some good and some bad implications. At first hand, it might seem that it should only or predominantly be good in terms of load balancing. The gas fee market should be a bit more relaxed, etc. But basically, in proof of stake, having these slots and a single proposer for each slot, we kind of give this proposer some kind of monopoly, guaranteed monopoly. And this monopoly power can kind of be at least skewed to some extent to the advantage of the proposer. If that doesn't make sense right now, hopefully it will at the end of this talk. So what the hell is time? Time is funny business, very confusing, at least to me. But when I talk about time in this talk, I don't intend to be clever or philosophical about it. I really just mean, how do we make progress in in our chain. In proof of work, this progress was random in time. Sometimes blocks come up very quickly after 3 seconds or 20 seconds, but on average 13 seconds. In proof of stake, it's constant, every 12 seconds, assuming that a block proposal shows up. And basically, when I talk about deterministic versus random time, I talk about how we make progress in our chain. That's kind of it. Now, how do we make progress in Ethereum today? It really is quite simple. We have this available chain, which we then try to finalize. But for this talk, we can safely ignore the finality gadget that lives on top of this available chain and just look at how the available chain grows. And again, we have this time unit called slots, which is 12 seconds long. And so every 12 seconds we slot. And so when the block proposal shows up, like here in slot N, we just chug along, people will vote for it, next slot comes along, we build on top of it, and then here we have this scenario that was discussed. If the block proposal doesn't show up, that's okay, the next block will just build on the previous block. Simple enough. But I want to kind of briefly touch upon where does this deterministic nature of time actually come from. And so basically, in any proof-of-stake system, we need a mechanism to select a proposer for a block from a set of bonded validators. And in proof of work, this is clearly happening randomly, just by nature of it being a race. Every miner tries to create a block, but on average, only one miner succeeded every 13 seconds, roughly, in proof of work Ethereum. And importantly, you don't actually know who will win the next round. In proof of stake, this random selection needs to be explicit. Now, clearly, there is no true randomness in a blockchain, since all nodes must come to consensus on it. And so different nodes calling random, a randomness function will just create chaos by basically outputting different results in each case. So instead, what we do is we generate pseudo-randomness on-chain from a seed that is computed and updated as part of the blockchain. And the challenge is basically to make this seed unpredictable. Now, for the purpose of this talk, we can safely treat it as a box and just pretend it works. It actually does. And so essentially what we do is we generate pseudo-randomness on-chain to assign and schedule duties. And this sequence of duties is scheduled deterministically. So we, as validators, we need to agree on a view of when duties are scheduled and also their time. And so in Ethereum, we chose this arbitrary parameter of 12 seconds as our block time. It's not completely arbitrary because obviously things like latency, etc., block processing are considered, but it could have been 11 or 13, and it would probably work just fine. Now, to kind of boil this down a bit more heavily, in proof of work, we are fed this exogenous randomness into our system, which gives us this random block time. And in proof of stake, we have to generate this on-chain pseudo-randomness, giving us this notion of deterministic time in Ethereum. And to make it even more blunt, basically you can think of proof of work as a continuous race. You never know who will win and when, could be anyone at any time. Whereas in proof of stake, we have this scheduled sequence of duties, and this difference here already implies what the core of the problem is that I will talk about. In proof of work, there's no notion of late, whereas in proof of stake there is. You can basically show up late for your duties, such as block proposing, and you can basically show up late, but early enough to still become canonical. And that's basically the wiggle room that a proposer has and can abuse. Yeah, basically this nice graph by Martin here, not sure if he's here, but I saw him earlier. Essentially, it's about block time around the merge. You can easily see here, yeah, in proof of work, obviously, you have this very large variance in block time, and as soon as we hit merge, we have this very boring, beautiful 12-second slot time, blocks showing up beautifully until there's one missed slot. So block time jumps up to 24 seconds once, but that's kind of it. Now, let's think about the implications of this deterministic time. And this plot really kind of illustrates it quite well, and I want to kind of continue on it. So Vitalik here notes basically, I'm actually in the way, am I not? Basically, it's immediately obvious that this block time is less volatile, and this less decreased volatility means that the gas fee market is more stable. And as Vitalik points out, basically, EIP 1559 works better since we hit the 2x gas limit of 30 million gas less often. And basically, removing this huge variance of block time leads to a more stable gas fee market with fewer people overpaying compared to when basically base fee hikes hits the limit every time there's a block that shows up after a long time in proof of works case. So basically, there's another tweet here by Barnaby, who's sitting right there. Basically, just visualized again. It's not as immediately obvious, but you can basically see the gas limit is not hit as often in the second half of the plot. And essentially, we can just summarize this as better load balancing. And I've now talked about transaction load balancing, essentially. But this really kind of translates throughout the stack on the P2P layer in terms of messaging load, etc. So there are huge benefits to this constant progress that we make in proof-of-stake Ethereum. But obviously, that's not the end of it. Otherwise, I wouldn't be talking about it, probably. Essentially, proposers can abuse their guaranteed monopoly power. And what I really mean is that, what do I mean by guaranteed monopoly? I mean that in proof-of-stake, there's only a single unique validator that has the right to propose a valid block in a given slot. And in proof-of-work, that obviously is not the case. And this guarantee, basically, now that we have this unique proposer that is allowed to propose a block for the duration of a slot, there's this leeway of timing your block that is possible. But before going there, I need to briefly introduce some Ethereum basics. Basically, a slot, there's several things happening. On the one hand, we have a block proposal. On another hand, we have a committee of attesters voting for what they consider as head of the chain. And then we have the aggregation phase, which we can kind of ignore, but it's just a way of efficiently packaging attestations so that we can actually fit them on chain. So the honest validator spec guide basically specifies that a validator is expected to propose a signed beacon block at the beginning of any slot, during which is proposer yada 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 returns true. So basically, if you're the elected proposer, propose a block at the beginning of a slot. So 0 seconds into the slot, ideally. Now, then the next phase is basically testing. And we have this attestation deadline 4 seconds into the slot, which basically the rule or the spec says attest as soon as you hear a valid block or 4 seconds into the slot, whatever comes first. So if the block's on time, you hear it after 1 second, you immediately attest to it. If you don't hear anything until 4 seconds, you attest probably to the previous block that you heard. And in order to know what to attest for, these attesters run our beloved fork choice. I see POTUS here. And basically, this fork choice rule is a function that takes as input the block tree and some previous attestations and gives you the head of the chain as output that you will then vote for or build on top of if you're a block proposer. So the fork choice is a flavor of LMD Ghost, which stands for latest message-driven greediest, heaviest observable subtree, which is a mouthful, but it really intuitively is quite simple. If you look at the block tree here, essentially, as long as there's no fork, you just extend the chain. And here you see the scenario, once we get to n+1, extending block n, easy, but then comes n+2, and for whatever reason, the proposer builds on top of n, creating a split in the block tree. Now, that might happen if the proposer was offline for whatever reason, but now basically the committee in n+2 has to make a decision. Will I vote for block n+2 or will I vote for block n+1? And the LMD ghost rule basically tells you to walk down the block tree and go down the heavier subtree, which means basically going down the path where more votes have been accumulated. And here you can see that block n+1 actually accumulated 100% of the votes in that slot, and so it's heavier than block n+2, and so as the committee in n+2, you will vote for n+1. And then n+3 sees these votes and makes a similar decision, and so basically n+2 gets kicked out of the chain. Now we have the basics, and so let's talk basically about what the proposer can do. I've mentioned it, it's basically about timing their block releases. And there's basically different notions of on time. Like, ideally, you release your block 0 seconds into the slot, then some like nodes will, on the P2P layer, receive them at different times, probably 1 second in, 2 seconds, probably everyone has heard it. But so as long as you hear the block 0 or 4 seconds into the slot, a block is basically considered on time in terms of attesting, because you hear about the block before a validator attests. So in this case, nothing really happens, business as usual. But the more interesting case is what happens if the block proposal is really late, say 11 seconds into the slot. Essentially, as you can see here on this diagram, you have this attestation deadline 4 seconds into the slot, and because they haven't seen a block yet, they will just vote for block n. Now, at some point, block n+1 comes along, and once we get to the next slot, block n+2 has to make a decision on what block to extend, on what basically to build on block n or n+1. You might think that n+1 shouldn't become part of the chain because no one actually voted for it, but in terms of fork choice, the weight of block n is actually inherited by block n+1, and so n+2 will extend that chain for a good reason, actually. So we have, maybe to go back, how does this, here we go. So what basically happened here? We have a very late block proposal, 11 seconds late. Why is this bad? This is bad because it's simply unfair to the next block proposer. Why? Because basically listening time to the transaction mempool is valuable. Transactions have transaction fees, priority fees, but obviously MEV dramatically increases this notion of unfairness in this sense that more listening time to the mempool basically gives you more transactions to extract MEV from, which basically means that if, as a block proposer, I only have 2 seconds worth of listening time that my previous proposer hasn't, that my previous proposer didn't have available to include in their block, I'm worse off. And so basically, anyone following the honest spec guide will actually have less MEV to extract. Now, that obviously can lead to centralizing effects that if you're not a sophisticated proposer, you simply earn less than sophisticated ones. So what can we do about it? Essentially, there's, I think, roughly 3 categories to think in. One is containing this monopoly power. Right now, basically, you can release a block at the end of the slot. What about making it so that we can kind of enforce a shorter time frame where block can still be released but become canonical? I will go through some things in a second. Another one is explicitly incentivizing timeliness. which we currently don't do in our protocol. And the third one is, I'm not actually going to talk too much about, but is trying to think about how can we maybe introduce competition to proposers again, in the sense of, right now we have this guaranteed monopoly, maybe there's a way the protocol can introduce some notion of competition where the proposer can't rest assured that they have 12 seconds to release their block. But that would require like fundamental changes to the protocol, and I'm actually not entirely sure if it even is possible in a world where we have attestations, thousands of attestations happening each slot. What can we do? There's some fork choice fun that we can do today. For reasons unrelated to this is proposer boost. Essentially, proposer boost is something that it's like part of the fork choice, where if you propose a block on time, the block will be treated as if it had already received 40% of committee votes. Basically, you have a head start in terms of fork choice weight, but only for the duration of the slot. Now, how can we basically use this to defend against this quote-unquote guaranteed monopoly? Here in this scenario, we see block n+1 is relatively late, around the 4-second, it's released around the 4-second deadline, such that some of the committee that votes doesn't hear it in time before they attest, and so they vote for block n, 70%, and 30% hear it before they attest, so they attest for block n+1. Now, block n+2 basically, with proposer boost, has an option. They can choose to either extend the chain by building on top of block n+1, or they can try to reorg it out by building on top of block n. And because of this proposer boost, we actually have the power, because 30% greater than 30%, you can basically overpower the block proposal of n+1 and reorg them out. And essentially what this does is it enforces a kind of soft 4-second deadline in terms of being able to release your block late while still becoming canonical. Because if you release at 4 seconds, attesters will have already voted, and you won't manage to accumulate at least 40% of the attestations. And some clients are actually starting to work on this. I actually saw Michael Sproul made a commit earlier, who unfortunately couldn't make it to Devcon this year. Fork choice fun that we can do tomorrow or in some time is basically a similar idea, block slot voting, where we also basically soft enforce this 4-second deadline. Here it works a bit differently. Essentially, what we're trying to do is that if I don't see a block, instead of just voting for block n, like I did previously, I basically vote for block n while also saying I want to vote and enshrine emptiness. So here what you can see is block n, you basically, in block n+1, you vote for block n with the information that this is from slot n+1. And essentially what you're doing is you're creating a fork that competes with this late block then. And you have the similar effect that now instead of the 60% voting for block n like on this side here, you have them vote on this kind of block, which is not a new block as such in terms of transactions, but it's just like saying, I want to enshrine emptiness. And now block n+2, the proposer runs the fork choice, sees 60 versus 40, and so they will vote for the 60%. Yeah, there is some nuance that I could add, but I think in terms of time, I need to keep going. Another idea that I mentioned briefly is that why don't we try to incentivize timeliness explicitly? Today, a block proposer is basically, they're rewarded in proportion to the profitability of attestations they include in their block. So basically, attestations that already exist, floating around, the fresher they are, the better, and so they are included. And these incentives are good because we need to make create incentives for them, for the attestations to actually land on chain, so that we have this notion of finality on chain. But why don't we try to incentivize timeliness? Now, the obvious problem is basically, what does timeliness mean in terms of on-chain? Like, how do we define timeliness on-chain? And an idea could be to scale the proposer reward by the share of same-slot attestations that the block receives and are included in the subsequent block. Now, that sounds more complicated than it has to be. Essentially, the idea is we have block rewards as today, and we scale them by the share of same-slot attestations. What I mean is, here in slot N, block proposer seems to be on time, such that 100% of the committee votes for that block. And so what we would do with this idea is we would scale them by a factor of 1, so nothing changes. You're on time, nice, good. Block N+1, on the other hand, seems to be slightly late. Only 90% vote for that block. 10% probably didn't hear it in time, so they vote for block N. Now, with this idea, what we would basically do is scale the reward of today by a factor of 0.9, effectively decreasing the reward. The idea is basically to punish people for being too late. Now, what I want to say is basically that it should be incentive compatible in the sense that the next block proposer is also incentivized to include these attestations on chain because they're fresh and so they're most profitable. And I don't see an immediate way to basically grieve one way or the other, essentially. The one problem that it does have is that MEV rewards may actually be able to dominate these timeliness rewards. That is probably, in some cases, always going to be true. But regardless, I think rewarding timeliness makes intuitive sense regardless of this problem as such. It just seems like it's a bit strange that we actually don't do it, in my opinion. And a spicy hot take that I don't actually personally agree with would also be something like, in a world of MEV smoothing, where we have an on-chain oracle of MEV, of the value of MEV in a given slot, we could think about using that oracle to scale timeliness rewards to ensure they are dominating MEV effects, basically making sure that the timeliness rewards are big enough to fight off any kind of MEV dynamics. But honestly, it seems like a dangerous path in terms of making consensus decisions on some oracle like that. Basically, in short, we can summarize this as load stability being a good thing and a guaranteed monopoly being a bad thing. Thankfully, we have things we can do about it. And things we can do today, things we can improve going forward even further. And yeah, I just wanted to kind of put this out there a bit more, and I will certainly be thinking about it more going forward as well. And yeah, thank you. And if any of these kinds of incentive games are of interest to you, then yeah, the Robust Incentives Group is actually hiring right now, so feel free to reach out and apply if you feel like it. Thank you.
If there are any questions from the audience, now is your chance. Yeah, over here. Please talk into the microphone for the stream.
Thank you for the presentation. I'm just curious about the fork choice rules. Like currently, as a validator, I will either sign something or I will not if it's too late, right? But if we're looking at the PB proposal, there are some other states, right, where you will get like a 40% boost of the votes if you are enough in time. How do we deal with time actually being subjective to validators? As I understand, there's no global view of time of such granularity between the validators, and we have them globally distributed and latency and all that. Like, how does that not result in us getting a lot of chain splits?
If I understand correctly, yes, there's no global notion of time. It's essentially a local property of your node. And there needs to be some notion of being synchronized with your peers in that sense, yes. But it's a local property.
Okay, another one in front here. Over here. Yep.
Hi, thank you. So I had two questions. One was on one of the later slides about incentivizing timeliness, kind of reducing the reward for a proposer that proposes their block a little late. Why would we not give the subtracted reward to the next proposer, given that they were the ones kind of, I guess, robbed of some MEV opportunity? Is that kind of a problem of just you only have the current chain state and you kind of only go back to the one that already happened, or?
I didn't catch the last part. So you're saying, why don't we give the part that we subtract from the current proposer to the proposer of the next slot?
Yeah, to the child rather than the parent.
You mean, and the idea would be to basically, because the block's late but still becomes canonical, to kind of compensate for the lateness of the previous block.
Yeah.
Might be a fun thing to actually think about. I don't know. Yeah.
Okay.
I mean, to be honest, this is more of an idea at this point. It's not a formalized proposal, but it's more like putting out ideas of how to think about timeliness going forward. But
okay. And then one more question is to better understand why more validators don't propose their block late. Like, what is the additional incentive for proposers to propose their block on time? Like, we're discussing potential ideas for it, but I guess in the current state, why do more validators not propose late?
Good question.
Okay. Thank you.
Thank you, Casper.
Thank you so
for your
much.
presentation and answers. Yes. The next presentation will be the final one of today, so we will take all the time needed for the questions. We will have Corey Petty ready to tell us about how to ethically build public good infrastructures. Corey, can I invite you to the stage, please? Let's give him a warm welcome.
So those of you who are leaving, you at least got to see the speed run of the talk while he was answering questions. My name is Corey Petty. I'm going to talk about how to ethically build public good infrastructure, specifically focusing on the ethics. It's not going to be as many details. If you'd like more details on kind of our history and the current work we do at Status and sister organizations, I'd recommend watching Oscar Thorne's talk he did earlier today. So if you missed that, check it on the stream. But for those of you who are leaving, if you want a TLDR, assholes exist. Web3's main primitive is to minimize their influence on everyone else. That's the whole goal, I think, that what we're trying to do in building decentralized technology is mitigating those with power and their influence on those without it. And the ethics of building this stuff, this infrastructure, has a massive impact on our success in doing this. So the process of how we think about building these things and how we make decisions in the process of building these things tremendously impacts our ability to mitigate assholes. So a little bit about me. My name is Corey Petty. I said that at the beginning. I started out doing podcasting in early 2015 and research a couple years before that. Joined Status 4 to 5 years ago. It's a blur at this point, doing security research and security stuff across the organization. And since this year, I've moved into doing kind of coordinating all of the infrastructure projects, which we've recently expanded into. And you'll see kind of a start to that work in the later half of my talk. You can reach me in all these different things, corepetty.eth, on status, just search for Petty, and corepetty on Twitter. So, Status is an organization that's founded on a series of principles. We wholly bought into what we believe to be like the ideal Ethereum principles for building public good infrastructure. I'm not going to list them all, you can see them. And in some cases, these things are a little in conflict with each other, but as an organization that's founded on these things, they serve really, really, really well as how we argue about trade-offs when implementing things or developing things or trying to understand how we'd like to do it. And I'm going to do the normal thing where I give you the Wikipedia definition of something, and that's public good infrastructure. And that's a good in which all enjoy in common, in the sense that each individual's consumption of such a good leads to no subtractions from any other individual's consumption of that good. And this is Paul Samuelson. So we're trying to optimize infrastructure where it's not a zero-sum game. And someone can't take advantage of others, or in the process of someone being successful, it doesn't detriment the use or experience of someone else that has nothing to do with that work. But, as I said earlier, assholes exist. There are always people who seek to profit for themselves on behalf of others because they don't care or they don't know. And our goal, like I said in the beginning, is to mitigate that influence as much as possible. And I've come up with somewhat of a law. I'm sure this is something more general and formal somewhere else, but every community has assholes. There's always someone in a community that cares more about themselves than the others, is willing to do things for themselves to the detriment of others. And as things grow, the likelihood of these things also grow. And more often than not, these people are usually very loud. Now, what a community is as generic as you could think it would be. It's either a blockchain ecosystem, a government, your local meetup, your friends group, whatever. We all know kind of who this person is. And I imagine there's probably a lot of assholes in this building as well. So like, we all kind of get the idea. Here's some. This is an example of what the influence of power dynamics can have on a system in which it tries to mitigate it but doesn't quite successfully do so. And I want to make it a point that we're not seeking to remove power dynamics. That's kind of a natural thing across society. We're humans. The world is unfair. We each start off with a different set of circumstances, and we change differently. But we're really trying to flatten its effects. We're seeking to remove the ability of someone with asymmetric power to impact those without it. And this can be summarized by this kind of change of phrasing. We've all heard in the beginning of Google their phrase of "don't be evil." And we loved it. That's one of the reasons why I enjoyed Google in the beginning, was they had this kind of ethos and motto of like seeking to not try and take advantage of others in the process of building out infrastructure and serving people. And I have to give credit to Dr. Manib Ali for introducing this exact phrasing to me back in, I don't know, one of the early consensuses in New York. And what we're trying to do is change "don't be evil" to "can't be evil." Because we've seen what happens when the motto is "don't be evil." You have the option to do so. And you continue to have that option. You get to selectively choose when it's economically feasible for you to not be evil, or maybe there's a change of guard and everything that's set up that had that ethos changes when that new change of guard doesn't really quite care the way the original one did. So we're seeking to do this. Changing "don't be evil" to "can't be evil." Don't give people those options. And this is an example of when that fails. This is a MEVWatch.info, I believe. Yeah, I think so. And this is what's currently happening as the result of the sanctions being put down on Tornado Cash. Now, I'm not going to opine on the original picture of someone being held captive in prison for a long period of time. But what we can see is that Tornado Cash was sanctioned. The code was removed and put back on subsequently. But we're seeing OFAC sanctions having an impact on what we thought was censorship-resistant technology, where this is the list of all of the blocks currently done since the merge. And those of and if you look at the gray here, the gray is all the ones that are not using a service on the validators called MEV Boost, and those that are the ones that are the portion of those blocks that are OFAC compliant. They're censoring transactions on the public public Ethereum blockchain in compliance with these tornado cast sanctions, and the ones that aren't. And I think if you look at that, it ends up being quite a bit. So 32 of all transactions being put across the blockchain network are OFAC compliant. And if you look at just the ones run through MEV Boost, the massive majority of those are. So we're seeing censorship at the base layer. And this can only be done because we can see what those transactions are. And you're able to make a distinction and do transaction ordering because you're able to see those details. Now, that means you're given the ability, if I look back here, maybe, you have the ability to make a decision. You're choosing don't be evil and not can't be evil. So it's showing that we need more privacy and censorship resistance. Well, I'll get to that in a moment. Don't know why that moved. Yeah, so we're seeing that we need more privacy and censorship resistance at lower and lower layers. If we can't just do everything on the blockchain layer and then ignore it on the ones below. And if you looked at the talk before this, you see that that's a really hard problem to solve. There's a lot of trade-offs and difficulties you have to do to try and figure out what is good behavior and how do we make the appropriate trade-offs to then maximize that, right? So I'm going to take a slight turn here to talk about kind of how you can maybe think about structuring this argument and where it actually comes into place when you're making decisions on how to build infrastructure and where you need to focus your principles. So I keep coming back to this phrase, the medium is the message, and it's a general idea that the technology you use, the medium, has a drastic impact on your ability to convey a given message. When we try to put something out, some idea in the world, we think about it in our heads, we form it in some way, and we send it out into the world via some technology or formalism or whatever, and it's up to the receiver to decode that appropriately. And it's also, while in transit, potentially being manipulated. And that's where a lot of that's coming in. I'll make kind of a case for that in a moment. But this wonderful picture by Monica in the crowd here is kind of like this example of what it looks like when you don't take this into account and you funnel everything, all human relationships, into a single medium in which kind of takes out all your optionality and how you can build things. So this is kind of like all of the complexity of human relationships and different things coming through what I would see a meat grinder where everything comes out uniform and the same. Currently, this is what I would consider centralized infrastructure, in which we try and take everything that we humans do to communicate and make digital relationships and lives, and what it turns out to be when we try and mimic that stuff in a digital environment. So, to dive into that a little bit deeper, there are three layers of any message. I want to try and explain what these are, and then point out kind of where the subtlety and the evil comes in. First, we have the frame message, which is the concept of giving information that there is a message. It says, hey, I'm a message, decode me if you can. It's the ability to identify that a message even exists for you to think about. And it implicitly conveys in the structure of this message. This is a book. So you know what a book contains a message. That's a good, decent example. And to understand the frame message is to recognize the need for some type of decoding mechanism. I've identified that there is a message, and now I need to find a way to decode it to understand what that message actually is. Next one is the outer message, which is the medium used to convey that message. This is how the message was sent out in the world. To understand this, the outer message is to build or know how to build the correct decoding mechanism for the inner message. So this is, I've identified that there's a message that I'd like to see, and now I need to understand that how can I take this message and understand what the intent of this thing is. And then finally, the inner message, which everyone kind of understands, which is the initial intent being conveyed in the first place. So understand this is to have extracted that meaning that was intended by the sender in the first place. Now, this is a overly simplistic model of what any message is, but it gives you a framework to kind of give you an idea of where things can be introduced and how to start trying to understand how you can mitigate these things. So if we think about blockchain networks as coordination mechanisms, we're using them as social layers to then, as I said earlier, mitigate assholes as best we can, and trust a system as opposed to humans to convey those interactions. And the interesting thing about them that's different from the internet is that they have real-world value, which attracts a lot of people to do things that are very greedy. So we have these beautiful cross-border, cross-jurisdictional attempting to be censorship-resistant coordination mechanisms that allow us to do all these things we couldn't do beforehand in a digital environment with digital relationships with real-world value. And if we think about that earlier framework of thinking about a message, it's really hard because it's layered in a bunch of different ways. If we look at the kind of stack, the very, very overly simplistic stack of what a blockchain network is, we have networking at the bottom. This is how messages get passed around, so then everyone who's contributing to these things kind of comes to agreement and has all the right data to figure out what's going on. They then go through the process of validating all these messages to say if they're well formed or someone's doing a double spend or they get dropped or whatever, and then construct them into blocks. And then we go through a consensus mechanism where we, as a distributed system, come to agreement like this is all the right one to then move onto from now on, right? And after that, we have to find some way of like extracting that data from this massive blockchain that we keep building. That's a lot of messages and a lot of different mechanisms which have what would be considered an outer message that needs to be interpreted appropriately. And based on anyone in this process's ability to understand that outer message and the powers they have in various places across the stack, give them the ability to change that message or censor it. And most of the time, when we're thinking about adding security or privacy, we're looking at the top two. In validation and consensus, we're basically just making sure it's correct. But what we're seeing now, we spend all our time on privacy and the retrieval and kind of, well, there's a middle layer with smart contracts and so on and so forth. We're seeing all of our time spending up here when things happen and the powers that be want to change stuff, they go to a layer above because we didn't necessarily think about it back then, right? So that's kind of an overview of like kind of how to think about public good infrastructure, its complexity, and a small example of, I don't want to say not thinking properly or building improperly, but like as this thing has grown and ossified, the interactions of not incorporating what I would consider the strongest point, the strongest principles that we set out to do, mitigating assholes properly at the lower layers. We look to scale things too quickly. And instead of providing what I think is a more fundamental requirement in order for self-sovereignty, and that is privacy, and censorship resistant, we're failing to do so now in the system that's actually being adopted by many people. So, quick history of Whisper and how we've moved from the Arlen relay and kind of statuses, and now back in Waku's attempts at trying to take infrastructure and grow it in the direction that it needs to grow while keeping all these principles aligned. Once again, there's a lot more details to all of this. I'd recommend reading the ridiculous amount of stuff we have online and watching Oscar's talk previously. Here's one tomorrow where he gives an awesome demo of what I'll get to eventually. Please show up for that. But this is the original Ethereum announced to the world. This is what the decentralized stack looked like, where you had smart contracts on Ethereum. We all kind of know what that is. And then Swarm and Whisper, which were the other two pillars of what a decentralized application was supposed to be. Swarm for file storage and Whisper for dynamic communications or ephemeral communications. And with a special emphasis in obfuscating the route of who sent a message and who's receiving it. We wholly bought into this as status. And we wanted to build an application. We wanted to be this thing that consumed these things so that people had access to it in resource-constrained or like areas in which only had access to low number of resources like the mobile phone, right? We wanted to increase the inclusion as much as possible while maintaining this high level of decentralization. And we had this concept of socioeconomic networks really, really, really early. You're seeing a lot of social token stuff happen. and kind of the idea of that Ethereum as a coordination layer. We're moving past this financial applications only situation. And so we incorporated Whisper. We used what was put out by Ethereum ecosystem. And we did it naively, I'd say. We used proof of work because that's part of it in terms of the anti-spam mechanism for messages being passed on the network. And we killed batteries and hid super hot phones. We used gossip and bloom filters for sending in MIDI, and we destroyed data plans for people, right? We tried to use this technology as best we could. And granted, it was a new technology, and we tried to apply it in a very extreme place. And then for discovery, for finding peers, and we had based on the high churn of people's mobile devices popping in and out of places or turning them off and so on and so forth, it's really hard to get good message reliability. And so what did we do? We took ownership of it because Whisper wasn't being developed and applying resources. They, reasonably speaking, had a tremendous amount of work to be applied to just fixing and making the blockchain scale itself and solving those problems with what resources were available at that time. So Oscar wrote a blog here, long end. We decided as an organization to take ownership of this and introduce Waku, which was a fork of Whisper. And we tried to make it a little more scalable, a little more usable so that status applications, the users of the status application could have somewhat of a reasonable user experience. So we attempted to patch Whisper for our environment, took responsibility, and applied attention to our required infrastructure. And we did this in an open way. We created VAC, which is a separate organization, to focus and research and study on trying to grow these things in a manner that's appropriate with the principles I talked about in the beginning. And for all of these things, you can see out in the open, we try to make open specifications that anyone can use. Whisper, or Waku, is for everyone. We're taking opinionated versions of it and applying it in contexts we think is appropriate. But it's for everyone. A public good is not to be owned by a given organization and used at our discretion. So we publish all these things at rfc.vac.dev, join, opine, contribute. But we had issues. We had spam. For those of you who've used status in the past couple years, and you go to maybe the status channel, you're going to see a lot of this. Why? Because we had no incentives. We took away our ability to mitigate some of that with proof of work because there are a lot of other issues with using proof of work for spam mitigation. But we had a problem. What could we have done to fix this? We could have offered up a lot of centralized solutions by looking at IPs and banning them or running things through our servers and censoring things appropriately, but we tried to stick to our principles of what a real decentralized stack should look like. And it was painful. But we had a scaling problem too. We had multiple problems simultaneously. So what did we do? We chose a plan for Waku 2 because the way Whisper was built was fragile and couldn't scale, and we realized that when we tried to fix it. So we wrote it completely from scratch off of libp2p and called it Waku v2. That's why we call it the spiritual successor of Whisper. So what do? We did a complete retooling of a private decentralized generaling messaging stack on top of libp2p. It's modular so that users trying to use this stuff for a specific context can make the decisions that's appropriate for what they're doing. Whenever you try and make a completely generalized solid framework that isn't flexible, you're going to optimize for no one. But if you will provide a suite of protocols that work well together and a way for them to interact together, then you can hopefully build multiple solutions that optimize for multiple applications. And it's open, once again. It's built for generalized messaging. It's not just for status. That's one of the applications we use it for. We can use for things based on what choices you make in the suite of protocols. Still spam, right? Still got problems with spam. We just dealt with scaling and getting people to use it and understanding that there's a lot of different ways you can do generalized chat, and we're not going to tell you how to do it. So, in order for keeping with our principles, we decided to build what's called the RLN relay, and that is a privacy-preserving spam protection that leverages zero-knowledge proofs, Smear secret sharing, and some economic disincentives. This is built on Waku v2 relay, and this is I'm not going to go through the overview. I don't have much time, but it's a really interesting way of using novel cryptography and very well-known cryptography in a unique combination of allowing people to contribute to a network and be removed if they do bad behavior without having to reveal a lot of PII information about themselves, and so on and so forth. So we stuck to our principles. It was painful along the way, but we got to a unique solution that I don't think ever would have gotten to, or maybe much later, had we just, compromised those things and moved on to some other way. All of the specifications, once again, are at rfc.vac.dev. You can see the papers of these things. I'm sure there's links on vac.dev, but you can find them here. It's easier if you just go to the website and click on it as opposed to writing it down now. Go play with it, tell us about it. We have a lot of different other research along the way. Once again, go see Oscar. You can see a live demo of this type of thing. Live? A video of a demo of this type of thing tomorrow. And so once again, wrapping up. So our principles are a priority, right? In order to do what I would consider public good infrastructure, you need to publish openly. You can't do things in the dark, especially when it's a digital permissionless system. You can't have trust in things if you don't know how it works. And these things should be community-based. So publish openly, implement, iterate. The concept of using old tools will lead to old solutions. If we would have compromised on our principles and done things to make status scale and kind of soar quickly, we would have just ended up with the same stuff, the same shit we have today. And that's not why we're here in the first place. Assholes are everywhere. And think about that. Think about how they can manipulate the intended messages that you're trying to send out in the world. Where can they understand the outer message of what you're trying to do, manipulate it, and change that message such that the receiver either can't get it or get something wrong? And in general, I think it's important to finish on, we should be conforming technology to relationships we're trying to have with the people we're trying to have them, and not the other way around. And we're building a lot of this. We've since expanded the organization substantially to start growing infrastructure. And we want to do that with as much of the principles and ethos that we started talking about in the beginning. And that's collectively built distributed access, specifically network level privacy. You can't have censorship resistance if people can see what you're doing, so as much privacy as possible with selective disclosure in the right places. Heterogeneous multi-chain network. You need the right to exit. You shouldn't be beholden to a single place in which you shove things and then rely on them to work appropriately. Native, private, public smart contracts. Once again, privacy at all levels of the stack. And as much as we possibly can, optimizing for resource-restricted devices, because you can't be inclusive if people can't get access to the devices that are required to use your software or hardware or whatever. So this is what we're doing. There's a lot of work to be done, and we're hiring. This is a QR code to go to a lot of the jobs that we've posted currently. Keep track of it. There's going to be a lot more. Thank you. And since we're the last ones, we have a lot of questions. Plenty of time for questions. I'm happy to take them.
Yeah, take as much time as you want, Corey. Yeah. We're looking, are there any? I'm looking, there's a question over there.
Hey, great talk. Allow me to stand. So I was curious, you talk about your principles, and it seems like first and foremost, privacy is at the top of that stack. I think there was like an implication about the morality of the OFAC sanctions, like in the validators, which seems to imply that privacy is paramount above the other principles that you try to present as like what is ethical for status. That's not a judgment. That's just, I'm just trying to say that. The question is, how do you prioritize the principles against each other? I mean, you talk about inclusivity, like with the resource limited devices, and then how do you, ask your community to input their opinions about like the priorities of those principles? So in designing, the future of status, like what sort of processes do you use to get feedback on those principles?
Good question, actually. It's really, really, really hard. First off, I think it's that, and Oscar's talk, you mentioned something that I like repeating and I like saying a lot because it really tells kind of how to, like, a general idea of how to frame these things. And like, because at the end of the day, there's a lot of principles to uphold, right? A lot of ideas we want to try and do simultaneously that in some situations, in a lot of situations, come in conflict with each other. But you can't build a decentralized framework on top of a centralized foundation. But you can do the opposite really easily. Coinbase is a wonderful example of that. And so when you're thinking about having one of these arguments and trying to come to a priority, which is going to be context specific, you need to try and see what's most important and what removes your ability to have that decentralized foundation that can be compromised with at a later place. Because we don't want to make decisions for other people. So how can we make the most generalized way that people can make decisions for themselves and build appropriately for their context? So that means privacy is very strong because you're not revealing information until you need to. But if you're not private, you're automatically giving all that information away, which allows people to make decisions, which doesn't allow people, you can't add, it's so much harder to add privacy later. It's the same thing. You can't build private solutions on top of public solutions. There's always going to be a way to remove that privacy to layer below and go after it, right? And I think one of the examples I've heard recently is from our founder is say you wanted to build a limited liability DAO. And how can we do that today? I don't think so, because if you make a vote on a specific proposal and someone doesn't like it, they can still see who voted on it and the whales and go after those. So there's no removal of risk in the process of contributing to something like that, because they just go after you. And you can, the lower you go, the more often that happens. So it's kind of long-winded answer to your question. You have to try and have arguments that move towards a direction of what constraints are we applying now that are going to have implications in the layers above, and is that in line with the people's ability to make decisions for themselves?
Thank you. Is there a next question? Otherwise, I have one actually. You mentioned you can build private solutions on public infrastructure. I'm wondering, what's your opinion on rollups then, and ZK applied?
They are beholden to whatever constraints that Ethereum gives them. They don't have a lot of power in themselves, and I really don't enjoy, although zero knowledge is wonderful, it's currently being used for compression reasons, and there's no privacy there. And once again, same thing, you're just even higher above the stack. Since you're publishing all that data to the blockchain in a non-privacy preserving way, it's not doing anything, it's just a scaling solution. So it's adding additional constraints that will eventually be subject to the same censorship resistant, non-censorship resistant that we're seeing today. But that being said, it's awesome. There's a bunch of really cool technology being deployed and very, very novel advancements in cryptographic primitives that will be useful for scaling and adding privacy-preserving solutions in different ways in the future. So I'm happy we're able to start to serve the amount of people that starts to compare to where we set it out in the first place, of blockchain serving the world. But if we keep moving in this direction, it may become so ossified that we can't make solutions that keep it from being censorship resistant, which is what I said in the first, because the whole point of all of this, if we build blockchains that are not censorship resistant, then we didn't do anything we set out to do, other than making, I don't know, digital fund money.
Thank you. Anyone else? If not, I'd like to give the biggest applause we have of the day, because it's the last speaker. Corey, thank you so much. And I'd like to thank all of you for coming, and I'd like to hope to see you tomorrow again. I would say enjoy the rest of your day and go grab some dinner. Thank you.